Hello everyone and welcome to this video on the DevOps Full Course by Edureka. DevOps is a way to bring together development and operations teams to make software delivery faster and more reliable. By encouraging teamwork and automating tasks, DevOps helps companies release updates quickly and with fewer errors. Practices like continuous integration and continuous delivery keep software ready for development at any time. DevOps ensures that changes can be made swiftly to meet customers' needs with maintaining stability and security. It's an essential approach for any organization looking to innovate and stay competitive. With that said, now let's outline today's agenda for this DevOps full course. First, we will give a brief overview of DevOps, laying the foundation for your understanding. Then, we will explore version control by exploring Git, including its installation and setup. Next, we will introduce GitHub and learn how to use this platform effectively. We will then move on to CI/CD pipeline, a practical and essential aspects of DevOps. We will then understand what Jenkins is and go through the Jenkins files, the installation and the setup procedure, equipping you with the skills to apply this knowledge in real-world scenarios. Afterwards, our focus will shift to DevOps tools such as Docker, Kubernetes, Terraform and Ansible, which empower teams to automate, accelerate and collaborate in the software development and deployment journey. We will also explore AWS DevOps, where you will gain expertise in building CI/CD pipelines on Amazon Web Service. Additionally, we will dive into Azure DevOps and its key components. Then we will compare DevOps versus Agile. As we conclude this course, we will go through the DevOps roadmap and share essential DevOps interview questions to help you succeed in DevOps interviews. But before we begin, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, visit the Edureka website for the DevOps Engineer Master's program, the link to which is in the description box below. Now, without much further ado, let's get started with our first topic, Introduction to DevOps.
What is DevOps? DevOps is basically a combination of two words, development and operations. So what do we get when we combine these two? Simply speaking, DevOps is a culture that implements technology in order to promote collaboration between development and operations team to deploy code to production faster in an automated and repeatable way. The goal of DevOps is to increase an organization's speed when it comes to delivering applications and services. Many companies have successfully implemented DevOps to enhance their user experience. Let's take for example, Facebook's mobile app, which is updated every 2 weeks, effectively telling users, you can have what you want and you can have it now. Ever wondered how Facebook was able to do this so smoothly? It's the DevOps philosophy that helps Facebook ensure that its apps aren't outdated and that its users get the best experience. Facebook accomplishes this through a code ownership model that makes its developers responsible. That includes testing and supporting through production and delivery for each kernel of code they write and update. It's through policies like this that Facebook has developed a DevOps culture and has successfully accelerated its development lifecycle. Industries have started to gear up for the digital transformation by shifting their needs to weeks and months instead of years while maintaining high quality. As a result, we will soon see that DevOps engineers have more access and control of the end user than any other person in the enterprise. So what are you waiting for? Don't be in the sidelines when that happens. To master your skills, enroll in Edureka's DevOps certification program and become a leader.
We have just introduced DevOps and its importance in software delivery. Next, in What is DevOps module, you will learn the key concepts and benefits of DevOps.
Now let's find out what exactly is DevOps. So DevOps is a set of practices that aims to automate and integrate software development and IT operations processes. The term DevOps is a combination of development and operations, reflecting the collaboration and communication between these two traditionally separate teams. The infinity symbol is often associated with DevOps as a representation of the continuous and iterative nature of the DevOps lifecycle. DevOps is a holistic approach that aims to develop a culture of cooperation and continuous improvement while automating procedures. The end goal is to deliver high-quality software faster and more reliably to meet the demands of today's fast-paced digital landscape. In 2008, the term DevOps was officially coined by Patrick Debois, a Belgian consultant, and Andrew Schaffer, a system administrator. The concept of DevOps emerged as a response to the challenges and inefficiencies that arose from the traditional approach to software development and IT operations. How is DevOps different from traditional models? DevOps differs from traditional models of software development and IT operations in several key ways. Traditional models often involve separate and distinct phases for development and operation, with less emphasis on collaboration, automation, and continuous delivery. Here are some of the key differences between DevOps models and traditional models. Development and operations teams often work in separate departments, leading to communication barriers and delays in the software delivery process. DevOps focuses on collaboration and communication between the operations team, development team, and other stakeholders. Teams work together throughout the entire development lifecycle, fostering a culture of shared responsibility. Traditional models rely heavily on manual processes for tasks like code deployment, testing, and infrastructure provisioning. This manual approach is time-consuming and is also prone to errors. DevOps advocates for automation at every stage of the development lifecycle. Automation tools and scripts are used to streamline and accelerate processes, reducing the risk of human errors and increasing efficiency. Traditional models often follow a waterfall model with sequential phases. Changes are not frequently released, leading to longer development lifecycle. Whereas DevOps embraces continuous delivery, where incremental changes are delivered frequently. This enables organizations to meet customer needs, release new features, and resolve problems more quickly. Traditional models involve manually managing and configuring infrastructure, which can result in inconsistencies and difficulties in reproducing code environments. Whereas DevOps utilizes infrastructure as code principles, allowing for the automated provisioning and management of infrastructure. This ensures consistency across different environments and facilitates scalability. For traditional models, testing is often performed in isolated phases, leading to delays in identifying and addressing integration issues. DevOps adopts continuous integration, where developers integrate code changes regularly, triggering automated tests. This helps identify and fix integration issues early in the development process. Monitoring may be limited and issues may not be detected until they impact users or systems, whereas DevOps emphasizes continuous monitoring to detect and address issues in real time. This proactive approach helps maintain system reliability and provides valuable feedback for continuous improvement. In summary, DevOps represents a departure from the traditional models by promoting collaboration, automation, continuous delivery, and a cultural shift towards shared responsibility. These differences enable organizations to deliver software faster, more reliably, and with greater adaptability to changing requirements. DevOps workflow. A DevOps workflow typically consists of several key stages, each playing a crucial role in the software development and delivery process. Here are 4 fundamental parts of a DevOps workflow. Continuous integration. Continuous integration is a software development practice that involves regularly integrating code changes from multiple contributors into a shared repository. The main goal of CI is to detect and address integration issues early in the development process, promoting a more collaborative and efficient workflow. Continuous testing. Automated CI processes are triggered whenever developers push code changes to the version control system. So CI involves building and testing the application to ensure that the new code integrates successfully with the existing code base. Continuous delivery is a software development practice that extends the principles of continuous integration to ensure that code changes are not only integrated and tested, but also automatically prepared for release and deployment. The ultimate goal of continuous delivery is to enable continuous and reliable delivery of software to production. Continuous deployment automates the process of deploying code changes to different environments such as development, testing, staging, and production. So CD pipelines define the steps involved in deploying applications, and they may include tasks like packaging, provisioning, infrastructure, and deploying the applications. Phases of DevOps lifecycle. The adoption of DevOps practices often involves a series of interconnected activities that span the entire software development and IT operations lifecycle. The DevOps lifecycle is characterized by continuous feedback, collaboration, and the iterative improvement of processes. Different phases of the DevOps lifecycle can be broken down into 8 C's. This is a generalized representation of various phases of the DevOps lifecycle. Plan. In the planning phase, development and operations teams collaborate to define project goals, set priorities, and plan the features and improvements to be delivered. This phase involves aligning development efforts with businesses, objectives, and determining the necessary resources. Code. The coding phase involves developers writing and committing code to version control systems. Collaboration and communication between team members are crucial during this phase. Continuous integration practices ensure that code changes are frequently and automatically integrated. Build. The build phase involves compiling the code, running automated tests, and creating executable binaries. This process is often automated through continuous integration tools, ensuring that the software is built consistently and tested thoroughly. Test. Continuous testing is an ongoing process throughout the DevOps lifecycle. It includes unit testing, integration testing, performance testing, and other tests to verify the functionality, security, and performance of the software. Automated testing is a key aspect of identifying issues early in the development process. Release. Making sure the environment is ready for the updated software to launch successfully is the main objective of the release phase. Deploy. In the deployment phase, validated changes are automatically deployed to production environments. Continuous delivery practices ensure that the software changes are ready for deployment at any time. Operate. The operations phase involves monitoring the performance and health of applications and infrastructure in real time. Continuous monitoring provides insights into system behavior, allowing for proactive issue detection and resolution. Automated scripts may be used to manage and maintain infrastructure. Monitor. Continuous monitoring and logging are essential for capturing data on system behavior, user interactions, and performance matrices. Monitoring tools provide visibility into application and infrastructure health, enabling teams to make data-driven decisions and respond to issues promptly. DevOps use cases. Companies across diverse sectors have adopted DevOps practices. It's important to note that the use of DevOps is not limited to a specific sector, and organizations of all sizes, from startups to enterprises, can benefit from its principles. Some examples of companies that were known for their DevOps adoption are Amazon. Amazon has been a pioneer in adopting and promoting DevOps practices, particularly within its cloud computing division, AWS, that is Amazon Web Services. Amazon heavily emphasizes on CI/CD practices to enable rapid and reliable software releases. Amazon adopts DevOps practices to enhance its service delivery and infrastructure management. Amazon employs a microservices architecture for building and scaling its applications. The company's success in delivering scalable and reliable cloud services is indicative of its effective adoption of DevOps principles. Netflix. Netflix is one well-known example of a company that has embraced DevOps practices to enhance its software delivery processes, ensure high availability, and provide an exceptional streaming experience for its users. Netflix has a microservices architecture where its application is divided into a large number of small, independently deployable services. This enables teams to develop, deploy, and scale services independently, fostering agility and ease of maintenance. Netflix is known for its 𝐂𝐝𝐿 and Simian Army tools, which are part of its 𝐂𝐝's engineering approach. These tools intentionally introduce failures and disruptions into the system to test its resilience and identify potential weaknesses. Netflix's success in delivering a reliable streaming service with millions of users worldwide is a testament to its effective implementation of DevOps practices. Google introduced the concept of site reliability engineering, which combines aspects of software engineering and applies them to infrastructure and operations. Google is a pioneer in containerization technology and is one of the main contributors to the Kubernetes container orchestration system. Google Kubernetes Engine is a managed Kubernetes service that enables the deployment and management of containerized applications. Google's DevOps practices extend to its data analytics and machine learning initiatives. Tools like BigQuery and TensorFlow are integrated into the development and deployment process for data-driven decision-making and machine learning model management. Spotify, a popular music streaming service, has implemented DevOps practices to enhance its software development, delivery, and operations processes. Spotify employs a squad model, which is a form of cross-functional team. Each squad is a small, autonomous team responsible for a specific aspect of the product. So this organizational structure promotes collaboration and shared ownership of the entire development and delivery process. Spotify follows Agile principles and Scrum practices for its iterative and incremental development. Agile methods allow teams to respond quickly to changing requirements and deliver software in small, frequent releases. Spotify's emphasis on DevOps principles has enabled the company to maintain its position as a leader in the music streaming industry. Microsoft offers an extensive range of tools and services under the umbrella of Azure DevOps. This suite includes services like Azure Repos for version control, Azure Pipelines for continuous integration and continuous delivery, Azure Boards for work tracking, and Azure Test Plans for testing and release management. Microsoft leverages Azure DevOps Insights for analytics and reporting. This tool provides visibility into development workflows, code quality, and release pipelines, enabling data-driven decisions and continuous improvement. Facebook is known for its rapid and continuous deployment of features and updates. DevOps practices, including continuous integration and continuous deployment, play a crucial role in enabling frequent and efficient releases. Feature toggles or feature flags may be used to enable or disable specific features without redeploying the entire application. This allows Facebook to conduct A/B testing and roll out features gradually. Now that we have an idea about what is DevOps and how it is used in the industry, let's move ahead with the roles and responsibilities of a DevOps engineer. A DevOps engineer is an IT professional who combines software development and IT operations to enhance the efficiency and teamwork of an organization's software development and delivery process. They should ensure fast, reliable, and secure software delivery. A DevOps engineer is responsible for creating scripts and tools to automate various aspects of the software development process, such as code integration, testing, and deployment. DevOps engineers frequently work with infrastructure that's managed through code and act as cloud architects. DevOps engineers also carry out quality assurance software testing to understand the effectiveness of various software tools. They put in place mechanisms to monitor the functionality of applications and gather logs in order to identify and fix problems. Let's move on to some essential technical skills required for a DevOps engineer. Version control. DevOps engineers must be proficient in version control systems such as Git to manage and track changes in code and configurations. Scripting and programming skills. A DevOps engineer must have a basic understanding of Linux fundamentals such as file handling, system administration, text processing, and process management. A strong grasp of programming languages is also important for automating tasks and building custom tools. Cloud services. A DevOps engineer should have cloud computing skills and should have an understanding of public cloud services such as AWS, Azure, or Google Cloud to deploy and manage applications and infrastructure in the cloud. Testing. Proficiency in automation testing is crucial as it guarantees DevOps engineers' ability to detect errors in software projects and products. Containerization. To deploy and manage applications effectively, a DevOps engineer must be familiar with container orchestration platforms like Kubernetes and containerization technologies like Docker. Moving on to the qualifications and certifications of a DevOps engineer. A Bachelor of Computer Science or a related degree that focuses on software development is a minimum requirement for a DevOps engineer. A postgraduate degree will be beneficial. Industry experience in roles that expose you to scripting and programming languages, cloud technologies, and experience in a leadership role may also be beneficial. Some in-demand DevOps certifications required for a DevOps engineer include AWS Certified DevOps Engineer Professional Certificate. So Edureka offers the AWS DevOps Engineer Certification training course that improves technical expertise in provisioning, operating, and managing distributed application systems on the AWS platform. Second, Certified Kubernetes Administrator. Kubernetes certification training by Edureka is curated by top industry experts and will help you clear the official Certified Kubernetes Administrator exam. So this Kubernetes training is live and instructor-led and helps you master key Kubernetes concepts with hands-on demonstrations, which in turn helps you become a certified Kubernetes professional. Microsoft Certified DevOps Engineer Expert Certificate. Edureka's Microsoft Azure DevOps Certification AZ400 course is curated by industry professionals as per the industry requirements and demands. This Azure DevOps training gives you a solid foundation to appear for the Microsoft Certified DevOps Engineer Expert Certification. Please check out the training courses offered by Edureka for these certifications. The link to these is in the description box below. Now let's move ahead with some common tools used by a DevOps engineer. Version control. Git. Widely used for source code version control, Git is the backbone of many DevOps workflows. Git is used to monitor changes in the source code, enabling multiple developers to collaborate on non-linear development. CI/CD. Continuous integration, continuous deployment is a technique that involves automating different stages of app development to regularly deliver apps to customers. Some popular CI/CD tools are Jenkins, an open source automation server that supports building, testing, and deploying code. GitLab CI, integrated CI/CD solution tightly coupled with version control platforms. Travis CI, a cloud-based CI/CD service that integrates with GitHub repositories. Configuration management. Ansible, an open source automation tool for task automation, configuration management, and application deployment. Chef, an automation platform that manages infrastructure as code. Containerization. Docker, a platform for containerizing applications, is one of the most widely used container technologies today. A Docker container image is a lightweight, executable, standalone software package that includes code runtime, system tools, and system libraries. That is everything needed to run an application. Orchestration. Container orchestration automates the deployment, management, and scaling of networking containers. Kubernetes, an open source platform for container orchestration that automates containerized application development, scaling, and management. Infrastructure as code. Terraform is the most popular infrastructure provisioning tool. It is a tool for building, changing, and versioning infrastructure as code. CloudFormation, AWS native IAC tool for defining and provisioning AWS infrastructure. Cloud platforms. Public cloud platforms such as AWS, Microsoft Azure, and GCP offer a wide range of services for building and deploying cloud-based applications. What is CI/CD? CI/CD brings continuous automation and continuous monitoring to apps at every stage of their lifecycle, from delivery and deployment to integration and testing. So these connected techniques are often referred to as a CI/CD pipeline and are used by the development and operations teams. CI/CD is a solution to the problems that arise when integrating new code. Continuous integration and continuous delivery are integral components of the DevOps philosophy, contributing significantly to the efficiency, reliability, and speed of software development and deployment. So let's explore one important CI/CD tool, that is Jenkins. Jenkins is an open source automation server widely used for building, deploying, and automating any project, particularly in the field of continuous integration and continuous delivery. It helps automate parts of the software development process, making it more efficient and reducing manual intervention. So Jenkins is an amazing tool to build a CI/CD pipeline because of its flexibility, extensibility, and strong community support. Jenkins plays a crucial role in the DevOps toolchain by automating key processes and providing a flexible and extensible platform for developing, testing, and releasing software. Its popularity and widespread adoption make it an essential tool for many DevOps teams. Next, let's explore the installation of Jenkins. The prerequisite of Jenkins is that we should have Java, that is JDK, installed in our system. If you haven't installed Java, go ahead and install it. You can refer to the Edureka's Java installation video. First, open the web browser and type Jenkins. Open the first link from the official Jenkins website. Yeah, this is the Jenkins website. Let's go ahead and click on download. So now we are directed to this page. Here we can see the version, download Jenkins 2.4 to 6.1. This is LTS version. So we can download Jenkins using Docker, Kubernetes, or in Ubuntu. Here in this demo, I will be showing how to install Jenkins in Windows. So let's click on this. Yeah, so now Jenkins installer is downloaded. Let's just save it here. Wait for the download. Yeah, so it's preparing to install. Let's now click next. So this is the path where Jenkins will be downloaded. Now here, I am not setting up the password and username right now. So I'm just clicking run service as local system. We'll set it after Jenkins is installed. Next. So this is the port where Jenkins will run, that is 8080. So let's just test if that port is available. So this green tick shows that the port is available. So let's just click on next. So now here we need to paste the JDK link, okay, the path to our JDK. So for that, let's just go, yeah, this is the path. Let's just copy the path of JDK and let's just paste it here. Click on next. Let this be the default. Click on next and let's press on install. Yeah, once that is done, let's go to this link. Click on this link. So now we need to unlock Jenkins. To unlock Jenkins, we need the initial admin password. So the initial admin password is here, okay, in this link that they have already provided. So let's go to explore. Let's go to our quick access and let's just copy paste this link. Okay, let's just open it using Notepad. Yeah, so this is the password. So let's just copy it and paste it here. Then click on Install Suggested Plugins. So now all these plugins will be installed. Let's just wait for the installation to be over. Yeah, now we need to create a username. So let's keep it Edureka and password. Okay, give your email address as well. Save and continue. Yeah, this is the URL in which Jenkins will run. Let's just save and finish. Now click on Start using Jenkins. Yeah, so this is the Jenkins dashboard and we have successfully installed Jenkins in our system. Now that you have installed Jenkins, we can go ahead and create a CI/CD pipeline. Click on New Item and name it as Jenkins Demo and click on Pipeline, then OK. Okay, then we need to go down and let's try some existing pipeline. So here we have an already existing pipeline, that is Hello World. So this is the pipeline script. So basically a Jenkins scripted pipeline is a sequence of stages to perform CI/CD related tasks that can be specified as code. So it enables you to develop a pipeline script and add it to your code repository so that you can version it. So first we have the node block, okay, that is the pipeline. Then we have the stage block. Here we will define what the pipeline will do. So this step here, it will echo Hello World. Okay, that is, it will print Hello World. So this is basically a simple pipeline script. Now let's save it and let's click on Build Now. Okay, so here you can see that the pipeline is getting built, and so these are the different stages. Okay, in the stage view you can see different stages of the pipeline that we are building. So now here you can see that there is a green tick. Green tick indicates that the pipeline is built. So we'll just go ahead and click on it. Yeah, now we can see that this is the console output. So here you can see that Hello World is printed here, that is echoed, and our Hello World is a success. Next, let's see how to pull code from a GitHub repository and build a pipeline. So GitHub is a web-based repository of code that plays a major role in DevOps. It provides a common platform for multiple developers working on the same code or project to upload and retrieve updated code, thereby facilitating continuous integration. So Jenkins needs to have a GitHub plugin installed to pull code from the GitHub repository. Also, we need to have Git installed on the local machine. So download the appropriate Git file for your operating system, in this case Windows, and install it into your local machine. So you can execute Git repositories in your Jenkins once Git has been installed on your machine. So to check if Git has been installed on your system, open command prompt and type Git. Yeah, this shows us that Git has been installed in the system. The second thing that you need to make sure is that we need to add the git.exe path to the global tool configuration in Jenkins. So for that, open Jenkins and click on Manage Jenkins. Click on Tools. Under Git installation, you can see this path. Okay, this is the path to the Git executable. Okay, so for that, to get this path, go to command prompt and type where git. Yeah, so this is the path to my Git executable. So we need to copy this path and paste it here. Okay, and then we save it. Yeah, so that is done. Next, what we need to do is we need to create a repository in GitHub. So this is my repository, CI/CD pipeline. This repository, I created it for the sake of this demo. So, and you'll also have to add a file, that is Jenkins. Okay, so this is a document named Jenkins. So the Jenkins file is a text file that includes the description of a Jenkins pipeline. Okay, so this is the pipeline code. So the stage block comprises a number of stages in a pipeline showing the Jenkins pipeline flow. So here there are 3 stages: build, test and deploy. So each stage will print building example. The first stage will print building example. Second will echo testing example, and the third deploying example. So now that everything is set, let's go ahead and build the pipeline in Jenkins. Okay, so click on New Item, name it as Jenkins Demo 2 and then click on pipeline and click on OK. Yeah, here we need to click on GitHub project, and for the project URL we need to go to the GitHub repository and click on code. Here we have the HTTPS link. Copy that and paste it here. Then go down and also enable this option, that is GitHub hook trigger for GITSCM polling. Now, once that is done, go to pipeline and pipeline script from SCM. Yeah, so now we need to choose our SCM, which is Git, and the repository URL will be the same thing that we had copied. Okay, so control paste, and then here under the branches to build, replace master with the asterisk. Once that is done, you also need to change the script path to Jenkins and save it. Okay, so now our pipeline is ready. Now we'll have to build it. So click on build now. Yeah, now we can see that our pipeline is getting built. So these are the different stages. You can see the progress here. Yeah, now the pipeline is built. We can see the green tick. So click on that. This shows us the console output. So you can go down. You can see if the statements are being printed. Now you can see that building example, testing example, and deploying example. The three statements are being echoed, that is being printed here. So now we have successfully created a pipeline in Jenkins.
Here's quiz question for you guys. Which of the following best describe DevOps? And the options are A, a programming language, B, a set of practices that combine software development and IT operations, C, a database management system, or D, a cloud service provider. If you know the correct answer, please comment down below. Having an understanding of DevOps, it's time to explore the tools that support it. In the next topic, what is Git? You will learn about Git, a crucial version control tool in DevOps.
Let's start out with what's version control. So to understand what is version control system, we need to understand first why we need a version control system. So we'll see why do we exactly need a version control system. So for that, let's take a scenario where there are 3 developers working remotely on a web application or a mobile application. Now for simplicity's sake, let's just assume that it is a streaming application and one of them is working on a streaming page. Let's call them developer 1. Developer 2 is working on a user information page, and developer 3 is creating the payment portal. Now all 3 of them are done with their respective pages at 10 o'clock, 11 o'clock and 12 o'clock respectively. Now the thing is, all 3 developers are working in isolation. There may be their own changes, there may be changes in somebody else's page. They're all kind of adding some new files or modifying older files, changing the source code or something like that throughout the course of this project. But how exactly are they going to collaborate considering that they are working remotely? The solution to this is a version control system. With this system, I'll tell you what happens. At 10 o'clock, developer 1 uploads all the files regarding the streaming page. With a version control system, this modification is recorded and updated to one central directory or folder. So every time you're modifying an older file or adding a new file, it creates a snapshot of the latest version or the latest update of the changes that you've made or all the files that you've uploaded. So the snapshot of your update at 10 o'clock is saved, and then when developer 2 adds their user info page, this modification is also saved as a snapshot. Now there are 2 snapshots saved, and finally the payment portal page is added, and this is the last modification done at 12 o'clock, and this is the most recent snapshot saved, along with other snapshots of other updates and modifications done throughout the course of this project. Every change in your project a snapshot is created and your entire project is saved that way. And these snapshots are actually known as different versions, which are basically the state of your project at a particular time or at the current time. It means that it will contain the kind of files your project is storing at one particular time and what kind of changes you have made so far between the previous version and this particular version. And this is exactly how a version control system works. So version control system basically is a system that records changes to a file or a set of files over time so that you can record specific versions later. These versions are recorded in a repository and they can be recalled anytime from these repositories during the course of your project. So version control systems essentially are of three types. Now the local version control system is one of the simplest forms of VCS and has a database that keeps all the changes of the files under revision control. So all the files are saved by this one user and they manage all of the files. But it's actually really hard to maintain the changes of the file and you can accidentally replace one or the other file that you need. It also needs something known as RCS or revision control system, which keeps patch sets or the differences between updates in a special format on your disk. All of this, your local version control systems maintains all the track of all the files within your local system. As a user, you can track specific versions later, and it basically works as an independent standalone system for an application. So your applications like spreadsheets and word processors have this control mechanism. So that's one type. Apart from this, you also have your centralized version control system, which basically uses a central server to store all the files and enables team collaboration. So it's not one local system, but multiple systems which work on a single repository to which users can directly access as a central server. So the repository is a central server that could be local or remote, which is directly connected to each of the programmer's workstation. And the third kind of VCS is a distributed version control system. Now these systems do not necessarily rely on a central server to store all the versions of a project file. In a distributed version control system, every contributor has a local copy or a clone of the main repository. So everyone maintains their own local repository, which contains all the files and the metadata present in the main repository. And they can push or commit or update the main repository if and when required. Now we are going to cover more on the latter two version control systems further in the session. So now let's try and understand in depth what's the difference between a centralized version control system and a distributed version control system. As I had mentioned before, in a centralized version control system, each programmer working on a branch on a project has absolute access to the central server. So the centralized version control system uses a central server to store all the files, and everybody on the team can directly access the central server as it is one single repository. So if you have 3 workstations, workstation 1, workstation 2, workstation 3, all of them can directly commit to the repository and get updates from the repository, which is your central server. The repository here indicates a server that could be local or remote, directly connected to each programmer's workstation. Every programmer can extract or update their workstations with the data present in the repository, or can make changes or updates or commit in the repository. And every operation is performed directly on this repository. Even though this seems pretty convenient when we are just talking about 3 people, to maintain a single repository like this has some major drawbacks. One of them is that it's not locally available, meaning every change that you have to make, you will have to be connected to a network to perform any action. Also, in any case, the central server getting crashed or corrupted will result in losing the entire data of the project. Also, another small thing which is revertible, but is if one person accidentally makes some unwanted updates. Instead of his or her local system, they will be making that changes directly in the central server. So recovering that part back will be again a time-consuming process. This is where distributed version control systems come to the rescue. Now, these systems do not necessarily rely on a central server to store all the versions of a project file. In the distributed version control system, each and every contributor has a local copy or a local workstation clone of the main repository. That is, everybody maintains a local repository of their own which contains all the files and metadata present in the main repository. You will understand it better if you take a look at the diagram. As you can see, every programmer maintains a local repository or a local copy on its own, which is actually the copy or clone of the central repository on their local hard drive. They can commit and update their local repository without any interference from one another. And then they can update their local repositories with new data from the central server by an operation called pull. Once they are done with their bit of the code, they can affect the changes of the main repository by an operation called push from their local repository. Now, this system or this act of cloning an entire repository to your workstation and making all the changes on a local repository gives you a couple of advantages over a centralized version control system. First of all the operations except push and pull are very fast because the tool only needs access to the hard drive and not a remote server. Hence, you do not always need to be connected via a network connection, or you always do not need an internet connection. Committing new change sets can be done locally without manipulating the data on the main repository. Once you have a group of change sets ready, you can push them all at once. So you complete your set of code on your local system and then you push all the files once and for all into the main repository. Third, since every contributor has a full copy of the project repository, they can share changes with one another on wanting to get some feedback before affecting the changes in the main repository. So this enhances the essence of collaboration amongst a development team. And finally, if the server gets crashed at any point in time, the lost data can be easily recovered from one of the contributors' local repository. And that is why distributed version control system has been picking up popularity over the past decade. So why version control is important? First of all, it helps collaboration. It allows remote development, shared workspace, and real-time updates. All versions of your code are preserved, hence it helps you manage versions of the same code. Easy rollback from current version. Suppose a part of your project has been headed to a wrong direction, you can easily roll back from the current version to the last version which was stable. Now, because you can reverse faulty updates, you can save time and hence it reduces downtime of your project development. And finally, it improves visibility. You can analyze and compare different versions, and that gives you like a 50-foot top view of your entire project, which just accelerates your product delivery. So now that you have a bare sense of what is version control and why do you need version control, let's understand one of the most popular version control systems that exists today, and that is Git. So Git is a distributed version control tool that supports distributed nonlinear workflows by providing data assurance from developing quality software. So basically what it does is that it lets you and your team of developers work together on the same project remotely from anywhere across the world. Your team members can work efficiently on files and easily merge their changes into one source without the fear of losing or deleting anything of importance due to the easy rollback feature. Git is primarily used to manage your project comprising of a set of code or text files that you may want to change from time to time. Now, Git is an integral part of DevOps. DevOps, as most of you might have the idea of, is the practice of bringing agility to the process of development and operations. A couple of years ago, it was this entirely revolutionary ideology which swept IT organizations worldwide, boosting project life cycles and in turn increasing profits. DevOps promoted communication between development engineers and operations participating together in the entire life cycle, from design through development process to production support. Now, in the entire life cycle of DevOps, starting from planning of the projects to its deployment and monitoring, Git plays a vital role. When it comes to managing the code that collaborators contribute to the shared repository, this code is extracted for performing continuous integration to create a build and test it on the test server and eventually deploy it to production. Tools like Git enable communication between the development and operations team. When you are developing a large project with a huge number of collaborators, it is extremely important to have communication between the collaborators, between the developers while making changes in the project. Commit messages in Git play a very important role in this particular collaboration or communication amongst the team. The bits and pieces that we deploy or update lies in this version control system, such as Git. To succeed in DevOps, you need to have all the communication in version control. Hence, Git plays an extremely vital role in succeeding at DevOps. And due to this very reason, Git has earned way more popularity compared to other version control tools available in the market, such as Apache Subversion, Concurrent Version Systems, and Mercurial. If you compare the interest of Git by time with other version control systems, you shall realize that larger companies' products are generally developed by developers using Git all around the globe. And some famous names out of them are Facebook, Yahoo, Zynga, Quora, Twitter, eBay, Salesforce, Microsoft, and many, many more. Now lately, all of Microsoft's new development work has been in Git features. Microsoft migrating .NET and many of its open source projects on GitHub, which are managed by Git. One of such projects is the lifecycle. It's a fast, distributed, high-performance gradient boosting framework based on the decision tree algorithms, which is used for ranking, classification, and many other machine learning tasks. Here, Git plays an important role in managing this distributed version of lifecycle by providing speed and accuracy. So basically, to enable version control, Git is your go-to solution. It's fast and suitable for handling massive code bases scattered across multiple developers, which makes it the most popular tool used today. Now that you know about Git, a terminology we'll be using a lot while talking about Git and GitHub is a repository. Now, repository, or a repo as it's most commonly known as, is a directory or a storage space where your projects can basically live. It can be local to a folder or your computer, or it can be a storage space in another online host such as your GitHub. And in this particular space, in this particular directory, you can keep your code files, text files, images, you name it, all of it inside a repository. Through the course of this, we shall also be talking about something known as GitHub, which is nothing but a central repository, the kind that we spoke about when we discussed centralized versus distributed version control systems. There's a central repository, and that is where all of your code will live. You have your local repository where you'll make the changes, and there you have the central repository to which you will push all of the changes. Yeah? And the central repository is something that all of the developers involved in this particular project, in a certain project, have access to. Alright, moving on, let's discuss a few Git features which make it so popular amongst organizations as well as individuals. First of all, it's economical. It's free and open source. Git is released under GPL's General Public Licenses, open source license. So you don't need to purchase Git. It is absolutely free. And since it's open source, you can modify the source code as per your requirement. Second is its speed. Now, since you do not have to connect to any network for performing all of the operations, it completes all the tasks really fast. Performance tests done by Mozilla showed it was an order of magnitude faster than other version control systems. Fetching version history from locally stored repository can be 100 times faster than fetching it from the remote server. So the core part of Git is written in C, which avoids runtime overheads associated with other high-level languages, which makes it extremely fast compared to other version control systems. Next is that Git supports non-linear development. Git supports rapid branching and merging and includes specific tools for visualization and navigation of a non-linear development history. A core assumption in Git is that a change will be merged more often than it's written, as it is passed around various reviewers. Hence, branches in Git are very lightweight and is only a reference to a single commit. With its parental commits, the full branch structure can be constructed. Next, let's talk about the robustness. Nearly every single task in Git is undoable. Git gives each developer a local copy of the entire development history and the changes copied from one repository to another. These changes are imported as additional development branches and can be merged and deleted and recovered the same way as a locally developed branch. Next is the snapshots, which are recorded changes made to a file rather than the file itself. Followed by which you have integrity, which means no changes can be made without Git recording it. Since every contributor has their own local repository, on the events of a system crash, the lost data can be recovered from any of the local repositories. You will always have a backup of all of your files, and none of the changes made to the central repository will go unlogged by Git. Git uses the SHA-1 or the secure hash function to name and identify objects within its repository, and every file, every commit is checksummed and retrieved by its checksum at the time of the checkout. The Git history is stored in such a way that the ID of a particular version, a commit in Git's terms, depends upon the complete development history leading up to that commit. Once it's published, it's not possible to change the old versions without it being recorded. Then it's a distributed system, which means every user has their own copy of the repository and the data is stored locally. Git gives each developer a local copy of the entire development history, and the changes are copied from one such repository to another. These changes are imported as additional development branches and can be merged in the same way as a locally developed branch. And finally, it's easy branching. Now, branch management with Git is very simple. It only takes a few seconds to create, delete, and merge branches. Feature branches provide an isolated environment for each change to your code base. So when a developer wants to start working on something, no matter how big or small, they can create a fresh new branch which is not interfering with the main branch, which ensures that the master branch or the main branch always contains production quality code. So any little experimentation that you want to do or little things that you want to try out can always be on a separate feature branch instead of the changes made to your master branch. Because ultimately, your master branch should contain your publishable product. So now that you know the basic features of Git, let's try and understand what the basic workflow of Git is, or how does Git work. So the basic overview of how Git works goes like this. You basically create a repository or a project with a Git hosting tool like Git or Bitbucket. You copy or clone the repository to your own local machine or your working directory. You add a file to your local repository and commit the changes, which basically means you save the changes. Then you push the changes to your master branch. Then you make changes to your file and commit. Then you pull the changes to your local machine. You create a branch or a version, make a change, commit the change, same process, open a pull request, and merge your branch to the master branch. Now this is a little complicated listening to it like this, but once we get on to our demonstration, I think things will be way more clear. You can still take a good look at this diagram, but if you don't get it, don't worry. I will be explaining these operations one by one when we get to the demonstration part of this Git tutorial. Moving on, let's get to the good part, the hands-on section, starting with the installation and setup of Git. Now there are two ways in which this goes. First of all, for Windows users, you need to install Git Bash for Windows. And for Linux users, you'll have to start by updating the package index and then install Git using the terminal. So first of all, for our learners using Windows, you'll have to log on to gitscm.com/downloads. and then click on Downloads for Windows button, and then run the executable file and follow through till you finally install Git Bash. I'm not going to install it completely as I already have Git Bash downloaded, but I'm still going to open the page to show you guys. All right. So the latest source release is Git 2.30.1 on the 8th of Feb, and you can just click on this button. The moment you click on this button, it's going to start downloading Git for you. And once you have the executable file, all you have to do is open it or run it in your own system, right? Next, for people using Linux, this is an example considering you are using Ubuntu. If you're using CentOS, a lot of the commands don't change, but instead of apt install, you will be using yum install for CentOS. So for that, now I'm going to open my terminal on a virtual machine. So here I have running an Ubuntu machine using the Oracle VirtualBox. So I'm going to start by running an update. All right, this is going to take a while. Kindly be patient. So here I have my Ubuntu running on a virtual machine. So to install Git on your Ubuntu machine, you have to start by updating. So this will take some time. We're going to use sudo apt update. If you're using CentOS, you will be using yum instead of apt. Let's clear that out, and then we're going to install Git. And then you can look for the Git version. Yeah? All right. Now that we have our Git installed, let's go ahead and look at the operations and commands that we are going to take a look at today. You have your repository setup, which include the commands init, clone, config, and alias. Then you have your save changes operations, which have your add, commit, diff, and stash. All of these commands we are going to go on and off and look at collectively mostly. Then we are going to look at the inspect operations, your inspect repository operations, of which the git status command is something we are also going to look at throughout this demonstration right from the beginning. So apart from that, you have your git log, git tag, and git blame commands. So you have your merge rebase command. So let's move on to our first set of Git operations. First of all, you have your git init command, which basically creates a new empty Git repository. Now this can be used to convert an existing unversioned project to a Git repository or initiate an absolute fresh Git repository. Now most other Git commands are not available outside of the initialized repository. So this is usually the first command that you will run in a new project. That is, if you're using Git Bash. So when I run git init, it reinitializes an existing Git repository, which I already have here. Now what this does is it reinitialized my existing Git repository in this particular directory, in this .git directory. Yeah. What git init does is that it creates an empty Git repository or reinitializes an existing one, like it did for me right now. It basically creates a .git directory with subdirectories and template files. And when you run the git init command in an existing repository, it will not overwrite the things that are already there. It will rather pick up the newly added templates. So that's the repository initialized. You can go ahead and create some files in the directory or repository, whatever you call it. Now that is about initialization. Now, what about if there was an existing repository on Git that you had to act upon, that you had to make updates to, that you had to add files to, things like that? That's where you use the git clone utility. Yeah. Now you have the git clone utility, which you use to target an existing repository and create a clone or copy of this particular repository on your local machine. Now, this is one of the features provided to you by a distributed version control system, as we had discussed before. So this is a blank file called Edureka rep with just the readme text file. Let me just go ahead and copy this. And then I can just git clone and paste its HTTPS URL. And as you can see, it's cloning this into Edureka rep. And now if I change directory to Edureka rep, you can see the readme file is right there. Yeah. So we're basically going to work off of this particular repository today, Edureka rep. Yeah. So now that we created a clone, moving on, we have the git config command, which basically is a convenience function that is used to set up your git configuration values on your global or local project level. This command is basically used to modify your configuration text file. So if I typed git config global user.email, and here I type, so there I gave in my email ID as the global user email ID. So if I ask for what the global user email ID is, it will return my ID back to me. Yeah. Basically, these configuration levels, like your username and your user ID, correspond to your .git config text files. Now, executing this basically will help you modify the configuration text file. Git uses this series of configuration files to determine non-default behavior that you may want. Yeah. So the first place Git looks for these values is in the system-wide configuration file, which contains settings that are applied to every user on this system. So basically, if you pass the option to your git config, it will read and write from this file specifically. And the next place the Git looks is the config/git config file, which is specific to each user. Now you can make Git read or write to this file by passing your global option, which is what I did. And the final command in the setup operations that we are going to look at is an alias. Now, alias, as the name suggests, is basically used to create shorter commands that map to longer commands. They enable more efficient workflows when you obviously have to use lesser keystrokes to execute a command. There are these lengthy commands which obviously kill a lot of your time. So these aliases you can use to shorten those commands. And these are also something that you will create via the git config command. There isn't really a direct way or a direct command of creating aliases. Yeah, this is just something I wanted to add in here along with the git config command. Like a very common alias created is CO for checkout or anything else, CK for checkout. So yeah, this is something that you can do using the git config command, just creating aliases. Moving on, let's look at operations that you use to add changes and save changes to your Git repository. Now, the first two commands here that we're going to look at are git add and git commit. Now, this combination is basically used to create these snapshots that I was talking about initially in the session, right? So basically what you do is first, you use the git add command to add a change in your current directory or your working directory. And you add that to the staging area. It tells Git that you want to include a particular set of updates or changes in a particular file in the next commit. Then what you do is you move on to git commit after making the changes to your working tree. Then you use the git commit command, which captures a snapshot of your project's current state. So basically, you use add to update the index using the current content found in your working tree. And then you basically prepare the content in the staging area for the next commit. Then you run the commit command to take that snapshot of your project's current status. Now remember, this is very important and you have to do it each time. You must use the add command to add any new modified files to the index. You can't directly commit anything without adding it to the stage area first. Now what I did was I quickly went ahead and added 3 files to my repository Edureka rep. So if I go into this repository, you can see there are 3 files, Edureka file 1, file 2, file 3. Now let's see if these files are in my index or not using the command git status. Now git status basically displays the state of the working directory and the staging area. It will list all the modified files which are ready to be added to the local repository. It lets you see which changes have been staged and which haven't, which files are being tracked by Git and not. So if I typed git status, you can see on your main branch, you have 3 untracked files, which are the 3 files that I just added, Edureka file 1, 2, and 3. These are not added to the index yet. This means I cannot commit these changes unless I added them explicitly to the index. So now we are going to add these 3 files. This command will update the index using the current content, which is found in your working tree, as you can see in front of you, and then it'll prepare the content in the staging area for the next commit. So either I can just git add and put in the directory name, or I can just use git add with an extension of A, which means all, and this will add all of these files to the index which are in the directory but not updated in the index yet. Yeah, now I've done that. Let me go ahead and use git status again, and you can see all of these file names are written in green, and you can see changes to be committed written here, which means all of these changes are ready to be committed. They are added to the index. Now these files are added to the index. You are ready to commit them. Now, as I had mentioned before, we're going to commit them, and committing refers to recording the snapshots of the repository at any given time. So your committed snapshots will never change unless it's done explicitly. So I'm going to clear this, and we're going to commit this by typing git commit and then adding a tag or a message called committing 3 files. Let's try this out. As you can see, 3 files changed, 3 insertions. You can see our Edureka files 1, 2, 3 have been committed. The git commit command has committed the changes in the 3 files in your local repository. Now, if you want to commit a snapshot of all of the changes in your working directory at once, you can always go with commit-a. Now let me add a couple more files to my directory just to show you the difference between your files added to the index versus the ones that are not. If I type ls again, you can see there are 2 more files over here. As you can see, I have 2 other files. I'm just going to add the Edureka file 4 and not the file 5. And then I'm just going to git commit committing files. And as you can see, only 1 file changed, only 1 insertion happened. And that only happened because Edureka file 5 is not added to the index. And even if I use the extension A, I cannot add Edureka file 5 because that has not been added to your index. Now if I just go ahead and add Edureka file 5, voila, the change has occurred in our Git repository. Now if I typed git status, there are no more files to add or commit. Our branch is ahead of the origin or main branch by 3 commits. And you can use git push to publish your local commits. Now what is git push? This is something we will cover later in this session. Now understand that before you affect the changes made to the central repository, you should always pull changes from the central repository to your local repository just to get the most updated version of your branch. You'll get all the work of your collaborators that have been contributing in the central repository. For that, you use the pull command. Now, as you can see, there's nothing to commit and your working tree is clean. There are other commands like the git status command, which you could use for similar purposes. For example, you have the git log command, which only operates on committed history. It basically will display to you the committed snapshots and will let you list the project history, filter it, and search for specific changes. So if you typed git log, it's going to show you all the commits that have happened since we started with this git file. Okay, so you can see at the bottom, your original main, there's your initial commit, right? Then our first commit where we committed 3 files, then we committed the 4th file, and finally when we committed file number 5, right? These are all the commits, including the initial commit, the first one. Yeah, along with the author and the date and time. Remember when I told you about everything is recorded when you're using Git? This is what I meant. You can always access who made commits at what time and what commits were made when you use a version control system such as Git. Now at a point like this, I think it's crucial to mention one more command, which is the git tag, and it's used to basically capture a tag in history or a point in history that is used for a marked version release, right? So it's basically like a branch that doesn't change, and after being created, they have no further history of commits. Yeah, so that is one. And another one is git blame. Now the git blame function displays of the author's metadata attached to a specific committed line in a file. It's used to examine specific points in a file's history and get context as to who the last author was that modified that line. So if I went back and typed git blame Edureka file 5.txt, it's going to show who the person is that is to blame, who committed this particular file or made this particular change, right? It'll also, if you paid attention, give you the commit number. As you can see, this E9D63EFO commit number. This also has this E9D63EFO, which is the first few characters of this particular commit number. Yeah. So now that you know how to check the status of the changes and see who made the changes, it's time that you understand how you fetch changes from your remote repository to a local repository and how you push commits from your local repository to your remote repository. So here we are going to look at two commands called pull and push. Now, first of all, you have the git pull command, which fetches changes from your remote repository to a local repository. Basically, it merges upstream changes in your local repository, which is a common task in Git-based collaborations. But at first, you need to set your central repository as the origin using the command git remote add origin, and I'm going to add the link to my central repository, which is this. And as it says, the remote origin already exists. Now that your origin is set, and now we're going to pull our main branch. So I'm just going to type git pull origin main, and it says we are already up to date. Now, certain number of tutorials or documents that you might be following might even give you the command git pull origin master, in which case you're working on the master branch. Now, to know which branch you're at, you can just use the command git branch vv. Yeah, I'll tell you which branch are you working on. Yeah. So yeah, we are working on the main branch and we are already up to date with the branch since my local repository was already updated with files from the main branch. This is the message of an up-to-date branch. Now you can also use git pull, origin, and your whatever branch name. Here I'm using main. That's a mistake on my part. Maybe I was trying to clear the screen. All right. So here, even if I pull from the branch using git pull origin and the branch name to my local Git repository, you can see it's already up to date. So now my local Git repository is now all updated with the recent changes. So now it's time to make the changes to your central repository by using the push command. So we're going to use the push command. This command transfers commits from your local repository to your remote repository. And it is basically the opposite of your pull operations. Pulling will import commits to your local repositories, whereas pushing will export commits to your remote repositories. It's going to ask you for your username. And password before it lets you push into your main branch there. So I've put in the username and password for my GitHub account. And with that, this has pushed the changes from my local repository to the remote repository along with all the necessary commits and internal objects. Now this has created a local branch in your destination repository. The use of git push is to publish your local changes to a central repository. After you've accumulated several local commits and are ready to share them with the rest of the team, you can then push them to your central repository by using the git push command. Now the files which have already been committed previously in the commit section and they were all push ready, you will use git push origin master to reflect these files in the master branch of your repository. Alright, so let's go ahead to our repository and see if changes have been made. And yes, you can see all of our files on our GitHub repository. You have Edureka file 1, 2, 3, 4, and 5. All the 5 files that we had created on our local repository. Yeah, you have all these 5 files and the README file here. Here also you have the README file and all the 5 files that we had created. Now at this point in this Git tutorial, I hope you have understood the basic commands of Git. You have pulling, pushing, adding, committing, things like that. Now let's take a step further and understand the 3 basic commands of parallel development. Here I'm going to be talking about branching, merging, and rebasing. So first of all, let's talk about merging. Now merging is a way to combine the work of different branches together. This will basically allow you to branch off, develop a new feature, and then combine it back in. As you can see in the diagram, it shows you 2 basically different branches, new branch and master. Now, when we merge the work of the new branch into the master, it creates a new commit, which contains all the work of the master and new branch. Now, if we merge the 2 branches with the merge command, as I had mentioned before, Git allows you for easy branching, which means you have parallel branches with your master branch that help you carry on your individual work while not interrupting your main product, which is your master branch or your main branch. So branches in Git are nothing but pointers to specific commits. Yeah. So Git generally prefers to keep its branches as lightweight as possible. Now there are basically 2 kinds of branches via local and remote tracking branches. A local branch is just not the path of your working tree. On the other hand, the remote tracking branches have special purposes. Some of them are linking your work from your local repository to your central repository and automatically detecting which remote branches to get changes from when you do a git pull. So you can check what your local branch is by using git branch. So you know you are at your main branch. And the one thing you should understand, one thing is like a main mantra of people who use Git are branch early and branch often. Yes. So to create a new branch, you're going to use a command git branch and your branch name. And in this case, I'm just going to use a branch name Edureka Images. All right. And here you can see this diagram shows the workflow of a new branch that is created. When we create a new branch, it originates from the master branch itself. So since there's no storage or memory overhead with making many branches, it's usually easier to logically divide your work up than having big chunky branches. Hence, the branch often part. Now let's see how to commit using branches. Now branching includes the work of a particular commit along with all parent commits, right? So as you see, the new branch has detached itself from the master or the main branch, and hence it'll create a different path. So we are going to check out the branch name, which in our case is Edureka Images. And then we are going to git commit. So you have untracked files, Edureka Images, and nothing added. So you made that branch. Now, merging is a way to combine the work of different branches together. So basically what this does is, now that we've branched off to something known as Edureka Images, you can go ahead, add files to it, develop a new feature, and then combine it back into your main branch. Here you can see two different branches. You have your new branch and your main branch. And when we merge the work of a new branch into the main branch, it creates a new commit, which contains all the work of the main branch and the new branch. So now if we merge this branch, as you can see, it's already up to date. It's important to know that the branch name here should be the branch that you want to merge into the branch that you're currently checking out. So make sure that you are checked out of this destination branch. So let's just merge all the work of the branch, Edureka Images, into your main branch. For that, I will first check out my main branch and then merge Edureka Images with git merge Edureka Images. And as you can see, all the data from the branch Edureka Images has merged into the main branch. Now notice that merging in Git creates a special commit that has two unique parents. Now this is one way of merging into the main branch. There's also another way of combining the work between two branches, which is called rebasing. Now rebasing takes a set of commits, copies them, and stores them outside your repository. The advantage of rebasing is that it can also be used to make linear sequence commits. The commit log or the history of the repository stays clean if rebasing is done. Now our work from the new branch is placed right after master, and we have this nice linear sequence of commits. This command doesn't copy but moves all our work from the current branch to the master or the main branch. They look like they've been developed sequentially instead of having developed parallelly. So if I just did another branch called git branch Edureka Images 2, and then maybe git checkout, okay, then we git commit this, and then I could just git rebase main, and your current branch will be up to date. This command basically moves all of your work from your current branch to your master branch, and it'll basically look like it has been developed sequentially instead of having developed parallelly. Now, apart from these, there are certain operations that you ought to know. Firstly, archiving your repository. You can use this command. It stores all of your files and data in a zip file rather than a .git directory. This creates only a single snapshot, omitting version control completely though. This comes in handy when you want to send these files to a client for review who doesn't have Git installed in their computers. Apart from this, you can also bundle your repository, which basically turns your entire repository into a single file. This pushes the master branch or the main branch to a remote branch, only contained in a file instead of a repository. You could alternately change the repository, clone the repo bundle, create a copy, and use git log. But that is like 5 commands instead of 1. Why not just use 1 command? And finally, stashing uncommitted changes. When you want to undo adding a feature or any kind of added data temporarily, we can always stash them temporarily. You can use git status, stash status, and then you want to reapply the changes you stashed using git stash apply. Having said that, let's move on to another very important topic in this Git tutorial. Let's go through a brief introduction to SSH. Now, what is SSH? What is an SSH key? Now, an SSH key is an access credential for Secure Shell Network Protocol. It's basically an authenticated and encrypted secure network protocol and is used for remote communications between machines on an unsecured open network, for remote file transfer, network management, and remote operating system access. So basically, it's typically used to log into a remote machine and execute commands in it. But this also supports tunneling, forwarding TCP ports, and X11 conditions. It can transfer files using associated SSH file transfer or secure copy protocols. It provides you several alternative options for strong authentication and protects the communication security and integrity with very strong encryption. It's a secure alternative to the non-protected login protocols and insecure file transfer methods such as FTP. So basically, how do you create SSH keys? You start by using the command ssh-keygen, and then you'll be prompted to enter a file in which to save the key. So home, Edureka. Then we're going to enter a passphrase. I'm just going to leave it empty again. And you can see our identification has been saved in the file that we specified. And we have something known as a key fingerprint. And finally, what we have to do is add the new SSH key to the SSH agent. And then you will see identity added. And that's it. You have created an SSH key.
Moving on to our next question, what is Git primarily used for in DevOps? And the options are A. Project management, B. Version control, C. Continuous integration, or D. Network monitoring. If you know the correct answer, please comment down below. Now that you know what Git is, we will move on to what is GitHub. Here, you will learn how GitHub enhances collaboration in DevOps using Git.
The need for GitHub. It is extremely important for software developers to work on a web-based platform to share their projects and collaborate with other developers. This platform must be a version control system, that is, it must enable multiple people to simultaneously work on a single project. Each person edits his or her own copy of the files and chooses when to share those changes with the rest of the team. This application must also be capable of hosting millions of programmers and hobbyists that download and evaluate each other's work. GitHub is one such platform of choice for developers that can host multiple programmers and review their code. GitHub has several competitors. For instance, GitLab. GitLab is an open source web interface and source control platform based on Git, whereas Microsoft Team Foundation Server is an enterprise-grade server for teams to share code, track work, and ship software for any language, all in a single package. Bitbucket, on the other hand, stores all of your Git and Mercurial source code in one place, with unlimited private repositories. So what really makes GitHub so powerful and popular among developers? GitHub is an open source platform, and the community is really what fuels it. Moreover, GitHub is the platform of choice for developers from various large corporations too. Microsoft is the #1 contributor to the system, but there are also Google, SAP, Airbnb, IBM, PayPal, and many others. Exposure and insight that you can get on GitHub are simply unmatched by any other platform. Here you can discover code written by others, learn from it, and even use it for your own projects. Versions control on GitHub works very much like Microsoft Office or Google Drive. It simply tracks all the changes made to your code and who makes them. You can always review the detailed change log that neatly hosts all of the relevant information. Using GitHub eliminates the need for complex corporate security solution because everything is on cloud. The platform protects code branches, verifies commit signing, and controls access. Now that we know why we need GitHub, let us understand what is GitHub. GitHub is a Git repository hosting service that provides a web-based graphical interface with many features. A repository is usually used to organize a single project. Repositories can contain folders, files, images, videos, spreadsheets, anything your project needs. Let's say, for example, a team wants to work on a particular project. Here they can simultaneously write and update their code to a central repository which is present on GitHub. So GitHub is a highly used software that is typically used for version control. It is helpful when more than just say one person is working on a project. For example, a software development team wants to build a website and everyone has to update their codes simultaneously while working on this project. In this case, GitHub helps them to build a centralized repository where everyone can upload, edit, and manage the code files. Most software projects have a bug tracker of some kind. GitHub's tracker is called Issues and has its very own section in every repository. Issues basically are a great way to keep track of tasks, enhancements, and bugs for your project. Moving on, people often get confused between the terms Git and GitHub. Now let me clearly explain the difference between them. Git is simply a version control system that lets you manage and track changes within your project, whereas GitHub is a cloud-based service that lets you manage Git repositories. So basically, Git is the tool and GitHub is the service. Now that we know the difference between Git and GitHub, let us move on and understand how these two work hand in hand. We already know that Git is a version control tool that will allow you to perform all kinds of operations to fetch data from the central server or push data to it, whereas GitHub is a code hosting platform for version control collaboration. GitHub is basically a company that allows you to host a central repository in a remote server. Now, without any further ado, let's get started with the demonstration on how to use GitHub. So for this demonstration, we're working on the website version of GitHub. There's another version of GitHub that is the desktop version, which you can download it to your personal computer. So we're simply going to search for GitHub in our search engine. The first link will lead you to the official website of GitHub. So I'm going to click on that. So this will redirect me to the main homepage of GitHub. As you can see, there is a search GitHub option. There are also two buttons that says sign in and sign up. If you're new to GitHub, you can simply enter in your credentials, that is a username, email, password, and sign up for GitHub. But if you already have an account like I do, I'm simply going to click on the sign in button and it'll redirect me to a page where I have to enter the credentials, that is my email address and password. I'm going to do that now and I'm going to click on the sign in button. Now, this is the main page of my account. As you can see, I have no repositories. It's all new, it's all fresh. But if you're not new to GitHub, you can view all of your repositories on the left-hand corner. Now, before we move on, I'm going to explain you all the features that are present within GitHub. So you can see a search bar here. So the search bar will allow you to look for profiles, certain keywords, look for different kinds of projects that are available on GitHub. All of those can be done using this bar here. And you can see 4 options next to the bar that says pull requests, issues, marketplace, explore. Pull requests we'll learn later on in this session, but the issues in marketplace we won't be discussing in this video for now. The explore button, on the other hand, is an extremely important and interesting button. So once I click on that, it'll redirect me to a page with some activities that are going on around in GitHub. You can see here they're trending repositories, they're trending developers. Basically, this is a feed that will allow you to interact with developers and other people, collaborators from all around the world, basically. In Instagram too, you have an explore button, which will allow you to interact with different people from all around the world. So the same concept is implied in the GitHub explore button too. So you can explore topics, you can explore trending repositories, developers. Basically, it's an interaction with other people from different parts of the world. So I hope that's clear. Now, the most important part of the session are the 3 buttons that are available in the right-hand corner of the navigation bar. So you can see there's a bell icon, there's a plus icon, there's a pixelated icon on the right-hand corner. So the bell icon allows you to read notifications of your activities that occur in GitHub. So that's what it really is. You can see the inbox will allow you to view all of the notifications. You can also view the unread notifications by clicking on this unread button. As of now, I don't have any notifications, so there's nothing available. You can also group these notifications by the date or repository by clicking on this group by button here. You can also view your saved notifications by clicking on here. And the done button, on the other hand, will let you mark all of your notifications that you're done with, your previous notifications. So these are the three important buttons you'll have to know in this bell icon. And the filters are not necessary as of now, so I'm not going to discuss that. This button, on the other hand, will allow you to manage your notification settings and your subscriptions too. So that's all for this bell icon. The next important button is this plus icon. As you can see, there are 5 drop-down options that appear here. The first one being new repository, followed by import repository, new gist, new organization, new project. So new repository we've already discussed previously in this session. A repository is a place where you create your files for your project. It's basically a storage space, right? So your repository can directly interact with your Git, right? So the new repository option will allow you to make files, a repository, to your GitHub account, right? The Git, on the other hand, the tool that which we use to make local repositories in our personal computer, can be directly pushed on. The local repositories can directly be pushed onto your GitHub account. So that's what the new repository button allows you to do so. But the new project, on the other hand, is a place to track issues, features, and other tasks that are related to the code within the repository. You can also connect with the DevOps build and deploy process, assign people to tasks, and so on by using this button. That is the new project button. So the difference between the new repository button and the new project button is that projects in GitHub are only a part of GitHub, but not Git. But the new repository option is a part of GitHub and Git. So that's the main difference between new repository and new project. I hope that's clear. So the next button will drop me down some interactions that I can make with my profile. So if I click on this your profile option, it will redirect me to a page where I can edit my profile. I can really create my identity using this page. So here, if I click the edit profile, I can add a bio about myself. I can add the company in which I'm working in, the location at where I am, the website, Twitter username, etc. All of that I can add here, all of the information about myself. I can also view the repositories I'm working on currently, or the repositories I've worked in the past, projects that I'm working on, the packages, and the entire contributions I've been making on GitHub from the last year. So basically, it allows me to build an identity, or it'll help me build my profile on GitHub. So I hope that's clear. Now, if I click on this button and if I want to sign out from a profile, I can simply scroll down and click on the sign out button here, and this will sign me out of my account. So that's all for getting started with GitHub. These are the basics on what GitHub is and what each of the button and options really do. Now, if I want to move back to the main page of my GitHub profile, I can simply click on this 𝐶𝐞, that's GitHub's logo. So I'm just going to click on this 𝐶𝐞 logo, and here I'm back to my main page. Now, before we move on and work on the different operations and options within GitHub and learn different things about GitHub, I'm going to give you a brief overview on how to download the desktop version of GitHub. So I'm simply going to search for GitHub Desktop on my search engine, and I'm going to click on the first link that's available on this page. Now I can simply click on this button that says download for Windows 64-bit. That's compatible to my current version of my personal computer. If you have a Mac, you can simply click on the Mac version and download it to your desktop. But as I've already mentioned previously that we're going to work on the website version, so I'm going to simply switch back to this. Now let's quickly move on to the next part of the session. Create a repository. So firstly, let us understand what a repository is. It is simply a storage space for the correct project that you're working on. GitHub is a very popular central repository that allows you to share your files, whereas Git allows you to create local repositories that are present on the system you are working on. So you can basically push your local repository into GitHub and share it with other collaborators via the central one. Now that we know what a repository is and how it works, let's go on to the demonstration part and create our first repository. So you can do this in two ways. Either you can click on your create repository button that is present on the left side, or you can, as I've already mentioned in the previous part of the session, you can click on to this plus icon and you can click on the new repository option. So this will redirect you to a page that says create a new repository. You can add your repository name. I'm going to name my repository as Edureka and it's available. All of your repository names must be unique from one another to identify them easily. You can also add a description, which is optional. I'm just going to add the description. This is my first repository. And a description allows people or other collaborators to understand what your repository is all about. But as a good developer or a good programmer, you would definitely want to add a description and give an overview of what your repository is all about. There are two options now available that says private or public. Now you can choose your repository to either be public or private. So the private one lets you decide who can access your profile, whereas the public one lets anyone view and access your repository, but you can choose who can commit to it. That's the difference between public and private repository. I'm going to let my repository be public as of now. Now, if you scroll down, you can see that you can initialize your repository with three options. The first one being add a README file. The second one being add a 𝐸it-𝐸igno file. You can always choose add a README text file to your project, which often contains information about the project and other necessary details the user must be aware of when he or she is accessing that particular project. Now, I want a README file for my repository, so I'm going to click on this button here. That's going to check it. The next option is add a .𝐸it-𝐸ignore file. So this file will let you ignore a list of files when the user is pushing files to GitHub. That's what this option really does, but I'm going to let this be unchecked for now. For your repository to truly be open source, you will need to license it, so others are free to use, change, and distribute the software. You can simply click on choose a license option and pick the required license for your project. There are several licenses like MIT, GPL, Apache License 2.0, BSD, etc. But for this repository, we don't really need a license, so I'm going to untick this too. And now you can see there's a piece of information that says this will set master as the default branch, but I'm going to ignore this for now. I'm going to explain about branches later on in this session. So this is all you have to do to create your first new repository. You add a name, you choose a description, you add an optional description, you let your repository be either public or private, and you initialize your repository with either of these three options. And I'm simply going to click on my create repository option. Now this will redirect me to a page with all the information and the files that are currently present in my repository. You can see here my repository name is present here with the optional description that I gave, and the number of files. Currently we have only just one file, that's the README text file, and that's present here. So this is all we have. Congratulations, you just created your first repository. Now you can see there are some options that says issues, pull requests, actions, projects, wiki, security, etc. We don't have to really talk about all of these right now. We will just learn about one option that says code here. So this is really important. If you click on this button, you can see that there's a link that is available here, an HTTPS link. So if you copy this link and paste it on your Git terminal that's present on your computer, you can download this entire project directly to your local system. So that's what the link is for. I hope that's clear. And the next option that says open with GitHub desktop will allow you to open this entire repository in your GitHub desktop version. And you can also, the last option that says download zip will allow you to download this entire repository in the form of zip files. So all of your project files will be within that zip file. So that's all you have to really know about your repository. And I'm going to click on the README text file that's available. It will take me to another page with some extra information about that file. You can see currently we have 2 lines and the memory space that is allocated to this file. So we currently have 2 lines, that is Edureka and this is my first repository. And you can also see the number of contributors to this project. That is just one, that's just me for now. And you can view the history of the commits or the changes that have been performed in your file. So we'll come back to that part later on this session, but you can move back to your main page of this repository by clicking on the name button here. So Edureka is the name of my repository, so I'm going to click on that. So now I'm back to the main page of my repository. Before we learn how to create our first branch, let us understand what branches are. Branches allow you to work on other features that can be included and merged with the master branch if required. So what is the master branch? The master branch is the main branch where your project resides on. So all of the changes, all of the activities that you do with your main project lies or is on your default branch that is named as the master branch. So what really GitHub allows you to do is it allows you to create additional branches. So on these additional branches, you can work on the other features or you can experiment with your project. And if you're happy with this, you can simply merge these features to your main branch, that is your master branch. This is what branches are really for. So they simply allow you to work on other features. That's what branches are. So let's move on to the demonstration part and look at how we can create our own branches. So now if you look on the left corner, you can see a button that says master. So currently we're on the master branch and there's only one branch, and the master branch, as I've already mentioned, is the default branch. So when you create a repository, you're automatically creating a master branch. So this is where your project will be residing on. And now if you want to create another branch, say let's name this branch 1 branch. So this is what I want to name my additional branch. I'm simply going to name it and I'm going to click on the enter button. So it will redirect me to a page. So this is the exact replica of your master branch. And you can work on this branch. You can work on any other feature, or you can add something, you can remove something, you can really experiment on this branch. And if you're happy with this, you can merge back this feature or the experimentation that you've been working on to your master branch, right? So you can see there's a README text file. It's exactly the same. There's the name of your repository, the description of the repository. You can click on the README text file and everything's the absolute same. You can quickly switch back to the main page. But the only difference is that you're currently on a branch named branch 1 branch. You're not on your master branch. Now, if you want to switch back to your master branch and work on it, you can click on this button and you'll find the master here. You can click on that and it will take you back to your master branch. Here you can work on your project. So there are currently 2 branches. You can see that, and everything's normal. Everything looks simple. That's all for branches. It's really easy. I hope it's clear. So you can look for branches here on this bar here that's present here. You can also create new ones in the same option. So that's all for branches. Let's move on to the next part of the session. Make a commit. Now, what are commits? Commits simply record changes to one or more files in your branches. So basically, they save the changes that you're making in your project. Git always assigns each commit a unique identification, which is called SHA or hash, that identifies the specific changes. So for any changes are made to your project files, you can simply go back and look at the version history or the history of each commit you've performed on your project files. So that's what really commits are all about. It's extremely easy. Let's go ahead and make our first commit. Now I'm going to switch to my branch 1 branch and I'm going to make my first commit. I'm going to click on my README text file. That's the only file currently in our repository. So we'll make the change in the README text file. There are 3 really important icons that are present in the right corner, as you can see. The first one is a PC icon that says open this file in GitHub desktop. So if you click on this file, this entire file will open in your GitHub desktop version. The next one, that is the pencil icon, will allow me to edit this particular file. That is my README text file. And the third icon is a bin icon, which will allow me to delete this file. Now, what we'll be working on is the pencil icon. That's the edit this file option. I'm going to click on this and I can simply view a space or a file that will allow me to make changes to my README text file. I'm going to add another line here that says this is my first commit. This is what I want to add to my README text file. And if I want to preview the changes, I'm going to click on this preview changes button. You can see that this is my first repository. This is my first commit. This is my first commit is the additional piece of information that we'll be adding to my README text file. And it's highlighted in blue, so we know that that's the additional information. I'm happy with this change. I'm going to switch back to my edit file. I'm going to scroll down. And if I want to add a description about the change that I'm performing to my file, I can do that. A good programmer would always add a description to the change that he's making to the project file, so other collaborators when they view the commit or they view the change, they can read the extended description and understand what the change is about. So that's a good habit that you must follow. But as of now, we're not going to do that. So I'm going to leave this blank. As you can see, there are two radio buttons that are currently available. The first one says commit directly to the branch 1 branch. This will allow me to make the change or save or make the commit directly to my branch 1 branch only. So the change that I'm making currently is only implemented to my branch 1 branch. The second option allows me to create a new branch for this particular commit and start a pull request. We're not going to talk much about this option right now, but the first option is extremely important. So we'll let this be stuck on to the option that says commit directly to the branch 1 branch. And I'm going to click on the commit changes options. And this will simply implement the entire change to the file. You can see that the change is implemented. The additional piece of line that says this is my first commit is added to my README text file. Now, the interesting part is if I switch to my master branch, the change is not implemented in my master branch. So the change is only currently present in my branch 1 branch. And now if I want to view the history of the changes that I've made, I've already mentioned in the previous part of the session that the history button will allow me to do so. So I'm going to click on this history button, and you can see that I made my first commit 23 minutes ago, and I made my new commit 41 seconds ago. And there is also a hash number, unique hash identification number, that allows me to distinguish between both of these changes. So all of my commits that I'll be making on this branch will be available here. So that's the main point of a version control system, isn't it? Understanding and keeping a record of all the changes that we're performing in our files and our projects. So this gives full justice to the word version control. So that is what GitHub is all about. Now that we learned how to make our first commit, let's move on to the next part of the session. Open and merge pull requests. So what are pull requests? Pull requests let you tell other developers about changes you've pushed to branch in a repository on GitHub. So once a pull request is open, you can acknowledge and review the changes with collaborators and add follow-up commits, after which your changes are merged into the base branch. So there are two ways to create a pull request. The first one being pull request from a forked repository, and the second one being pull request from a branch within a repository. Currently in this demo, we will work on the second one, that is pull request from a branch within a repository. Now I'm simply going to switch to my demo part. Okay, now currently I'm on my master branch. I'm going to click on this pull request option that's here. Now it says branch 1 has had recent pushes 3 minutes ago, compare and pull request. I'm not going to click on that. I'm going to simply click on the new pull request option here. So this will allow me to compare the changes. There's a base branch and a compare branch. The base branch is the master branch, and the compare branch, I will compare my master branch to my branch 1 branch. So this notification says that the merge between the branch 1 branch and master branch is definitely possible. So it's a green signal. So if I scroll down, I can view the difference between both the branches. So the left hand side indicates the information that is present on the master branch, and the right hand indicates the information that is present in my branch 1 branch. Plus sign indicates the additional information that is present in my branch 1 branch. I'm happy with this. So I'm simply going to scroll up and create the pull request. I'm going to click on that. I can also leave a comment and I can preview the change. That's not necessary for now. So I'm going to go ahead and create the pull request. Now this will redirect me to a page. So this page says that the pull request has been opened. And now I can choose to merge this pull request. That is, I can merge the branch 1 branch to my master branch. So it says this branch has no conflicts with the base branch. Merging can be performed automatically. And that's good news, right? So I'm going to click on merge pull request, and I'm going to confirm my merge, update my README text file. I'm happy with that, so I'm just going to confirm it. Now it says pull request successfully merged and closed. You're all set. The branch 1 branch can be safely deleted. I'm not going to delete the branch. I'm going to compare both of the branches and see if my master branch is exactly the same as my branch 1 branch. So I'm going to click on this Edureka. I'm going to go to my main page of my repository. So my master branch has the additional piece of information that says this is my first commit. Now if I switch to my branch 1 branch, It has the exact piece of information. So the information that was present in my branch 1 branch has been successfully implemented to my master branch. So that's all for the pull request part 2. We've reached the end of the demonstration part. Now let's quickly look at the case study of how Microsoft implemented GitHub. I'm pretty sure most of you have heard of Microsoft. Microsoft Corporation is an American multinational technology company. It develops, manufactures, licenses, supports, and sells different computer software, consumer electronics, personal computers, and other related services. So initially, Microsoft was against the use of the open source because they held very tightly to the internet protocol. They were completely hesitant to adapt to this new concept of sharing code to the entire world. But in 2010, they rethought this entire scenario, and now Microsoft is one of the biggest contributors to open source. Today, about 2,000 to 25,000 Microsoft engineers maintain TypeScript, .NET, Windows Terminal, DARP, Helm, and more than 1,000 other open source projects. So first what they did was they released new processes in measured containment. But later on, they released only licensed software. So here, developers can learn from the company's source code, but they couldn't really build on it. Eventually, the stigma died, and now even closed code like .NET is open source under an MIT license. Teams realize that they need to accept contributions to get feedback and learn from other developers. To organize and understand this approach, Microsoft created their Open Source Programs Office, which enables distribution and centralization of knowledge. So the OSPO provides the resources and maintainers to manage thousands of repositories and contributors effectively on GitHub. Even though Microsoft invests in its tools, they expect other individuals and organizations to lead the way. Microsoft believes that GitHub's value isn't in any one feature, but its entire community. GitHub is the place to collaborate, it's where everyone is, and where most of the entire world's open source is already happening. It's not just a feature, but the whole thing.
Having learned about GitHub, we will explore what is CI/CD. This topic will help you understand how continuous integration and delivery streamline the DevOps process.
Let us execute this process with the help of the pipeline. First stage in any continuous integration flow is version control. Now, what is version controlling? And then building, then unit testing, deploying. So let me directly show you the demonstration rather than talking about it. Let us take some code given to us by the developer friend. So there are version control tools where developers can write the code and push the code. I have a GitHub repository where I have some code which is given to me by a developer. Right? This is a Java based code. For this particular code, okay, for this code, we have the source code, we have the test cases written, given by the developer. I'm going to, and as soon as the developer writes the code in his local machine, let's say here he has written some piece of code, he'll push all of his code into this server. This is an external server where anyone can push the code. Okay, so this on this repository, on this particular repository, the developers are maintaining all the versions of their. Okay, so version controlling is the process to maintain, manage the changes that a developer or a user is doing to the files, common files accessed among by the team members. This repository is accessible by every team member. That is version controlling. I'm going to use a tool called as GitHub for version control. GitHub is an open source tool where 90-95% of the code is available for everyone to use. After version controlling, the next step will be to build the code, friends. To build the code. So build the code, we are going to make use of Jenkins server, friends. Now to tell you that what is Jenkins? Jenkins is an open source tool, friends. It is available for free, right? And it is provided by an application by an organization called as CloudBees. Jenkins is like a robo. Whatever you tell to Jenkins, it will do it for you. You ask Jenkins to do a task, it will create a job, it will create it. You ask Jenkins to create a file, it will create. Delete a file, it will delete. You just need to instruct Jenkins to do a task. You just need to instruct Jenkins to do a task. It will perform the task for you, friends. It will perform the task for you. Okay, automatically or at the scheduled time or at the scheduled interval, or whenever you have this, whenever you have set the trigger, automatically Jenkins will perform the task for you. Jenkins also provides you whatever task is executed by Jenkins, it provides a very good console output which will help us to troubleshoot the issues. It also maintains the history of the jobs that have been run and when it was run. It also provides a one-click philosophy to automate your entire CI/CD pipeline. Jenkins can do a continuous integration and continuous deployment flow for you, friends. So let us use Jenkins as a tool for performing the build steps. Now, build is a process which involves compiling the code, unit testing the code, and packaging the code, friends. Packaging the code into an artifact, friends. The code that I have picked up, if I show you the details of the code, the developer has already told this code when built, when this code is built, it is going to be built into a WAR file. So a package which will be generated will be of type WAR file. So I'm going to now to do the build process, friend. We have a tool called as Maven and its commands are available that will help us to build the code. But executing the Maven commands is done manually. DevOps says whatever is your manual process, please automate it. So using Jenkins, we are going to automate the process of compiling the code. So let me quickly log into this server. So I've already installed Jenkins and I'm going to log in with my credentials. Okay. Jenkins provides you. So if you're opening Jenkins for the very first time, you may not have any particular job, right? So here, if you go to the new item, Jenkins will allow you to create a job, friend. Job is nothing but a task that you want Jenkins to do. So here, my first task that I want Jenkins to do is compile the source code that is given by the developer. Now, where is the source code? The source code is available in this SRC folder, main folder. There are some files available here. These Java files can be used to, these are the source code available that I want to compile. It is my first step in build process. So let us write down one dot. So let's say I'll write 04 dot. Compile is the first job that I want to build. Jenkins provide you different templates to build your code. Whenever you want to do the process of building the code, you can use a template called as a freestyle project. It is one of the easiest way of creating your project in Jenkins. But if you prefer to go with the CI/CD pipeline, you can go with the pipeline code also. So let me take the pipeline code and show you how to create the pipeline. It's very easy to work with the pipeline code also. Here you will be writing the scripted pipeline code. Writing scripted pipeline code in Jenkins is very easy, as it is the format is quite readable, easy to understand, and it does not require any coding skills for you to write the code. Also, Jenkins provide a pipeline syntax, that is a snippet generator, which will automatically generate the pipeline code for you. So let us use the snippet generator to generate the code that will create our CI/CD pipeline. Okay. So what I'm going to do, I'm going to go back and I'm going to recreate the job with a new name. I'm going to delete this job. I'm going to delete this job and I'm going to create a new job and I'm going to call this job as CI/CD pipeline. Okay. And I'm going to take the template as a pipeline template. Whenever you have multiple jobs to be executed one after the other, it is always better that you take the pipeline as a template. Let us press OK. Now what I'm planning to build today, let me quickly explain you that also. So I'm going to build a following pipeline. Okay, just a moment, please. I'm looking for a PPT for a slide. Okay, so I'm going to build the following pipeline for you, as we were just seeing in the slide also, but this is more descriptive. First, we have the source code and Git, and I'm going to create a stage called as compile. Now, in this pipeline, first we are going to take the code from Git and we are going to compile the code. Okay, all right. So here we go. We are going to write the code here. Every pipeline code starts with pipeline. Okay. And here we are then going to start building the code on a particular where do we want to run the code. So we want to run the code on an agent. Okay, agent N. And we also have an option called as tools. Which two tools I want to use to build my code from. The tools that I want to use is JDK, that is Java. Because my code is Java based code, I want to use JDK, and this is the name of the tool, my Java. MVN is another tool that I want to, Maven is another tool that I want to use because we are going to build the code. For building the build automation tool that I am using is MVN Fridge. Okay, so here you go. The name of the tool that I have set up in Jenkins is my Maven. So this is the first phase in my pipeline where I'm creating set of tools. Okay, these are the two tools that I'm going to use to execute my task. Okay, then we are going to create something called as stages. Stages is here represent the steps that you want to perform. Okay, the task that you want Jenkins to perform. My first stage is going to be clone the repository, clone the code. Whatever is the code written by the developer, I want to clone. In the stage, you will write down the steps. What are the steps involved in it? So the steps involved is we have to just run a command. We have to tell Git, hey Git, clone the repository. By cloning the repository means whenever you create a Jenkins job, in its workspace, we want to get the code given to us by the developer. So this is the code given by the developer. Let us go and take the path of the repository here. This is the path of the repository available. I am going to use the snippet generator. In the snippet generator, if you see, there is a step section. I'm going to use a step called as get. In this step, it is asking us, give the repository URL which you want to clone. And then just a second, friends. Let me quickly connect again. Let me give the name of the tool as Git and let me provide the GitHub repository. Give the name of the branch. Now this is a snippet generating pipeline syntax generator that will automatically generate the code for us for the particular stage. Git is a plugin that is available by default in Jenkins that can clone the repository. By cloning, we mean we are fetching the code from GitHub. Since we are building the CI/CD pipeline, I am assuming that you have an idea on what Git is, what GitHub is, and the Git commands like git clone fridge. After this is my first stage. This is my first stage, and if I execute this stage, let me save this stage. Now let me call this stage as a version control stage. Let me save it. So you will save the pipeline and you will build it fresh. So as I build a part of that particular, because there is only one stage, it is just going to clone that repository into Jenkins. Observe here, it has failed miserably. Let us see what is the issue. My Java It says the no such property my Java. Okay, let me go and check it. Let us go to manage Jenkins. We have to actually go to global tool configurations and set up the Java path. So there is my Java here. It is available. Okay. Let me check the job again. Go to the configure section. Okay, the reason why it has failed is we have to provide the name of the tool in single quotes. Now, if I will run the job again, let's build it again. So please see here on this particular in the middle section of the job, it shows stage view. So whatever stage has been executed, it shows whether it is successful or failure, right? So I think the second build is successful here. Go here and check it. It has created every job that you create through Jenkins creates a workspace. Workspace is like an output directory where your code can be available. So if you go scroll down further, see cloning the GitHub repository. Now Jenkins has got hold of your code. You make any changes to your code, Git can use this pipeline to fetch the code. So that's continuous version controlling, friends. Now let me go ahead and create the next stage. The next stage is, so as part of my slide, I've completed this step of fetching the source code. Next step is to compile the code. So let me go ahead and create one more stage. And I'm going to call that stage as compile stage. Okay. Now in the compile stage, I'm going to use steps and I'm going to use Maven to compile the code, friends. Maven is a build automation tool which provides us plugins which when run can compile your code. Compilation is a process where your source code which is available in your workspace is picked up and is converted into a machine understandable code. That is the class files or binaries or zeros and ones. So the command is mvn compile. This is the Maven command to compile the source code. Okay, and you are going to use shell. My server is an EC2 Linux based machine, a Red Hat Linux machine, so I'm using shell command to execute the Maven compile command. Okay, that's all. So let me save it and let me build it. I will show you the compiled files after this stage. So my third build, observe here, I'm slowly building my pipeline, version controlling and compiling the code. Okay, compiling the code. Now, if you go to your build here, no, let me go and show you in the workspace. If you see the workspace here, you can see at the following location in the target folder, my compiled files are available. That is the files that we have just converted just now. We have converted these files, compiled the Java files into class files. That's my first step in build process, friend. Now let me continue further writing my code. The next stage is going to be the stage called as unit test stage. You can also add a stage, a small security stage if you want to implement a security in your DevOps. That's called as a static analysis stage, wherein you are going to use a tool called as PMD. So the PMD is a plugin provided by Maven that will check your code for programming mistakes, static mistakes. Okay, so I will actually call it as yeah, that's fine. So the command is steps As such, using the shell, you are going to run the command mvn pmd:/pm. PMD here stands for Programming Mistake Detector. PMD:/PMD is a command that is used to run the PMD plugin of Maven, which runs your source code to check for programming mistakes like unnecessary parentheses, out of memory error, connections have been created but not closed, using of certain you're recalling the loop again and again. Loop is going into infinite flow, or you have defined a condition but you have never called the condition. So such programming analysis are done by a Maven plugin called as PM. Okay, so I'm then going to build this stage. Let me build one more stage. After this, after we have completed static analysis, I'm going to add one more stage, which is my unit testing stage. This is the stage where my developer has given me some set of test cases. I want Jenkins to use Maven so as to pick up these test cases. There are some JUnit test cases given to us. So we want to pick up these JUnit test cases and execute them. Now, as you know, how you may be having a doubt that Sonar, from where are you getting the test cases? See, the first stage, we have already cloned the entire repository. So Jenkins is already holding the source code as well as the test cases. So you just need to tell Jenkins, hey, Jenkins, execute the following steps. What are the steps? Use the shell to execute the Maven command mvn test. So Maven has a plugin called a Shawfire plugin. Using the Shawfire plugin, which can be triggered using a command called as mvn test, you are going to execute the test cases which are available in the test folder and give the output as how many tests have passed or failed. So let me save this one and build the job. So if you see, we have cloned the repository. We are now compiling the files again. We are doing the static analysis. Any issues are there on the code, programming mistakes, we're going to find that out and then do the test cases also. Each of these stages will generate a report with you how many unit test cases have passed or failed. It's going to generate the report telling the programming mistakes done by the developer. Let me show you the reports. You can go to the build and you can scroll down, go to workspaces. In the workspace, if you go and check the target folder, you will have Shawfire report, which is your target test report. Here the report tells how many test cases have been executed, how many have passed, how many have failed. It gives the complete information and the time taken to execute the test case. There are 3 reports generated by the Shawfire reporting plugin. They're all generated in XML. You can use the JUnit plugin of Jenkins to convert it into a trend report. If you will join the DevOps training, we will show you how to convert these XML files into the trend reports also. And here is a PMD XML file generated where you can see the programming mistakes done by developer. Like in line number 18, there is an empty clutch block. Line number 62, there is useless parentheses. There is a unnecessary modifier in line number 24. So this report is automatically generated by the Maven plugin. Jenkins is just triggering it. Maven is actually executing those commands on the source code. Let me build my pipeline, the last stage of the continuous integration in my pipeline I'm going to build. The pipeline that I've built so far, that is version controlling the code, compiling the code, analyzing the code, testing the code, and finally packaging it. This pipeline is called as continuous integration pipeline. Package stage. In this stage, I'm going to write the steps. Now I'm going to use a shell to execute the Maven command mvn package. mvn package. So package is a command which will take the source code and convert it into an artifact. Convert it into an artifact. What is an artifact? Artifact is an executable. Artifact is an executable which when executed or which when deployed on a server will allow the users to access the application. Okay, so when if suppose to understand executable, suppose you go to your browser and I ask you to download Skype. So when you download Skype, there is an exe file which gets downloaded in your laptop. That exe file is called as an executable, which when double clicked and pressed next, install the software on your server. Same thing I'm going to do, take the test case, take the entire code and package it into an executable so that I can deploy it on my servers. So let me save this and build the pipeline now again. So you will see the last stage here, packaging. So here we go, friends. Our first continuous integration pipeline is automated. But you may be thinking that I am executing the code again and again manually. How is it called as a one-click philosophy here? Jenkins supports a one-click philosophy. That means when you just give one click, all the stages should get executed one after the other. Even if you want to automate this click, you can do that by using the triggers here. There is an option called as build periodically. Let's say every 15 minutes I want to run this pipeline. So I can give a schedule here by using a cron tab format. This is the cron tab format that you have to use. Like how many minutes, what for every 15 minutes, or what time do you want to run? Which hour of the day do you want to run it? Which day of the month do you want to run it? Which day of the week do you want to run this particular code frame, right? So this gives you, you can even set a schedule. Let's say I want to run it star means every minute at, let's say at 9 p.m. So we have already crossed 9 p.m. So let's say I want to run it at 22. Okay, at 10 p.m. is when I want to run my pipeline again, and I set a schedule here. Star here represents every day, every month, every day of the week. That's a schedule given. Suppose some more examples are given to you by Jenkins here, that let's say you want to run your job every 15 minutes. So let us take this cron tab. This tab here represents, so this is the Linux cron tab. Same thing. Every 10 minutes of the first half an hour. Once every 2 hours. Once every 2 hours slot between 8 a.m. to 4 p.m. You can give this schedule like this. So let me give a 15-minute tab here so that we can see. Okay, so as per the schedule, the job will run in the next 15 minutes. Suppose you don't want the scheduled one. There is also an option called as poll SCM. Poll SCM is a process in Jenkins where Jenkins is going to check with Git. Has the developer done any changes on the repository? Let us say the developer created a file here and did changes to it. As you commit the changes, as a developer commits the changes here, immediately the pipeline will run. So let's do this. So let us do this. So I'm going to set again here, you have to give a schedule to Jenkins. Jenkins, at what time should it check with GitHub for changes? So let's say every minute. So I'll give star, space, star, space, star, space, star. Every minute I want Jenkins to check with GitHub if developer has done a commit. So always in continuous integration, that's the flow. Hold on, I think there was an error. Okay, there's no error. So do you really mean that every minute you want to run it? Yes. Okay, but observe the pipeline will not run. Observe the pipeline will not run until and unless the change happens on GitHub. The continuous flow says, if we are here, let me see if there is. The continuous flow says, as the, so we have completed till here only, till here. The continuous flow says, as you version control your code or as the developer pushes the code in GitHub, your build pipeline, that is compiling the code, unit testing the code, package the code, should trigger automatically. So the setup is done in the following way. Now let's assume I am a developer of this repository. I will make small change in one of the files. Let me make a small change to a file. So let's say checkout on get. Okay. On the repository, if there is a commit, I'm doing a particular commit. On the repository, if there is a commit, immediately the pipeline should trigger. So give it a second. If you see here, there is a polling log created by Jenkins. So when every second, every minute, it is going to poll GitHub. If there is a change, it's going to trigger the job. Right now, no, it did not poll yet. It did not poll yet. 3:43, it is going to poll. Since we did a change in the GitHub repository, it should trigger the job. Just give it a second. Yeah, see here, changes have been found. Since some changes have been found, automatically the pipeline has been triggered. If you observe, all your steps will be triggered again, friends. All the pipeline is getting executed again. Who is triggering the pipeline? Jenkins is triggering. Who is executing the stages? Maven is executing it. Where is the code available? In GitHub. So we have integrated 3 DevOps tools: Git, Maven, Jenkins, right? Okay. Now, after this, we want to deploy the code on a particular server, friends. So next step is deployment. Deploying your code on the next server, on any other server. Now, deployment of the code can be done using a deployment tool. Now, there are 2 ways to deploy your code. Either you deploy the code in the legacy way, that is installing the Tomcat server or Apache server, placing the code on the directory, and then restarting the server. You can do that flow, or you can do it with the help of containers, friends. I'll show you both the ways. Let me show you with containers, friends. Let me show you with containers. Containerization is the new latest way of deploying your application, friends. Okay, what are containers? What are containers? Let us also talk about it before I build the pipeline. Friends, for deploying your code, for deploying your code, we have the package available. Addressbook.war file. A package is available, a war file is available with. I need to deploy it on the next server in a QA environment or the staging environment in the form of container. Now, container is nothing but a package. It's an environment. You can assume it to be like an environment which has its own network, which has its own state, which has its own memory, and your application that is running. So I want to place this address book war file. So I want a container which has Tomcat on it. Upon that, I want to place this address book war file. Upon this, I want to also execute a command to restart Tomcat, right? And I want to expose this container. I want to access this container from the browser of my machine. So I'm exposing it to the port 88. So a container is nothing but it contains each and everything that is needed for your application to run. Right? Now, how do we create a container? That's again that's an important thing that you need to learn. So if you join the DevOps training course, we are covering Docker as a tool which provides containers. But to create container, no, you never create container. You launch a container. Okay, you never directly create a container. Never. So basically, there are three items that are needed for you to create a container. You always create a file, or you take, for that matter, any containerization tool like Docker, Rocket, Cryo, Containerd, Linux containers. Any containerization tool, Docker being the market leader. So we all always think container means it is Docker. No, it is not that. Okay, so there are many other tools and all of them mostly follow the same process. What they do is they create a file, manifest file, or a file which is called, as in case of Docker, called as a Docker file. In the Docker file, any administrator who has to deploy the code will write the instructions, okay, needed to deploy the application. Needed to deploy the application. Okay, and then friends, after that you are this Docker file. So here in the Docker file, you provide a simple instructions as to what you need to deploy your application, to run your application. You provide this Docker file, and this Docker file is built into an image, friend. Docker file or a manifest file is always built into an image. Image is nothing but, if I have to define, a static file which which is a set of libraries and binaries for your application. It's a static file. It just holds the binaries that are needed for your application. Now this image, when you run an image, is when a container is created automatically. You never create a container. You always create a Docker file, build the Docker file. You build the Docker file and then run the image, build the Docker file into an image, run the image. That's when the container is available for you. It is available and is in running condition. As a user, from your browser, you access this container. From the browser, as a user, you will access this container and your application will be available to you. The running instance of an application is called as a container. The static instance of your application is called an image. What should be an image is on your Docker file. So let us quickly write a Docker file with help of Jenkins friend. So let me show you. Okay. So what are we going to do is now, let us go to Jenkins and create a job. So let me continue the same pipeline. You can very well create another job also if you want, but let me write down here itself, deploy. So after this stage, now I'm going to write the next stage, which is going to be my deployment stage. Now for deployment, my steps are following. Okay, and before deployment, I need to connect to my server and install Docker on my system. We need to create containers, right? So let me quickly connect to my AWS machine and install Docker on. Let it connect. You also need to start Docker. Docker is a service that needs to be started. That is one thing. The next thing that you have to do is you have to go to a file called as vim etc sudo ers file, where you need to provide Jenkins. Okay, already there is permission. You need to provide Jenkins user full permissions to execute any command. Okay, any Docker command or any command on this server. Right, I've already provided Jenkins as a full user permissions. Okay, now let's go back here and start creating the steps for deployment. So your deployment could be on a QA server, deployment could be on a staging environment, deployment could be on production. Same steps can be followed. Okay, so I'm going to write a shell script here and I'm going to say label, comma, script. Okay, so let's start writing the script here. My script is going to be, I'm going to start creating a directory, mkdir. Okay, so on my Jenkins server, wherever this stage is created, I want to create a directory called as my deployment, okay, or my app, anything. After that, I want to go into the directory. And after that, I want to copy the file. Now, we want to copy the address book war file, the war file which is generated into this directory, friends. So let me save it and go to the stage, package stage, where you can see the war file. So please go here, go to the workspace. In the not to the workspace, go to the console output, which was last run. At the end of it, you will get the location where your war file is present. So this is the location where my war file is. Go to your pipeline and mention here, copy at this location, this war file in the current directory. After this, I'm going to create something called as Docker file. Docker file, and I'm going to ask Linux to run this Docker file until it meets end of text. Read Docker file. Read Docker file until you meet end of text. Now let's write down the Docker file. Docker file is nothing but a set of instructions that you want, instructions about the application and the softwares that you want on your container. So from is the base of your container. Like I want Tomcat on my container. After that, I want to add whatever is this address book war file. I want to add it. I'm taking Tomcat version 9. I want to add it to the Tomcat's root directory, which is user share Tomcat web apps. Okay, in this directory. After that, I also want to expose my container to the port 8080. Every container will be exposed to one particular port, friends. It will be so that you can access the container from the browser of your machine. So it's mandatory that your container, if it is of web application, it should be exposed to a port 8080. Okay, and I'm going to run a command to start Tomcat. The command is, now you don't have to write all this, friends. You can very well go to hub.docker.com and search for the Tomcat image. Over there, it is, everything is available. So this is the Tomcat image. If you want to deploy an application on a Tomcat server, so if you scroll down, you can get complete information here. To start the Tomcat server, here is the command. To deploy on Tomcat, here are the to create a Tomcat container, to remove a Tomcat container. They have not given anything, but however, here is the home directory of Tomcat, and this is the command to start Tomcat server. Same thing I am mentioning here, start Tomcat server. Okay. Once I start the Tomcat server, I stop my Docker file here. That's all. So this is a set of instructions that I'm passing to Docker to take this Docker file and build it into an image. Now, so the Docker command to build the Docker file into an image is sudo docker build, okay, -t. Build the Docker file into an image. So let's give an image name, my app version 1. I'm giving the name dot. Okay, sudo docker. Run this image now. Run the image in a detached mode. That means keep creating my container, let it run in the background, and do a port mapping. Now, if you join the Docker session, that's when we can explain you the topics of port mapping, what is detached mode, right? Port mapping, to tell you, is when the container is created, there should be a port number using which you can access it. So that port number you will get from this option called as port mapping. Give the image a name, my app version 1. Okay, that's all, friends. Let me close the script. Right, so I've started a script here and it went on to create this. So these are the steps that I've executed. Closing the stage. Stage is closed. Stages are closed. Why there is an error? Steps are closed. 1, 2, 3, 4. Let me save it. Yeah, there is no more error. Okay. So these are the steps to deploy your code as a container. So let me save it and let me run it. So my Jenkins and Docker are on the same server RP. If they are in different servers, then you have to use SSH to connect Jenkins to Docker. Currently on my same server, I have Jenkins and I have Docker. So it does not need to connect to any other machine. But in real time, of course, you will have another server where you would want to deploy it. So you need to create an agent on Jenkins. You need to create an agent on Jenkins that will that the master will connect to it and deploy it as a Docker container on the third server. Okay, so I think it has created the container for us. Let us first go and see if it has created an image. So in the DevOps training, we do execute those pipelines using Ansible playbooks also. You can deploy your code using Ansible playbooks and Docker containers. Okay, so let me see. Systemctl start Docker. Docker images. Your image should be available. See my image. No, my image did not get created, friends. I think is it in progress? Please see here. So here my Docker file has been built. No, it did not. It did not build it. There's a warning here. Let me finish this. So I have the Docker file with me. Let me just quickly finish it. And how to use CI/CD for QA testing. So after the package, after you have deployed Mohammed, so after the deployment is done in the QA environment, the container of your application will be available. Then push your Selenium test cases into GitHub. Those test cases which are written by the testing team. Now create a next job here called as system testing, or create a job like integration testing, and ask Selenium. Clone the Selenium test cases repository and use Jenkins to run it, Selenium test cases. And you can also create a job in Jenkins to run the JMeter test cases for performance testing. Yes, Ansible Playbook is not an alternative to Docker. Ansible Playbook will trigger the execution of Docker containers. Now, however, my deployment has failed. Let us go and check it. Cannot create the directory, file already exists, so directory is already available. That is why it is failing. Let us go and quickly make changes to it. That is okay. So basically Ansible is again a similar automation server where you write a playbook to install Docker, to start Docker, to create Docker file, to build a Docker file into an image and run it into a container. So Ansible can trigger everything for you on hundreds of servers. So here it is now creating the image. Can we integrate test cases report to the some test case management tool as well as with Jenkins job? You can. So test case reports like your HTML reports, your TestNG reports, your JMeter reports, your extent reports, you can. Okay. And see here, one image has been created and one container also got created. See, your image has been created and your container also got created. You can go and check it here. Docker ps-a. So here one container is just up and running on the port 49153. So if I take the public IP address of my server and go to 49153 / address book. So here we have successfully deployed the application. Oops. Okay. Let me just see. Okay. All right, friends. And now I know the reason why it is not deployed. We need to make a quick change. I'm going to build now again quickly on those 100 servers. Now I think we should be through with the. So I have a container 49154. So here you go, friends. We have successfully deployed our address book application. I have started from the scratch, build the code, that is, compile the code, unit tested the code, package the code, and deployed it into a container.
Moving on to our next question. What does the CI/CD pipeline help achieve in DevOps environment? And the options are A. Manual deployment of applications, B. Automated testing and deployment of code changes, C. Version control of software, or D. Real-time monitoring of applications. If you know the correct answer, please comment down below. We have covered CI/CD, the backbone of DevOps. Next, in What is Jenkins, you will discover a tool that automates CI/CD, making software delivery even smoother.
What is Jenkins and how does Jenkins fit in this particular picture? Now, Jenkins is an open source automation server which helps us to automate the process of development relating to testing, deployment packaging, and others. It is a server-based system that run on software, Apache Tomcat. Now, it supports VCS store like Git, Bitbucket, etc. It also supports build automation tools like Apache, Maven, and it helps to make and facilitate our continuous integration and continuous delivery process. Now, Jenkins was first released in the year 2011 and it's completely open source software as a part of the MIT license. Jenkins is a plugin based profile. In Jenkins, you have got plugin which basically used to interact with different tools and components. In Jenkins, plugins are primarily released in language other than Java. Plugins are available to integrate Jenkins with most version control system tools and most databases. Using these plugins, we set up purposes, for example, unit testing. Now you can do compiling, you can do packaging. Now you can create some reports. Now you can do some logging. Now all these things are possible using plugins and Jenkins. Another important component that we've talked about in Jenkins, apart from plugins, is Jenkins notification, which we call it as Mailer. Using Mailer, guys, we can configure email notification. For instance, you can configure scenario. For example, you want mail notification when build is successful. Now, all these things can be done using Mailer as the Jenkins component. Another important component in Jenkins is the SSH agent. Jenkins also follow a typical master-slave topology. Now, why do we need a master-slave topology and a CI tools like Jenkins? Now, when you work in the organization, we have got multiple teams which you want to build and deploy their own pipeline or deploy their own software project codes. Now, teams don't want the piece of code to be run on a server which is owned by some other teams. So what we can do is we can set up a master-slave topology where Jenkins may run on a server X. But you can connect multiple other servers which will act as a slave. So when you are deploying a code executing a pipeline, you can run those codes on those XYZ servers. Now this is the beauty of using Jenkins master-slave topology. Now another good thing about Jenkins is Jenkins can be deployed on any operating system. In Jenkins, you can use in a Windows mode, a Linux mode, a Mac mode, or now all these Jenkins jobs can be deployed on any operating system. It is not at all dependent. Now both master and slave needs to be of the same operating system. Another important core component of Jenkins call is JavaDoc. This is our plugin in Jenkins, which basically is a part of Jenkins core that helps us to publish results like build action, build directory, what is the expected build output. All those things that we see in Jenkins, they all are happening using JavaDoc. Now let's talk about security injection. Apart from that, Jenkins have other sorts of authorization like project-based strategy, metric-based authorization, which help us to make Jenkins more secure. We'll talk more about this when we talk about the Jenkins overall. So as you can see on the diagram, Jenkins is pulling code from the source code control system like Git, Bitbucket, etc. To start deploying it in Jenkins, we have got a notification management system using Mailer, where if the bit is successful, we get a WAR file or a zip file. we can define how we want the build to be created, and if it is a failure, it will send the notification management to a developer that something happened wrongly with the specific code lines and you need to rectify your codes. Now that is the beauty of using Jenkins. So Jenkins is still the bread and butter in the industry. There are some Jenkins competitors also in the market like GitLab Jenkins and some others. But by default, Jenkins is the to-go tool for the CI industry. So far we've talked about Jenkins. Now let's talk about what is pipelining in Jenkins. Now let's say I want to deploy a code. The code may have certain steps like first step, I'm building the code. Second step, I'm compiling, then code reviewing, then packaging, then deploying. So how do I automate a combine of all these steps which can be executed in one go? Now to deploy all this scenario, we've created a delivery pipeline. Now pipeline is nothing but it's a combination of different steps or different tasks that we need to perform in order to deploy our code. Now using a pipeline, instead of doing this task or code deployment manually, we combine them and deploy them as a sort of one common approach of a delivery pipeline. Now there are multiple ways on how you can create a pipeline. The two most common ways or common approaches of using a pipeline, as you can see from scenario, a declarative approach. And the second one that is used in the industry is a scripted approach. This particular is an example of a Jenkins pipeline script. Here you are saying we are first doing a stage called build stage, where we will be combining multiple tasks. Like first we are using Java, then we are printing something called echo hello pipeline. Then we are using Maven as the build automation tool and try to deploy a package, and then we are doing a shell script output of what all things are present in that particular directory structure. This is a typical example of syntax of how to create a pipeline in Jenkins. Now let's talk about the two predominant pipelines that are used in the IT industry, scripted and declarative. Now let's talk about what is scripted and declarative and how they are different from each other. A scripted pipeline is a traditional Jenkins pipeline approach, and a declarative pipeline is a modern day pipeline approach that is used in the industry. In a scripted pipeline, the syntax was first strict, while in declarative pipeline we use something called as groovy syntax. When you use a declarative pipeline, you can get a code from any version system tool like Git. You can create something called as Jenkins file, and you can download Jenkins file from a virtual constant tool, and that can be used to run your Jenkins code. When you use a scripted pipeline, you define a code something called as a node block. But one declarative pipeline will define a code in a pipeline block, as we can see in the previous example. Now let's talk about what is Jenkins file and how it can be used. Now Jenkins file are like a text file where you define your entire structure and syntax of your Jenkins. You know only how to download the file, and in particular, you can just give the part of your Git repo. If it is true, then get the credential, the private repo, and it can pull all the contents from there and just execute your code. It is a modern deployment mechanism that we use when we work with a Jenkins pipeline. Using Jenkins pipeline, we use certain things which help us. Let's talk about this. First is code review. Now you do a Jenkins pipeline, you can easily review your code. Your code can be reviewed by multiple developers before being executed. Now how that works is, in Jenkins file, they are stored generally in a version control tool like Git. You can put something called as a pull request for a code review. Now different members of your team can review the code before you actually pull the Jenkins file and deploy it. Now you can do an audit trail, or refer to as a long audit. You can log each and every step's output that is being executed as part of the Jenkins file, and can see what is happening when the Jenkins file is getting executed. It's sort of like a verbose log. Then you can find a single place to store all your data or all your outputs. You don't need to have developers scattered here and there and writing their own codes for executing a Jenkins pipeline. Whole organization can approach a Jenkins file methodology where code can be stored in a VCS tools, and from there the code can be downloaded and can work as a single source for your entire pipeline. Now let's talk about the Jenkins workflow in particular. How does Jenkins workflow work? Jenkins workflow always start with a version control system, or you can say a source code repository. Multiple developers collaborate and they put their code in a source code system like Git, from where Jenkins try to pull the data from that source control system. For your system, there is no mandatory or the source code needs to be Git. It can be Bitbucket, SVN, whatever your organization uses with Jenkins server. Now we execute tasks like build, deploy, compiling, packaging, code reviewing. Now all these things happen using Jenkins server, where your Jenkins actually installed was running. Now Jenkins server can be any operating system. It can be a Windows machine, Ubuntu machine, Linux machine, or a Mac as well. It can be any operating system of today's modern world availability. Using this Jenkins server will execute our different tasks and scenarios. In Jenkins server, we use the mail functionality for the feedback mechanism. We notify developers the commit or the code deployment successfully or it is a failure. It also has some challenges. Now, what can be done using the feedback mechanism? Possibly using the Jenkins server. So using Jenkins server, we always first deploy the code on a lower lifecycle environment. That is recommended standard practice. So what we do is we first deploy a QA server on a testing server, and once the code deployment is successful on the lower lifecycle, then we go ahead and deploy the code on a production server. That is how the entire Jenkins workflow, mainly particular, interact first. Now guys, let's talk about the Jenkins installation and how to install Jenkins in a machine. As you all know, Jenkins by default run on 8080. So please make sure that if you're using any VMs in your organization, the port 8080 firewall settings are open and configured so that it can be accessible. I will get into some of the prerequisites required for installing Jenkins first, which will go ahead and install Jenkins on a Windows box. Now there are a few first configuration that needs to be done, and I'll be covering those as well. So once I have Jenkins installed and configured properly, I will get into the user administrative part, then create few users, and I will get into some of the plugins for setting up various kinds of access permissions for these users, and I also put in some of the freestyle jobs. Freestyle job is basically nothing but a very simple job, and I will also show you the powerfulness of Jenkins by scheduling this particular job to run based upon time schedule. Then I will also connect Jenkins with GitHub. Now GitHub is a source code repository where I've got some repositories put up there. So using Jenkins, I will connect to GitHub, pull up a repository that is existing on GitHub onto the Jenkins box, and then run a few commands to build this particular repository that is pulled from the Jenkins sending out emails. Now it's a very important configuration of Jenkins or any other continuous integration server for that particular matter. Now, whenever there is any notification that has been sent as a part of either build going bad or by being good or building propagate to some environment and all these scenarios, now you will need the continuous integration servers to be sending out notification. So I will get into the bit of details of how to configure the Jenkins for sending out emails. Now, I will also get into the scenario where I will have a web application such as a Maven-based Java web application, which will be pulled from the GitHub repository, and I will deploy it into the Tomcat server. Now the Tomcat server will be locally running on my system. Eventually I will get into the other very important topic, which is the master slave configuration. It's a very important and pretty interesting topics where distributed builds is achieved using a master slave configuration. Now all this can be very easily based up using a plugin. So this is what I'm going to be covering as a part of this tutorial. Now, Jenkins is a web application that is written in Java, and there are various ways in which you can use and install Jenkins. Now, I've listed the popular 3 mechanisms in which Jenkins is usually installed in any system. Now, the topmost one is a Windows or a Linux-based services. So, if at all you have a window like the way I have, and I'm going to use this mechanism for this demo, so I will download the MSI installer. So, whenever you start as a service, it goes out and nicely install all that is required for my Jenkins, and I have a service that can be started or stopped based upon my needs. Any flavors of Linux is one of many other ways of running Jenkins in downloading this generic WAR file, and as long as you have a JDK installed. You can launch this WAR file by the command opening up a command box prompt or shell prompt deferred to later on Linux box, specifying jar and the name of this WAR file, typically bringing up your web application. And you can continue with your installation. Now, the only thing being, if at all you want to stop using Jenkins, you just go ahead and close this prompt, even into a Control-C, and then bringing down this prompt and in Jenkins server. And then you also have the other older versions of Jenkins where run popularly using this way, in which you already have a Java-based web server running up and running. So you kind of drop in this WAR file into the root folders or the HTTP root folder of your web server. So Jenkins will explore and kind of bring up your application. All user credentials or user administration is all taken care by the Apache or the Tomcat server or the web server on which the Jenkins is running. This was a very old way of running, but still some people use it because if they don't want to maintain two servers, now if they already have a Java web service which is being nicely maintained and backup, now Jenkins can't run a test to it, alright? So either ways, it doesn't matter however you're going to bring up your Jenkins instance, the way we're going to operate Jenkins is all going to be very same or similar, but the subtle change in terms of user administration. Now, if at all you're launching it through any other web server, which will take care of the user administration, otherwise all the command or all the configuration or the way in which I'm going to run this demo is going to be same across any of these installation. All right. As I mentioned earlier, Jenkins is nothing but a simple web application that is run in Java. So all that is needed is Java, preferably JDK 11 or 17 with a 2 GB RAM, which is a mint RAM for running the Jenkins. And also, like any other open source tool sets, when you install JDK, ensure that you set in the environment variables. Now Java home to point in the right directory. Now this is something very specific to JDK. Now, but for any other open source tools that I've installed, there is always a preferred environment variable that we got to set in which is specific to that particular tools that if you're going to use. This is a generic thing that there is for you to know. Now for any other open source project, because the open source project discover themselves by using the environment variables. So as a general practice or a good practice, always set these environment variables according. So I already have a JDK 17 installed on my system, but in case you do not, what I will recommend is just navigate to the browser, to the Oracle homepage, just type in your search for install JDK page, then you'll have the accept the license agreement. Now what I will recommend is just navigate on your browser to the Oracle homepage and just type in your search install JDK. Now you're gonna navigate to the down here and install the 64 installer, that is the .exe. Now let me show you once I have installed what I've done with regards to the path. So if you get into these environment variable, so I have just set in the Java home variable. Now you can go back to your this PC, go to C programs, go to Java, and then copy this part, then click in the environment variables. I'll select the first one, that is the edit the system environment variable, and we click on the environment variables and we'll set a path here. As you can see here, Java home, and we'll go down here on the path. So this is the path for your Java home screen. So simply click on edit and click on new, and we will just paste the path which we have just copied from the install.exe Java. So I've already installed it, as you can see there, C program files. I simply click on OK. So the only difference between the system variables and the user variables for daemon is this is control the whole system of the JDK, the system variable. So we want to edit in the system variables. So the path I've been changing here is in the system variables. All right. Now the home variable is where I have the SQLs and program friend of the JDK 17. Now you see this is my Java home. Alright, now one thing to do is ensure that in case you run Java or Java C, for a command, you ensure that you also add the path into this path variable, right? So if you see somewhere, I will say there you got the colon program files. Now you click on that and I'll show you the bin as well, which I've copied and pasted here as well. Okay, so simply just go back. So that's how you get the bin. Copy this path and paste it here, which I've already done it. So I'll just simply click on OK, OK, and OK. Now let me minimize the screen as well. So the next thing we need to do now is go to CMD to check if your Java has been installed on your system. So you simply type on Java space / version, and you can see I already have Java version 17.0.5 installed in my system and it's up and running. So as you can see the runtime environments, and this is a 64-bit server. This is a VM virtual machine. Okay, so as you can see, Java is installed in my system and is up and ready. So the next thing we need to do now is install Jenkins. I'm just canceling that out and open a new browser again, new tab, and type in jenkins.io. Now as you can see, this is the homepage of Jenkins. All right. So you can even read the documentation, or you can simply click on download. Will take you to this page. Now here you can see the hardware and software requirements, then what packaging is required for downloading the installing Jenkins. So this is the part for, on the left hand side we have the LTS, and on the other side we have the which is a more stable, and on the right hand side we have the regular weekly releases. So we'll definitely go for the stable LTS download, which is a long-term support, which is released every 12 weeks, whereas the regular releases changes weekly. So I'll be going ahead and scroll down and click on window. So as you can see, there are different parameters where you can do. You can have on Dockers, then you have Ubuntu, then we have the CentOS, Fedora, or the Windows, like I'm going to install in this case in this demo. Then but we have different aspects as well, like the FreeBSD, the CentOS, Mac OS, etc. So as you can see on the first stop, we have the .var. We can even install that and unzip that. But in this case, in this demo part, we'll simply click on Windows. So go on ahead and click Window, guys. Now you can see the download has started. So we just wait a few seconds until it's done installing the MSI. And as you can see, it's done. So this is my download in Jenkins instance. So what I'll be doing now is simply click on next. Now, as you can see, guys, on top here, it's written the Jenkins run on localhost 8080. So keeping that in mind, click on next. As you can see, this is where our Jenkins is installed. That is in C and program files and by the name Jenkins. So you can always change this location where the Jenkins has been installed. But in this case, I'll rather keep it on the C drive itself. So the next thing you need to do now is we'll run server as a local system so that we don't have to put any administrator or the password. And so the next step now is we test the port. So as you can see, you got a green tick mark. So we'll click next. Now you can see here that it has failed because there is no compatible Java version 11 or 17. But as you can remember, guys, we have already installed Java 17 and we have already verified that we're using the command prompt where it has shown us the version Java 17. So what you need to do is simply click on change and select the Java 17 from Java 8. So simply click on Java 17, JDK 17, as you can see, click on next and click on the install part. Done and dusted. So I've already told you that Jenkins run on the localhost 8080, right? So we're gonna go localhost colon 8080 and hit on enter. Now, as you can see, please wait while Jenkins is getting ready for work, right? So this will take a few minutes and then you'll be having to provide the credential of the administrator. All right, so just give it a few minutes while it's starting up. All right, now you have to provide the administrator password, right? So you can go ahead and go down out here. You can see the password is in the C and goes to the program data, then Jenkins. Then we have a .jenkins, then a secret, then you'll find the initial admin password. So we need to head out there. So what we need to do is we'll go down there. So I'm just going to minimize the screen now, minimize it once again. And as you remember, we go to the C. So you can see right where it is. I'll just show you, minimize the screen here so you can see and do it along with me. So you can see this in PC, then scroll down to C disk. Okay, this thing popped up, sorry. It's in this, so you have a program data, right? As you can see here down, there is no program data, right? So what you need to do is it's in the hidden file. So what you need to do now is click on the three buttons and view, click on show and click on the hidden items. Now let's see if it's there. Scroll down, program data, you can see at the last. Yeah, simply click on that, double click on it. As you can see, then we have to go to the folder name as Jenkins. Yeah, you can see on the top, Jenkins and .jenkins. Then we need to search for secrets. There it is, folder. And as you can see, there's an initial admin password. Now you simply click on that. We'll try with the notepad so we can copy. So simply copy that and paste it in the administrator password and click on continue. So in this case, I will not save it in my computer or system. So there are two installation plugins available, which is custom by Jenkins. One is they have suggested plugins, and the other one is you can select the plugins which you want to be installed. So in this scenario, I'll simply click on the install suggested by the Jenkins. Now what happened is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugins and got a dependency which is not installed and you get all those issues. In order to get rid of that, what Jenkins recommends is that there are a bunch of plugins that is already recommended and they are good to go, right? So just go ahead and blindly click on that recommended by the plugins, which is a suggested or custom by the Jenkins. And as you can see, these getting started process is going ahead. So it'll take a few minutes depending on your internet speed or on the system. Now you can see all these plugins are installing it for you. So it will take a few minutes time. So let's just wait till we get all the plugins installed in a system properly. So this is a good combination to kind of begin with, and keeping that in mind, Jenkins need a lot of bandwidth, right? Now in terms of network, so in case you know your network is not so good, it'll make for a few of these plugins will kind of fail, and these plugins are all are available on openly or mirrored site, and sometimes some of them may be down. So do not worry, in case some of these plugins kind of fail to install, you get an options to kind of retry installing them, but just ensure that you at least at the most 90 to 95% of all of these plugins are installed without any problem. As you can see, we are almost there. It's around 60% to 70%. Now once all these plugins are installed, now my plugin in the installation is all good. There's no failure in any of the plugin. So after that, we have got to create this first username, that is the first admin user. So you need to give in the username, then the password, then you have to confirm your password, give it your full name and your email address, right? So we'll start it by giving the username. I'll keep it plain and simple. Now you got to remember these password and the confirm password, because if you kind of lose or you don't remember the password of the Jenkins, it'll be really hard to get back your account. So try to keep it as simple as possible, and keeping in mind that you have to remember the password, because getting back this account will be really difficult. All right, so I'll be putting the password as well. Give it my full name. Okay, my A is small, and go to the email address @edureka.co. All right, so once it's all done, so just simply click on save and continue. So click on never, don't want to save the password. And as you remember, I've told you by default Jenkins run on localhost 8080, right? So you can simply click this, or you can copy this, or just write save and finish. You can even copy this link, save and finish. Now start using Jenkins. All right, now that's kind of complete my Jenkins installation. As you can see, it was not that tough at all. Now the Jenkins is installed correctly. Now let me quickly walk you through some of the very minimal configuration that is required. Now these are kind of the first time configuration that is required. So, and also let me warn you, the UI is a little hard for many people to wrap their head around, especially the window guys. But if you're all a Java guys, you know how painful it is to write UI in Java. You kind of appreciate how the effort that has gone into the UI bottom line. It was a little hard to wrap your head around. It becomes like start using it, possibly you start liking it all right? So I will get into some of these important ones, something called as configuration system, or the configuration a system. This is something kind of put in your configuration to complete your Jenkins instance. Now few things to kind of look out for. This is the home. Now configure system is where you kind of put in the configuration for your complete Jenkins instance. Now a few things to keep a lookout is the home directory. All right, now this is a Java home where all the configuration, all the workspace, anything and everything regarding Jenkins is stored out here in the system message. Now in the system message, you can put in some of the message on the system. You can just type anything you want, probably show up somewhere here on the menu. Now the number of executors is a very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. So you can kind of visualize like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, the number of executor you should be good enough in case at any point if there is any multiple jobs that kind of get triggered at the same time. Now in case the number of executor are less compared to the number of jobs that are out there to open up the new, so you don't need to panic, because they will get queued up and eventually Jenkins will be get up and running. So just keep that in mind that whenever a new job kind of gets triggered in the CPU usage and the memory usage, in terms of the disk, it's like a very high of the Jenkins instance. So that's something you got to keep in mind. All right, the number of executors for my system is kind of a good label. For my Jenkins, I don't want any of these usage. So how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this as low as possible. All right, as you can see, it's 2. Now this is usage. So I can leave everything to default. So what I want is I want this SMTP server configuration. Now Jenkins will be sending out some emails. What I've done here is I've configured the SMTP details of my personal email details. In case you are, in your organization, you want some sort of an email that is like an email ID that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of like send out emails. But in case you want to try it out like I have configured my personal email ID, which is of the Gmail for sending out notification for the same TP server, will be the SMTP Gmail. So it's right as username as so we have used SMTP authentication and then we're given the password. Now you can just send out an email to see if at all this configuration works again. Now Gmail will not allow you to allow anybody to send out notification on your behalf. So you just have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notification on your behalf. So I've already done that. So let's see if this works. Let's test it again since I've entered the wrong password. Let's see if this works or not. And it has given me a password has not accepted. So now as you can see, since my Gmail has not been set up, so what you have to do is you have to lower your security level of your Gmail ID so that you can be allowed to test your email configuration. All right, so simply click on save. So now we're heading back to the dashboard. Now we should go to the global tool configuration. Now look at the scenario where Jenkins is a continuous integration server. Now it does not know what kind of a code base it's going to pull and what kind of tool says is required or what is the code that is going to pull in and how it is going to build. So you'll have to put in all the tools that is required for building the appropriate kind of code that you're going to pull in from like a source code repository. So for example, in case your source code is a Java code, and assuming that you have, because this demo, this is my laptop and I put all the configuration, JDK, everything on my laptop because I am a developer and I'm working on the laptop, but my country's integration servers will be known as a separate server without anything being installed on it. So in case I want Jenkins to, like run on a Java code and I need to specify the JDK location of this out there. So, okay. Since I've already have the JDK installed and have already put in the Java home directly or rather and the environment correctly, so I don't need to do it. So now if at all you want the Jenkins server to use Git, now as you know that Git is a command bash or the command prompt for running Git and connecting to any other Git server. So you will need Git to be installed on that particular system. Now Gradle and Maven, if at all you have some Maven as you want to do this and any other tools that you're going to install on your system, which is your continuous integration server. So you'll have to come in here and try to configure it. And in case you have not configured, then Jenkins will not be able to find these tools for building your task. So since I don't want to install anything, we'll go back to manage system. Now you can see the global, configure global security. Now you can see this an SSH server. Now what does this mean if you ask me? Jenkins own user database. So this is nothing but the security access control which is set to Jenkins own user database. So what this mean is, Jenkins by default it uses files system where it stores all the usernames which hashes up like these username that kind of stores them as of it. So as of now, Jenkins is configured to use in your own database, assuming that you're running in an organization. So you will probably want to, have some sort of LDAP server, which will in turn have a control of your access to your Jenkins repository. So you will specify your LDAP server details, the root DN password or the managed DN. So the LDAP, as you can see, or the LDAP, which the Jenkins itself will tune in for your specific servers. Now you have the manager DN, the manager password. Now all these should be filled, all these details should be filled in case you want to connect your Jenkins instance with your LDAP server or any of the authentication server that you have in your organization. But for now, since I don't have any of these things, I'm going to use its own database. That's good enough, right? So I'll simply the Jenkins own user database. So I will set up some authorization methods So for now, let me not get into any of these details of this. Just be aware that Jenkins can be connected for authorization to an LDAP server, or you can have Jenkins managing its own server, which is happening as of now. Let me put in a very simple job. All right, so let's create a new job in this video. So simply click on new item. Now simply you can add any item name here. So the most important here are the freestyle and pipeline. Now for the first demo, we'll click on the freestyle job and click on OK. So in the description, you can write anything in your description. This is an optional thing. So you can say this is my first job demo for. So in this demo, I don't want it to connect it to any source code for now. So I'm just going to leave it to none. Now we don't need to write any build environment as well. Now in this build step, we simply click on execute Windows on. So since I'm on the window box, I will say execute window bash command. All right. So what do you want to do? So let me just echo something. Echo hello world. This is hello. Welcome to my first demo job in Edureka. Then we'll specify the date and time as well. So put in date, colon as time as well. So you can see it's a very simple command. You just have to put an echo and we have something along with the date and time. So we'll keep everything as simple as possible. So we'll save this job. So once it is shipped, so you can see there's a build history. So once you have saved this job, you know, the job name comes up here. As you can see, project first job. By mistakenly, I've written double T in my first job. Now as you'll see here, there's a builds history. So there is nothing as of now because I've put in a job. I have not yet run it all right. So let me try and build it now. Now you can see there's a number, my first job. So you will see a date and you will see the time since I've clicked twice. So if I've come 1 and 2. Now if you click on this, now you can see the console output. Now if you click on this, now you can see it. And this is the output that is run. Hello, welcome to my first demo job in Edureka, along with the date and along with the time. Now if you see this, now if we navigate this, we go back to here. Now as you can see, there's a folder created as jobs, right? So this is the directory what I was mentioning earlier regarding Jenkins home. If you can just open it up wider, you can see this folder jobs. So this was mentioned earlier regarding Jenkins home. So all the job related stuff, it's specific to this particular Jenkins installation is all here. Now all the plugins that I install, the details in each of those plugins can be found here, right? So the workspace is where the jobs that I've created, whichever I'm running will, you know, there'll be an individual folder specific to the jobs that has been put up there. All right. So one job, one quick run. That is how it looks like. So the workspace is where all the jobs that I've created, whichever I'm running, will, you know, there'll be an individual folder specific to that jobs that has been made up. All right. So as you can see, there's a first job that we have just created just now. So one job, one quick run that we have done. That is how it's look like. It's pretty simple. Now let's go back. So let us put on a second job. So we can go back to dashboard, click on new items and say second job. Let's get the spelling correct this time. Second, I wrote second first again. Second job, and I can put a semicolon here, underscore. Second job. We click on freestyle again. Click on OK, and you can say this is my second. So I just want to demonstrate the powerfulness of the automation server and how simple it is to automate a job that is put on the Jenkins, which will be triggered automatically. Now remember what I've said earlier about Jenkins, because at the core of Jenkins is a very powerful automation server. All right, this is my second job. This is my second job, which will be triggered automatically. Okay, so in the build step, we'll put bash tabs, then we'll write here echo again. So we'll say here something as second job is going on here. The tools, with the tools of an automation tool. And then I'll give some date as well. Date, put in the time. But this time I'm going to demonstrate the powerfulness of the automation server that is there. So if you see here, there is a build trigger. So build can be triggered using various triggers that is there. So you'll get into the GitHub trigger or a hook or a webhook, which is kind of triggering. So we'll see that later on. But for now, what I want to do is I want to ensure that this job that I'm going to put in will be automatically triggered. Let's say every minute I'm on this job to be run on its own. So we'll put as build periodically and we will set the time. Now, if you can see here, There's a bunch of help. If you want to go through it, you can go through it. Let's just put out very simple regular expression for scheduling this job every minute. All right. So 5,000 is all I'm gonna put in. 1, 2, 3, 4, 5. Now let me save this. Let's go back. So when you build periodically, now you can see here. Now we just copy that, and now how do we check if it gets triggered every 15 minutes? So I just don't do anything but wait for 15 minutes, and if everything goes well, Jenkins will automatically trigger my second job in 15 minutes. Now you can see here it's still processing, so we have to wait for 15 minutes. Now we can go through all this command of the scheduling time, so you can see how many stars required for each minute or for each hour. Now as you can see it's done. You can just go and go here and go to console output. Now you can see the finish is success, and you have this. Now we can go back and copy this and see if they're on your it's already there. You can go to workspace. You can see your second job has also been created automatically by Jenkins. Now that I have my Jenkins up and running, a few jobs that have been put up here on my Jenkins instance, I will need a way of controlling access to my Jenkins server. This is where I will use a plugin called a role-based access plugin and create a few rules. The rules are something like a global rule and a project rules for a specific role. I can have different rules, and I can have user who have signed up, or the users from my create kind of assign to these roles so that each of these users fall into some category. This is my way of kind of controlling access to my Jenkins instance and ensuring that people don't do something unwanted. All right. So first thing first, let me go ahead and install a plugin for doing that. So we get into manage Jenkins, then we go to manage plugins. We will plugins, install plugins. We have advanced settings. So these are the available plugins, and then if you go to install, now these are the installed plugins. Now let's go and search for a role-based. Now you can see here, base authorization strategy. So this will happen is it enables user authorization using a role-based strategy. Now roles can be defined globally or for particular jobs or nodes selected by a regular expression. This is the plugins everyone. So you will install it without restart. So it's success. It looks good. Looks good. Now waiting for this. Yeah, success. Done now. So go back to the top page. Now one thing to remember guys is Jenkins is running on a Java using a Java instance. So typically many things will work the same way unless inherently you want it to restart. So but a good practice is whenever you do some sort of a big installation or a big patches on your Jenkins instance, just ensure that you can restart it. Otherwise there will be a difference in terms of what is installed in the system and what is there on the file system. So you'll need to flush out few of those settings later on. But for now, these are very small plugins. So this will run without any problem. But otherwise, if at all, there are some plugins which they will need to restart, you can kindly go ahead and restart your Jenkins instance. But for now, I don't need that. So it looks good. I have installed the plugins. So where do I see my plugins and install the plugins? Just specific to the user control to the access control. Now let's go to the configure global security. Now we can go ahead and check the authorization. You can see here authorization role-based strategy popping out here, right? As you can see, the role-based strategy has been installed and has been shown here. This is because of my installation of my role-based plugin. So this is what I would want to enable because I already have my own database set up, and for the authorization part in that sense that you can do what I'm going to install. I mean, I've already installed a role-based strategy, right? Now I'm going to enable that strategy. So we'll simply click on role-based strategy, okay, and click on save. So now I'm going to enable that strategy. All right, now I will say, okay, now I've installed the role-based access plugin. Now I will need to just set it up and check, I will go ahead and create some roles, and it shows that I've assigned users as per these roles. So let me go to manage the configuration, manage Jenkins, and let's see how we can create our roles. Not here as well. So we can do manage and assign roles for creating a roles. Okay. Now you'll only be able to see this once and only when you have installed those plugins. Now I've enabled the plugins. Now I've enabled the role-based access control as well. Now we'll go ahead and create some rules for this particular Jenkins instance. So first I will manage roles. So this is at a very high level, which is a global role. Now there are some role to add which you can add by yourself, some item roles for some projects or something. So let me create a role that's kind of visualize like a group. So we'll create our own called the developer. Typically the Jenkins instance or the CA instance are kind of owned up or controlled by a QA guys. So that's why I'm creating a role called developer, and I'm adding this role at a global role. So I will add this here, and then so I can click read as well. So we've given this administrator, right? So we add this. So as you can see here, you will see this develop a rule that there is each one of these options that you can hover here and sort of see what kind of permission you have given it to this developer role that you have just created. So you can read and write, then you can create some changes. We've given a permission as credential, which you can create. Then you can delete, then manage the domains. So this kind of help or the permission that they're giving it. So these are some kind of sort of a help for a permission specific. So you want to see it's like how it sounds a little different, but I will want to give you a very little permission for the developer. So from an administrative perspective, I just want him to have a read and write kind of a role credentials. Okay, let's read and write, and I can allow him to view as well. I don't want him to create agents or give him some delete. No, I don't want him to configure, build, provision, or connect or disconnect anything. So I'll just give him a read and a view. And I don't even want him to have access to my workspace as well. So I'll just give him now for run. So I won't even give him the access to that. Now we can give view as well. I don't want him to delete. And what am I doing here is just creating a global rules for the developers. And I've given him a very limited roles, in the sense that I don't want this developer to be able to run any agents, nor create jobs or build jobs or cancel jobs or configure jobs at the maximum. Right? So I just want him to read that is already put up there. Okay, so I will save now and create a rule. That is done. Now that I've created a rule. Now I still don't have any users that is in there in the system. So let me go ahead and create some users on the system. So we'll go back to Manage Jenkins and go to Manage Users. Now let me create another user, okay, by clicking on plus users, and we'll say this one as a developer. Give him some password and name him as develop123. And email, and just simply give my email here and click on create users. Okay, 12. So we have created. Now this developer 12 is a user that I've configured, but still yet I have not set any rules for this particular user. So I will go to the manage and gain and will give him the manage and assign roles. So now we'll go manage and assign roles, and we'll assign role. So what you're gonna see, what I'm gonna do now is I'm gonna assign a role that is specific to that particular developer. So I'll find that particular user and assign him, or means the developer role that I've already configured the rules. Okay, so this is the role that we have created. So we will search the user that we have just created, developer 12. Now if I assign this, so go ahead and save the changes. Now let's go ahead and check the permission of this particular user by logging on to my main account and logging back as the developer one. Now let's log out from here. Log out and say developer 1. Now if you remember, this role was created with very less privilege. So there you go, I have Jenkins, but I don't see a new item. I can't trigger a new jobs. I can't do anything. I see these jobs, however, I don't think I'll be able to start this job. Now I don't have the permission to set forth at the maximum. So what I can do is look at this job, see. So this is a limited role that was created, and I've added this Damanang Lamare to that particular role, which was a developer role, so that the developers don't get to configure any of the jobs because the Jenkins instance is owned by a QA person. He doesn't want to give developer any ethnicity or right. So the rights that he set out by creating a developer roles, or any user who's tagged as a part of this developer role will get the same kind of permission. And these permission can be, fine grained. It can be a project specific permission as well. But for now, I just demonstrate the high level permission that I've set. So let me quickly log out of this user and get back to my admin account. So because I need to continue my demo with the developer roles that was created. Now, one of the reasons for Jenkins being so popular, as I mentioned earlier, is the bunch of plugins, but it's got plugin for connecting anything and everything. Now you can find the Jenkins plugins, then you will see the index over here. There are so many plugins that are there. All of these are wonderful plugins. Whatever connectors that you will need if you want to connect Jenkins to the AWS instance, or you want to connect Jenkins to a Docker instance, or any of those containers, you will have a plugin. You can go and search up if you want. If you want to connect Jenkins to Bitbucket, simply click on Big. So as you can see, these are available. So bottom line, Jenkins without plugin is nothing. So plugins is the heart of Jenkins for you to connect, or in order to connect Jenkins with any of the containers or any of the other sets of tools, you will need the plugins. Now, if you want to connect or you want to build a repository which has got Java and Maven, you will need to install Maven and GTK on an instance. Now, if at all you're looking for a Microsoft build, you will need to have MS Build installed on your Jenkins instance, and the plugins that will be triggered MS Build. If at all you want to listen to some server-side webhooks from GitHub, you will need a GitHub specific plugins. You want to connect to Jenkins, to AWS, you need those plugins. Now, if you want to connect Docker instance that is running anywhere in the world, as long as you have the URL, which is publicly reachable, you just have a Docker plugin that is installed on your Jenkins instance. So if you want to connect to a Docker instance that is running anywhere in the world, as long as you have the URL which is publicly reachable, you just have a plugin that is installed on your Jenkins instance. Now, SonarQube is one of the popular statistic code analysis, so you can connect a Jenkins build. You can build a jobs on Jenkins and push it to a SonarQube and get SonarQube to run analysis on that and get back the result in Jenkins. Now, all of these works very well because of the plugins. Now with that, let me connect our Jenkins instance to a GitHub. So now let us connect our Jenkins instance to a GitHub. Now I already have a very simple Java repository up on my GitHub instance. So let me connect Jenkins to this particular GitHub instance and pull out a job that is put up there. Right. So this is a very simple and repository is called Hello Java. And this is what is there in the repository. This is a simple class file. It's just got some one line of system.out. So this is already present on github.com at this place, and this will be the URL for this repository. So I will pick it up. So what I'll do is I will connect my Jenkins instance to go to my GitHub and provide my credential and pull out this repository which is on the cloud hosted in the github.com and get it to my Jenkins instance and then build this particular Java file. Now I'm keeping the source code very simple. It is just a Java file. Now how do I build my Java file? How do I compile my Java file? I just say java.c and name. Now the name of my class file is hello Java, and how do I run my Java file? I will say Java and hello. Okay, so remember I don't need to install any plugins now because what it all needs is a git plugin. So git plugin which is already installed on this system. So let us go back, create a new items. We'll create a first job here. Let's say this is a git first project. Now let it be a freestyle. Okay. Now we'll go to the source code management. Remember, right? We always have been keeping it on none. So in this part, we'll put it as git. Now, as you remember earlier in examples, we do not use any source code because we were just putting up some echo kind of jobs that did not need any integration with any of the source code system. So now let us connect this. So I'm going to put up my source code and it will show up because the plugin is already there. Now I've already copied the HTTP address from the GitHub and simply paste it here. Now what is the credential? So simply add that. If you add credential this time, so I'll just click and cancel. So if we just add Jenkins, so we'll add a username here. Now if there are any errors in terms of not able to Jenkins to be able to find the git or the git.exe, or if the credentials are wrong somewhere down here, so you'll see a red message, okay, like something is not right. So for now it's okay. Now I'm gonna build trigger. Now what will be there as a part of my build step, because this repository just have the Java file correct, hello Java. So in order for me to build this, I will say execute window bash command, and I'll say Java, hello Java, Java. Now let's save this. Okay, so let me try to run this. Okay, build now, click on this, console output. Great. Now as you can see here, there's a lot of executed git on the behalf. It goes on there to provide my credentials, and so it pull out my repository and my default. Now we'll pull up the master branch. This is there on the post string, and it kind of builds this whole thing on Java C hello world. Finish, and it's given me a success. So it's kind of build this whole thing Java C hello to Java, and it runs this Java hello world. And there, as you can see, this is the output. It's there, and here you can see, if you want to look at the content that was created on the repository. Now, if you can go there into my workspace, like I've showed earlier, you can just simply click here, and you can already see here it's been created Git first project, and it's saying hello. Now, as you can see, it's already there. Now, if you can go back, as you can see, and simply close that. Now, what it did was Jenkins on your behalf went over all the way to GitHub, pulled this repository from there, and then it brought it down to your local system on my Jenkins instance. Now it's compiled it and it ran this particular application. Now that I've integrated Jenkins successfully with Git, simply within the Java application.
Moving on to our next question, Jenkins is primarily used for, and the options are A. Container orchestration, B. Continuous integration and delivery automation, C. Version control, or D. Cloud infrastructure management. If you know the correct answer, please comment down below. Having explored Jenkins, we will now discuss why Docker, where you will learn why Docker is essential for containerizing applications in DevOps environment.
So since Docker is a containerization platform, it's important to understand what came before containerization, or what is the history of containerization. So before Docker came into the picture, before containerization came into the picture, there was this concept of virtualization, or basically using virtual machines. So virtualization was this technique of importing a guest OS on top of an operating system. And this technique was a revelation at the beginning because it allowed developers to run multiple operating systems in different virtual machines, all running on the same host operating system, which nothing but eliminated the need for extra hardware resources. Now, the advantages of virtual machines or of virtualization are many. Multiple OSs could be run on the same machine. The maintenance and recovery was easy in case of failure conditions. And the third point here being the total cost of ownership was also less due to the reduced need for infrastructure. So as you can see here on your screen right now, you can see that there is a host operating system on which there are multiple guest OSs running, which is nothing but a virtual machine. So as most concepts have their shortcomings, virtualization also had a few. So running multiple virtual machines on the same host OS, each to the performance of degradation. This is because the guest OS running on top of the host OS will have its own kernel, own set of libraries, and own dependencies. And these take up a large chunk of the system resources, that is the hard disk, processor, RAM, and other resources. Another problem with a virtual machine, which used virtualization, that it takes a lot of time to boot up. So the problem is very critical in case of real-time applications, so these drawbacks were always there. Apart from that, you also have the age-old battle between development and production teams, that the code works at development and does not work in productions, because the developer has a system with their own set of libraries, their own kernel, and the apps running on there, whereas the production team has these resources of their own. So this is a problem that you can blame upon the difference in the computing environment. A code that runs on the developer's system might not run on someone else's computer. So this led to a new technique called containerization. Basically, a container brings virtualization to the OS level. While virtualization brings abstraction to the hardware, containerization brings abstraction to the OS. So what you might notice here is containerization is basically virtualization, but it's more efficient because there is no guest OS here. It utilizes a host's operating system, shares relevant public libraries and resources when needed, and unlike virtual machines, the application-specific libraries and binaries of containers run on the host kernel. So each app has its own set of libraries and binaries in its own little container, which makes processing and execution extremely fast. Even if you have to boost a process, it takes only a fraction of a second, because in case of containerization, all the containers share only the host operating system, but hold all their application-related binaries and libraries in themselves. They are lightweight and faster than virtual machines. So here, as you can see, there is your host OS or your host kernel, which is shared by all the different containers. So the containers themselves only contain the application-specific libraries which are separate for each container. This is what makes them faster, and they do not waste any resource. All these containers are handled by a containerization layer which is not native to the host OS. Hence, a software is needed which can enable you to run containers on your host OS. And this is also how containerization solves the difference in computing environment problem. Now, a developer works on containers instead of virtual machines. The app and its required libraries and binaries all are in one container. So when it is passed on to the testing team or the production team, it does not matter whether their host systems have the same libraries. All the dependencies are already present in the container containing the app. So now that you know what is virtualization and what is containerization, and why do we need containerization, let's move ahead and talk about Docker. Why do we need Docker? So a challenge I briefly spoke about earlier is what I would like to elaborate on in this section. Now, when you have a project code in a development lifecycle, there are different environments. You have your virtual server, you have your staging environment, you have your production environment, you have your QA environment. Now, most of the code that we deploy today is done using VMs or virtual machines. Now, how this works is that a developer or certain developers will write the code, and all of it is placed in a version control system such as Git. Now, this could also be placed in a staging server depending on your organization's infrastructure, but most organizations these days use a version control system. So more often than not, the code is placed in that version control system. Now, this code is never directly deployed in the production server. It's usually first deployed in a lower lifecycle server like your QA server or your staging server. Now, once it is successful in that, then only it is deployed on your production server. Now, this is where the chances of conflicts increase. So the same piece of code that might be running on your staging server might not run on your production server. And the reason is very simple, it is the difference in the computational environment. This is also known as infrastructure incompatibility. Now, in most cases, your QA servers or your QA environment, staging environment are always updated. In most organizations, that's the case. It usually has the latest libraries, latest binaries, latest jars, all that jazz. But the same cannot be said for the production environment. So in order to face all these challenges that is faced, difference in environment and lack of optimization of resources, we use Docker. So this is where Docker comes into picture. Docker does virtualization in the software level, and we call it containerization, as I had mentioned before. So here, as you can see, containers are bundled with their own set of libraries and binaries, but they can communicate with each other with a fixed set of protocols. The thing about containers, however, is that they do not have their own operating systems, which is a great thing, because this is what makes them lightweight and function on very little resources, which makes them really fast as well. So what exactly is Docker? As you can see on your screens, there are two machines. The first one has 3 software applications. One is Angular based, one is React based, and one is Django based. Now, all of them are using common resources from the systems, libraries, RAM, processor, etc. And the frameworks are allocated a location in the memory. Now, how is it different from your machine with Docker? Since you have a Dockerized machine, you have a Dockerized system, all of your frameworks and binaries and libraries required by your Angular app, your React app, and your Django app can be put into their each isolated containers, which are going to run independently from each other without interfering with another app. And the space in which you had your framework stored has opened up. So now you can add another software application there with its own frameworks and libraries, binaries, etc. And that is what Docker is meant to do. It's a tool designed to make it easier for you to create, deploy, and run applications by the usage of containers. Docker is a containerization solution. Docker containers do not use the guest operating system. They use the host operating system, and on top of that host operating system, there is the Docker engine. And with the help of this Docker engine, Docker containers are formed, and these containers have applications running in them. The requirements for those applications, such as all the binaries, libraries, frameworks, jars, etc., are also packaged in the same container. There can be multiple containers running simultaneously. As you can see, there are 2 containers here in our example, and those containers have applications running in them. And you don't really have to pre-allocate any RAM to those containers. These containers allow a developer to package an application with all its parts, all its needs, and then you can deploy it as one whole package. They are basically lightweight alternatives to virtual machines that use the host operating system. This is basically a general workflow of Docker. So you can see one way of using Docker over here. What is happening is that your developer writes a code and defines an application requirements or the dependencies in an easy to write Docker file. And then this Docker file produces Docker images, so whatever dependencies are required for a particular application is present inside the image. Now, as we have specified many times before, what are Docker containers? Now, the Docker containers we spoke so much about are basically the runtime instances of these Docker images. This particular image is then uploaded onto Docker Hub, from where anyone can pull the image and build a container. Now, Docker Hub is nothing but the GitHub of Docker. It's like a repository for Docker images. It contains public as well as private repositories. So from the public repositories, you can pull your images and you can upload your own images as well to Docker Hub. And then, as I mentioned, from Docker Hub, various teams such as your QA team or production team can pull the images and prepare their own containers, as you can see in the diagram. So this shows a great advantage of Docker is that whatever dependencies that are there that are required for your application to run are present throughout the software delivery lifecycle. If you can recall, the initial problem that was there with VMs was basically that the application worked fine in a development environment, but when it reached the production environment, it was not working properly. So that particular problem is easily resolved with the help of this particular workflow, because you have the same environment throughout the software delivery lifecycle, be it a developer, testing, QA, or production. Now, before moving on to the next section, let's look at a case study about containerizing the NASA Land Information System framework using Docker. Now, developed by the Hydrological Sciences Laboratory at NASA's Goddard Space Flight Center, or GSFC, the Land Information System, or the LIS, is a high-performance software framework for terrestrial hydrology modeling and data assimilation. Basically, the LIS enables integrating satellite and ground-based observational products and advanced modeling algorithms to extract land surface states and fluxes. Now, this framework was very difficult for non-experts to install due to many dependencies on specific versions of the software and compilers. This situation then created a significant barrier to entry for domain scientists interested in using the software for their own computing systems or in the cloud. In addition, the requirement to support multiple runtime environments across the LIS community had created a significant burden on the NASA team. Now, to overcome these challenges, NASA had deployed LIS using Docker containers, which allowed installing an entire software package along with dependencies within a working runtime environment. They also used Docker Swarm, which we shall learn about later, to orchestrate the deployment of the cluster of containers. This installation, that used to take weeks or months, was now completed by NASA officials in minutes, either in the cloud or on premises. Now, moving on, let's look at Docker's workflow and architecture. What you see in front of you is the Docker workflow. Now, the Docker engine uses a client-server architecture, where the Docker engine is simply a Docker application that is installed on your local machine. The client-server architecture communicates using a REST API, and the Docker daemon checks the requests to manage the containers. So the Docker architecture includes a Docker client, which is used to trigger Docker commands, a Docker host which runs the Docker daemons, and a Docker registry which stores the Docker images. The Docker daemon running with the Docker host is responsible for images and containers. We'll understand the concept of images a little later in this very section, as a part of Docker components. So to build a Docker image, you can use the CLI or the client to issue a bill to command the Docker daemon which runs on the Docker host. Now the Docker daemon will then build an image based on your inputs and save it in the registry, which can either be the Docker Hub or a local repository. So if we do not want to create an image, then we can just pull an image from the Docker Hub, which would have been built by different users. And finally, if we have to create a running instance of any Docker image, we can issue a run command from the CLI or the client, which will create our Docker container. So this is basically the overall architecture or the overall functioning of the Docker architecture. As we move forward in this section, things will be more clear to you. So as you can see, the heart of the Docker architecture is basically the Docker engine. The Docker engine is simply the Docker application that is installed on the host operating system of your host machine. It works like a client-server application which uses a server, which is a type of long-running program called the daemon process. The second point here is the command line interface or the client. The next component here is the REST API, which is used for communication between the CLI client and the Docker daemon. So now if there is a Linux-based OS and there is one Docker client which can be accessed from the terminal and a Docker host which runs the Docker daemon, we build our Docker images and run our Docker containers by passing the commands from the CLI client to the Docker image. So this was all about Docker engine and its workflow. Now let's talk about the Docker components which you will be most acquainted to hearing. You have your Docker file, which builds into a Docker image, which you run, you get a Docker container, and then you store it in a Docker registry. Let's go ahead and look at all of these components in a little depth, shall we? First of all, you have your Docker file, which is nothing but a text document which contains all of your commands that you as a developer call on the command line to assemble an image. So basically, to create an image, you'll have to write a Docker file and then build it. So Docker file basically has your set of instructions which creates the Docker image. Next, you have the Docker image, which can be compared to a template used to create a Docker container. So Docker images are basically the building blocks of a Docker container. These Docker images are created using the build command, and these are read-only templates. You can then store them, as I had mentioned before, in your Docker Hub or your local registry. Next, after building your Docker image, what you get is a Docker container, and these are read-only templates. You can then go ahead and store them in Docker Hub or your local registry, as I had mentioned before. Docker lets you create and share software through Docker images, and you also don't have to worry about whether your computer can run a software in a Docker image, because a Docker container is always there to run it. So in case of Docker images, you can use a ready-made Docker image from the Docker Hub or create a new image as per your own requirements to run in a container. With that, let's move on to the next component, which is a Docker container. So the Docker containers are the ready applications created from Docker images. It's the running instance of a Docker image, and this Docker container holds the entire package needed to run this Docker application. So a Docker container happens to be the ultimate utility of Docker, and hence this is the part of Docker which is most popular and most widely used. So if you talk about the applications, every application is run inside a container. So it is an isolated application platform that contains all you need to run an application built from one or more images. So finally, let's move on to Docker registry, which is a storage component for the Docker images. Now this is where the Docker images are stored, which could either be a user's local repository or a public repository like the Docker Hub, which allows multiple users to collaborate building an application even with multiple teams within the same organization who exchange or share containers by uploading them to the Docker Hub. It helps you control where your images are being stored and integrates your image storage with your in-house development workflow as well. Now, Docker Hub, as I've mentioned before, is Docker's very own cloud repository, which is similar to GitHub, which is kind of like GitHub but for Docker images. Hope you guys are with me so far. With this, we have seen the architecture and components of Docker. So now we are going to talk about two other components of Docker, Docker Compose and Docker Swarm. So first of all, let's start with Docker Compose. Now, Docker Compose is a tool for defining and running multi-container Docker applications, which basically means you can run different or multiple containers as a single service. The containers are still isolated, but they can interact with each other using a YAML file, which is used to configure your application's services. And then with a single command, Docker Compose up, you can create and start all the services from your configuration. A great example of this would be a microservice such as a shopping app. So for example, you can take any online retail store's app. It could be Amazon, it could be Flipkart, it could be Ajio. And the idea behind an app like this is that it's a microservice app, which basically means it has multiple services in one big application. So all of these services individually are easier to build and maintain, and when one service is failing, the entire app is not down. So a retail app like Amazon or Myntra or Flipkart or any app of your choice, it'll have multiple services, like it'll have a login account, it'll have your product catalog service, it'll have a shopping cart service and a checkout service, and this is just the bare minimum. And each of these services could be scaled up or down in their own container, tested and built and fixed in their own isolated containers without interfering with any other service in that entire application. So using something like Docker Compose, you can connect all of these isolated containers as a single service. All right? And the next thing I want to talk about is Docker Swarm. Now, Docker Swarm is a service which allows you to create and manage a group of either physical or virtual machines or nodes and schedule containers. Each of the nodes is a daemon which interacts with others using the Docker API. Docker Swarm is basically a technique to create and maintain a cluster of different Docker engines. Services deployed in any node can be accessed on other nodes in the same cluster. It allows for high availability of services, auto-load balancing, decentralization of access, easy upscaling and downscaling of deployments, and rolling updates. So basically how it works is that your manager nodes know the status of all the working nodes in a cluster. Your worker nodes then accept tasks sent from the manager node. There is an agent assigned to every single node to give its task updates to the manager. And finally, the workers communicate with the manager using an API over the HTTP protocol. And that is how a Docker Swarm works. Basically, Docker Swarm is an orchestration management tool that runs on Docker applications. It helps you end users in creating and deploying a cluster of Docker nodes. Each node of a Docker Swarm is a Docker daemon, and all the Docker daemons interact using the Docker API. And each container within the swarm can be deployed and accessed by other nodes of the same cluster. So if you consider an environment having Docker containers, if one of the container fails, we can use the swarm to correct that failure. Docker Swarm can reschedule containers on node failures, and the swarm node also has a backup folder which we can use to restore the data onto a new swarm. So with that, we have come to an end to the workflow and architecture of Docker. So now I'm sure all of you might be eager for actually doing something on Docker. So let's go ahead and install Docker. So here are the steps to install Docker on Ubuntu, on your Linux systems, on your Ubuntu systems. You will be using the command sudo apt install docker.io on your Ubuntu systems to install Docker on your system. So let's go ahead and start up with the installation. Today I am using the Ubuntu distribution running on my Oracle VM VirtualBox. So we're going to start out by updating. So sudo apt update. and this might take a little bit time, so kindly be patient. This is a good practice before making any installations, any setups on your machine. All right, as you can see, all my packages are upgraded, and now we can go ahead and install Docker. So to install Docker, we are going to use the command sudo apt install docker.io and then click on Y. And this is also something which takes up quite a considerable amount of time, depending on the speed of your machine as well as the speed of your internet, so on and so forth. Now understand, this is just one way of doing this, and this is the method I am most comfortable with, and that's why this is the method I will be demonstrating here. There are 2-3 other methods through which you can download Docker on your machine. And not just in Linux, you can also install Docker Desktop on Windows, just in case you do not want to use a virtual machine. And you can also use a cloud platform such as an EC2 instance to run all of these Docker commands that I shall be showing you later in this session. So now we are going to start and enable Docker using sudo systemctl. Okay, with that we have started and enabled our Docker machines. And now we are going to go ahead and check out our Docker version that's running. And as you can see, this is the Docker version and this is the Docker build that we are running. All right, so moving on, we are going to get to our hands-on section. In this section, we will learn how to create a Django project setup using Docker and deploy it on our local host. For that, remember, you need to have a GitHub account and Docker installed on your machine, just the way I showed you right now. We're going to build a backend REST API with Python and Django. We're going to create a new GitHub project that we are going to use to store the source code for our recipe app API. Now, this is a wonderful way to show the versatility of Docker. Now, I found this project while browsing through GitHub, and I came to a conclusion that this was a wonderful way to show how eclectic, how versatile is Docker as a tool. So the first step would include initializing a new project on GitHub and coming back to your Linux machine and navigating to where you wish to store your API. There, we are going to create our Docker file using an editor. You can obviously use the VI editor or Nano editor if you please. There, using the editor in our working directory, we are going to be creating our Docker file, our requirements file, and our Docker compose file, which is our YAML file. And then we are going to run our app on the terminal. So this is a basic breakdown of how we are going to create our Django project setup using Docker. So let's go on straight to our demo machine and put all of this into action. So we are going to navigate to GitHub and we are going to create a new public project or repository on GitHub. So let's create a new repository and let's call it Docker Demo API App. And in the description, we're just going to write Demo App Setup. We're going to keep this public and we're going to initialize this with a README file. All right. So let's go ahead and create our repository. So as you can see, this is a blank repository, Docker Demo API App, just the README file there. So here on our repository page, I'm going to click on this green button, code button, and copy the URL from here, from your clone or download option. We're going to copy this to our clipboard so that we can clone this particular repository using our terminal. I'm going to move on to the terminal, and I'm going to load my terminal and navigate to the directory where I want to store my app. So maybe I'll just save it here. I'm just going to clone this repository to my local machine. All right, and that's done. Now you can go ahead and change your directory to the repository. So now I'm going to use the command ls to see if my repository has been cloned. Yes, it has been cloned. You can see the Docker demo API app is cloned right here on my local machine. So I'm going to change my directory to this repository I just created by typing the command cd docker demo API app. Now what I'm going to do is I'm going to open up this project in the editor. Like I had mentioned, you can use any other editor. You can use the VI editor, the Nano editor, any editor that you're comfortable with. So now I'm going to clear all of this. And I'm going to use the Nano editor to create the Docker file first. So just Nano and Docker file. There's no spaces between Docker and file. And I am going to put in this code over here. All right. So this is my Docker file. So the first line of the Docker file is the image that you're going to inherit your Docker file from. With Docker, you can basically build images on top of other images. The benefit of this is that you can find an image that has pretty much everything that you need for your project. So you can just add customized bits that you need just for your specifications. So we are going to create our Docker file from Python 3.7 Alpine image. Now you can find this if you head over to the Docker Hub. You can find a list of available images that you can use to base your project off of. If you search for Python, it'll take you to a list of items where you can choose this one. So we're going to use the 3.7 Alpine image. So what it is that it's basically a lightweight version of Docker, and that's what Alpine means, and it runs Python 3.7. And the next line is optional. It's usually a maintainer line, but it's useful just to know who is maintaining the project. So I'm going to leave that one out, but you can go ahead and put in your maintainer line. You can put your name or your company's name, whatever name you basically use to keep track to show that who is maintaining this Docker image. Next, we are going to set the Python unbuffered environment variable, the way you set unbuffered environment variable. Now, the way you set an environment variable in a Docker build file is that you type env and then the environment variable that you want to set. We're going to set one called Python, and it's got to be in all capitals, unbuffered, and then we're going to set it to 1. So what this does is that it tells Python to run in the unbuffered mode, which is the recommended mode when running Python within Docker containers. The reason for this is that it doesn't allow Python to buffer the outputs. It just prints them directly and then avoids some complications and things like that. So when you're running your Python application, we are going to install our dependencies. We are going to store our dependencies in a requirements.txt list or file, which we are going to create in a moment. So that what we need to do here is we need to copy our requirements.txt file. And what this does is it says copy from the directory adjacent to the Docker file copy. So we're going to copy the requirements.txt file. Further, we're going to copy it on the Docker image, which is what this /requirement.txt file means. Next, we're going to run pip install. our /requirements.txt. So what this does is that it takes the requirements that we have just copied and installs it using pip into your Docker image. Next, we're going to make a directory within our Docker image that we can use to store our application source code. So you have your run mkdir/app all in lowercase, and below that we are going to type workdir/app, and below that we are going to type copy./app /app. What this does is it creates an empty folder in our Docker image called /app at this location, and then it switches to that as the default directory. So any application we've run using our Docker container will run starting from this particular location, unless we specify otherwise, of course. Next, what it does is that it copies from our local machine the app folder to the app folder that we have just created on our image. This allows us to take the code that we created in our project here and copy it to our Docker image. So here we have run add user -D and user. And finally, we are going to switch to that user by typing user. Now this might be a little confusing because I've added the username user for our user, but what this command means is that it says add user, which creates a user. User -D says create a user that is going to be used for running applications only. So not for basically having a home directory that someone will log in. It's going to be used simply to run our processes from our particular project. Finally, this user switches Docker to the user that we've just created. The reason we do this is for security purposes. If you don't do this, then the image will run our application using the root account, which is not recommended, because that means if someone compromises our application, they can have the root access to the whole image and they can go ahead and do other malicious things. Whereas if you create a separate user just for the application, then that kind of limits the scope that the attacker would have within our Docker container. All right, so we can go ahead and we can save this file and move ahead to creating our requirements file. So this is what your requirements.txt file will look like. It's just 2 lines. In the first line here, we are installing Django. We are using version 2.2.4, which is the latest stable version that I could find. And that's the version that we are going to use for the project. And then type Django > 2.2.4. So basically what it says is that install Django that is equal to or higher than this particular version. And we do this to take the minor version, which is the last number, and make sure that we install the latest available version, because typically it's the version that has the security features and security fixes and things like that. But it typically doesn't have breaking changes, so we can be confident that our application, when we rebuild our Docker image, will have the latest security patches, even if it does not have the latest version. Okay, in the next line, we're going to install the Django REST framework. So we are using 3.9.0. And in the same way which we did with Django, we are going to make the install one less than 3.10.0 to get the latest version of 3.9, which is whatever is the latest minor version at the time we build our project. So now we're going to go ahead and save this file as well. Now what we're going to do is we're going to go ahead and create an empty directory called app here for our Docker file to call, because when our Docker file will run and it's going to ask for an app folder, we're not going to have one, then we're going to face issues. So now if I do an ls here, you see we have a Docker file, we have our requirements file, and we have our app folder. Now understand why this is required for our Docker file for us to build it now. So now if you try to copy it without the app folder actually existing, it will give you an error. So now we can go ahead and build our Docker image. So we are already at our terminal. If you're not on your terminal, you can load up your terminal. And if you're on Windows, it'll be your command prompt. Let's make sure that you navigate to your project folder, which I am already at. And then I'm going to type docker build dot. Now what that's going to do is that it's going to build whichever Docker file is in the root of our project that we are currently in. The reason we call it Docker file in the first place is because it's the standard convention that Docker uses to identify the Docker file within our project. So we're going to wait for it to complete, and it should be fairly quick because we are using an Alpine image. It's a very lightweight, minimal image that runs Python. That's how we create a Docker file for our project. And go ahead and create our Docker Compose configuration for our project. So we're going to use Docker Compose as a tool to allow us run our Docker image easily from our project location. So it allows us to easily manage the different services that make up for our project. So for example, one service might be the Python application that we run. Another service might be a database, for example. So let's go ahead and create the Docker Compose file for our project. So nano docker compose dot YAML or YML. So this is a YAML file that contains the configuration for all services that make up our project. The first line of the Docker Compose configuration file is the version of Docker Compose that we are going to be writing our file for. So version :3. Next, we define the services that make up our application. Right now, we only need one service for our Python Django application. So services, : and in the line below, you're going to type app. This is the name of our service. So we are going to call it out. And then we are going to type build. And then context code on context. So what this says is that we are going to have a service called app, and the build section of the configuration we are going to set the context to dot, which is our current directory that we are running Docker Compose from. Next, we're going to type the port configuration. So we're going to type them in open speech marks. 8080 is our host to port 8080 on our image. So we're going to type that. And then we're going to add a volume. The volume allows us to get the updates that we make to our project into our Docker image in real time. So it basically maps a volume from our local machine here into our Docker container while we'll be running our application. Now this means whenever you change a file or you change something in the project, you will automatically update it in the container. Now the good part is you don't have to restart Docker to get the changes into effect. So then you have a ./app /app. So what this does is it maps the app directory, which we have here in our project. And this it maps to the app directory in our Docker image. Then you have the command to run your application in your Docker container. So just make sure that the indentation is one indent from where your command starts, and then you type the command. So we're going to use to run our application be sh-c. This means we are going to run the command using the shell, the Python manage py run server. Then we're going to run the server on our local host at port 8080. So this will run the Django development server available on all IP addresses that run on the Docker container. And it's going to run on port 8080, which is going to be mapped through the POS configuration on our local machine so we can run our application. So again, we are going to move on to our terminal and build the Docker Compose file. And what this does is it will build our image using the Docker Compose configuration, and this should not take too much time. So we're going to build our Docker file. So now we're going to add sudo docker compose build. And as you can see, it's successfully built. Clear it out. So now we're going to use Docker Compose to create the project files for our application. And for that, you can either log in as super user or just type sudo. So Django admin.py, we're going to start project. Now, after running the command, you will realize that if you go into your empty app folder, which was the folder that you created initially, and list out, it's not empty anymore. It has another app folder in it, which contains all of our app setup. I will show you. There you go. You have these files, 1, 2, 3, 4, 5 Python files, which is basically your Django app's entire setup, and all of this Docker created and set it up for you. So a teensy little detail, let's just open up our settings.py file, and we're going to go down to allowed hosts, and just in case it's empty between the close brackets, you can go ahead and add your local host or put in the asterisk, which allows all hosts. All right, so I'm just going to do that, and then I'm going to go back. And now all we have to do is deploy the application through your terminal. So we're going to go sudo docker compose up. So now, as you can see, your Django application is up and running. And all of this was possible because of Docker.
Moving on to our next question, what is the key benefit of using Docker in a DevOps workflow? And the options are A. Simplifies database queries, B. Ensures applications are lightweight and portable, C. Automates code review processes, or D. Enhances server uptime monitoring. If you know the correct answer, please comment down below. Having a good understanding of Docker, we will now explore what is Kubernetes. Here, you will learn how Kubernetes manages containers at scale in DevOps workflow.
Need for Kubernetes. What is Kubernetes? But before I start with Kubernetes, I want to talk about two things. Like Kubernetes is a container orchestrator. It's a container orchestrator. So I need to talk about two things here. What exactly a container is and what exactly a orchestrator is. I just want to talk about these two things first. First, let me start explaining these two things to you. Then we'll talk about Kubernetes. Okay, Kubernetes is a container orchestrator. Now, let's suppose I want to deploy an application. Now, it can be any application. It can be a web application. It can be a database application. Okay, I want to deploy some application. So how do we deploy that application? How do we do it? To do that, what do? We first create up a server. We require a server. Yes. Okay, this is my server. A physical, virtual does not matter. We require a server, a computing machine. We require a machine. Okay. Now on this machine, I simply go and install the operating system, OS. Yes. And on top of that, we go and install our application. Yes, this is what we do. The very basic example is on the screen only. For example, this Notepad++. This is an application. It's a text editor. Okay. Now to run this application, what I have did, first of all, I had a laptop with me. I purchased a Dell laptop. I require a machine. Okay. And on top of that Dell machine, Dell laptop, I've installed Windows operating system. Okay, now once the operating system is installed, I have deployed the application Notepad++. Not only Notepad, but I've deployed multiple applications like Chrome, Edge, Zoom, okay, Putty, WinSCP, this is empty Putty, this is WinSCP. Okay, so I've deployed multiple applications. But yes, to run those applications, we require a complete OS. We require the operating system. Okay. Now, running an application on top of an operating system is actually it consumes high amount of cost. It's very costly to run the application directly on top of an operating system. Now, the question is why it is costly. Okay, let's talk about that. For example, okay, you have the machine over here. Okay. You have this machine over here. This is your OS. Let's suppose you want to deploy an application. Now, first of all, to deploy this application, now let's suppose you are deploying a database. Okay, now we'll talk about the server side. Okay, this is just my desktop applications. Desktop applications, multiple applications can work on a single desktop, it's fine. But when you talk about the production world, when you talk about servers, when you talk about the real applications, the production applications, for them, you need to give a dedicated server. Okay, like on this dedicated server, you will be installing a OS, and on top of this OS, you will be installing any database like MySQL or Oracle, whatever database you want. Whatever database you want, that you will be installing on top of this. Yes. Apart from Oracle, no other application will be running. Like let's suppose you want to run a HTTPD or you want to run an Apache. For that, you will be running another server. Okay. You will be creating one more server and you will install Apache on this. Okay. This is a web server and this is a database server. We do this in production. Okay. Now, the challenges with this architecture is, that for running one application, you require one complete machine with a OS installed. Okay. So running this machines for single applications is very costly. It is taking good amount of price from your customer. Okay, it is going to take some good amount of money basically. Why? Because you have to create one machine for one application. Apart from that, this operating system, you have to run a full copy of the operating system. Okay, so there must be a dedicated team that is managing all these operating systems. A sysadmin team is there. Yes, so you have to again pay the money to them. Okay, there's again a cost involved to manage a sysadmin team. Okay, apart from that, okay, first of all, to run this application, it is necessary to install the OS first, and installing OS is a time-consuming process. Running an OS is a heavyweight process. This OS itself will take some amount of resources. Like for example, to this machine, you have given around 10 CPUs and you have given around 32 GB of RAM. But out of this 10 CPUs, 2 CPU and out of 32 GB, maybe around 8 GB is taken itself by the operating system. So the resources that you're giving for your application, in that some is consumed by the OS itself. And these resources are nothing but again money. So running an application on a single server is costly. First of all, you need to maintain a full copy of the OS. Okay. And apart from that, this OS, you need to also have a sysadmin team, because sysadmin team will be patching the operating system. Okay. They will be maintaining any bug fixes on the operating, or they will be basically scanning the vulnerabilities on the operating system. All the OS related tasks will be done by the admin team, not by the application team. Application team is only managing this. Okay. But for the client to run Oracle on a single machine or to run MySQL, it is costly because he has to maintain a complete machine. So now the question is, can we not put multiple applications on a single OS over here? Like on this, on my desktop, okay, you can see that I'm running multiple applications here on a single operating system. This is Windows 11. I have Windows 11. on Windows 11, I'm running multiple applications. Can we not run multiple applications on a single server? Okay, and all the applications isolated from each other. All of them are isolated. Okay, so can we not do that? Answer is yes, we can do it. Okay, first of all, to do that, okay, we first need to have a machine. On that machine, we have an operating system installed, OS is installed. Now, let's suppose you are running one application. Okay, it's fine. Application number one. You are running another application. I can run two applications, but there can be conflict among these two applications as well, as they are directly running on this OS. Now, it can be any conflict. Like, for example, I want to deploy Apache, okay, and I also want to deploy HTTPD on the same server, Apache, or let's suppose I want to deploy 𝐿, which is a front-end application. I want to deploy similar kind of applications on OS. Now, let's suppose when I'm running Apache, this application is running fine and is running on port number 80. Now I'm trying to deploy 𝐿. Now 𝐿 also requires port 80. 𝐿 also requires port 80. My problem is that I want to run multiple applications on single server to reduce my cost. Okay, that is what my thing is. I want to run multiple applications on single server. But the problem that it arises that there can be conflicts, there can be network conflicts, there can be some file, like for example, there is a single file and that file is accessed by both the applications simultaneously. Again, there's a conflict. Okay, so there can be conflict at any point, network conflict, file conflict, process conflict, there can be conflicts. So I want a solution where I want to run these applications on the same server to reduce cost. Apart from that, these applications should not conflict each other. There should not be any conflict between them. Okay, like here, Nginx and Apache both are using port 80. So I cannot run two applications which are utilizing same port number. It's a network conflict. Okay, so to overcome this problem, to give me a solution that I want to run multiple applications on single server in their isolated environment, for doing that, we require some kind of isolations. And that isolation is given by your container runtime tools, container runtime engines. Okay, CRE basically. Okay, there are a lot many container runtime engines basically. Okay, you have like Docker, you have Cryo, okay, you have LXC, you have your Podman, okay, you have container D. There are a lot many container runtime environments. Now, what they exactly do? Okay, so basically on this machine, okay, where you had your operating system installed, on top of that, first of all, you will install Docker, any container runtime basically. You can, Docker is one of the more very popular container runtime engines. So that's why I'm naming it Docker over here. But yes, you can use any of them. It's not only necessarily Docker. Okay. Now let's suppose you have installed Docker. Okay. And what this Docker is going to do, Docker will help you in creating some isolated environment. Okay. On this server, onto this particular server, you can create some isolated environments. Now, this isolated environment will have its own IP address. Okay, it will have its own name. Okay, it will have its own set of processes. It will have its own set of files or mounts. Basically, it will have everything different. Same for this. Same for this. Okay, and now in this isolated environment, you can run your application and you can run your another application over here. Like I can run Apache over here. Apache utilizes port 80. I can run Nginx over here, which utilizes again port 80. But they both are isolated. Why? Because they have their different IPs. Like this will have IP1, this has IP2. The IPs are different. Ports can be same. The distinguish is done at the IP layer, the networking layer. TCP layer can be same. Ports can be same if IPs are different. Okay, so this Docker or these container runtime tools allow us to create these isolated environments. And these isolated environments are nothing but your containers. These are your containers. Okay. And these tools allow us to create these. And why do we put our application? Why do we need to put our application in the container? To reduce cost. Okay, because on a single OS, now you can run multiple applications. I can run multiple containers, and in each container, I can have a different application. Like here, I can run MySQL, here I can run a Kafka, or here I can run a Hadoop, or whatever you want to run, you can run it. Yes. So on a single piece of hardware, on a single machine, I'm running multiple applications in their own isolated environment. And that isolated environment is nothing but a container. So this is what a container is all about. Okay. Now, my life is good. Like I am able to run multiple applications on a single server. Okay. Like I have this OS installed. I have a container runtime engine. Okay. And on top of that, I've deployed multiple containers where I'm running some applications. I'm running some applications over here. Okay, that's fine. That's good enough. But this architecture also has a drawback. It also has a serious drawback. And the drawback with the container or with this architecture is, what if this machine fails? What will happen if this machine fails? If the operating system goes corrupt, then what is going to happen over here? That is what the problem is. Okay, if the OS goes corrupt, if the OS goes offline, or the machine goes offline, what will happen to these application containers? They are running on the Docker on this machine. They are running on this machine. Okay, so in that case, these containers will also fail. If the machine fails, it's a single point of failure. It's a SPOF, single point of failure. If the machine fails, container fails. Now, there is no high availability. There is no fault tolerance for your application containers, for your apps. There's no high availability. There's no fault tolerance. Okay, like if the container has failed, it should be recreated, but there's nothing because the complete machine has failed. So how we can overcome this? That is now the question. How to overcome this problem? Okay, containers has made my life easier. Okay, but container has reduced the cost, but the thing is, containers are not giving me a scalable, fault-tolerant, highly available architecture for my application. Okay, so in this case, we require a orchestrator, a container orchestrator we require, okay, to give us all these features. Okay, so what does an orchestrator basically do? If I talk about the orchestrator over, there are a lot many orchestrators available in the market. Container orchestrator I'm talking about. Okay, so there are a few container orchestrators. I can name them for you. I think the first one we all know is Kubernetes, Docker Swarm, Apache, Mesosphere. These are some of the well-known container orchestrators available in the market. Out of which Kubernetes, out of these three, Kubernetes is the most popular container orchestrator. It has become the de facto standard for running any containerized application, Kubernetes. Okay. Why we'll talk about that, but first let's see how does the orchestrator solves the problem. So orchestrator, if I define what a container orchestrator is basically the technology that groups multiple machines to create a cluster of containers. Okay, basically it's a container clustering technology. How does it work? Let's talk about that over here. For example, let's suppose I have this machine number. Let me make a bigger picture. Okay, just 1 minute. So let's suppose I have this machine which has the OS installed on this, and I have a container runtime engine running over here. I have one more machine over here which is having the OS installed, container runtime engine. These are all standalone machines. As of now, these all are your standalone machines. Okay. You have one more machine over here. Now it can be 1, 2, 3, as many machines as you want, you can have those. Okay. So I'm just starting with a basic 3 node. Okay. Okay. So now You have three machines, machine number 1, machine number 2, machine number 3. Now on these three machines, you want to create a orchestrator. You want to create a cluster, Kubernetes cluster, or you want to create a Docker Swarm cluster or Apache Mesosphere cluster. So what does these orchestrator will do? What does the orchestrator is going to do? Orchestrators are simply any orchestrator. Like for example, you talk about this Kubernetes. So what Kubernetes is going to do, or what Docker Swarm is going to do? The orchestrator, when you deploy orchestrator, it will create up a cluster network. It is going to create a network, a container network, okay, between all the machines. It's basically a private network, private container network, okay. And what this network is used for? This network is basically used for providing the IPs to the containers that are running on different machines. Like you have container number 1 running here, container number 2 running over there, container number 3 running over here. Okay, these are different containers that you are running. Okay, now the thing here is that these containers are running on different machine. Container 1 on machine 1, container 2 on machine 2, container 3 on machine 3. All the containers are on different machine, but these containers will take the IP from this common network, which is created by the orchestrator. Any orchestrator do the same thing. You talk about Docker Swarm, you talk about Kubernetes, you talk about Apache Mesosphere. All the orchestrator do the same stuff, same thing. Okay, all the orchestrator has the same thing to do. They will first create a network between the machines so that containers can take the IP. Now, this container 1 and container 2 can easily talk to each other, although they are sitting on different machines. Earlier, this was not possible. Like you create a container on machine number 1 and you have a container on machine 2. The two containers sitting on two different machines cannot talk until and unless you are using an orchestrator. So here, if you're using an orchestrator, the orchestrator has created this network between those nodes, and all the containers sitting on the nodes can now interact. This is the primary responsibility of the orchestrator. It makes your solution scalable. Now you can run the containers on any node. Okay. Apart from that, let's suppose you think that this container number 1 is a very critical application. It's a very critical application. Okay. And you want multiple copies of this. You can scale the number of containers. High availability orchestrator can give you. For example, I can create one more copy of C1. And this C1 is running on node 2. I can create one more copy of C1 over here running on node 3. High availability. High availability is there. Let's suppose if this machine fails, if the machine number 1 fails, okay, then container number 1 will also fail. Yes, container is going to fail if the machine fails. In that case, do I need to panic? No, I don't need to panic. Why? Because this was a critical application. I know that. So already I have created 2 more copies of the same application running onto 2 different machines. So if this container is offline, I can access the application from these containers. It's possible. That is what orchestrator give you. High availability. High availability. That's another feature that orchestrator gives you. Scalability, high availability. And the third one is fault tolerance. For example, this container number 2, this machine fails. This machine fails. Container number 2 is offline. Container 1 is also offline over here. But let's talk about this. Container 2 is offline. So orchestrator is a smart guy. He knows what to do with the failed container. He will simply go and recreate the container on some other node automatically. That is the job of the orchestrator, to provide you fault tolerance. This is also called as a self-healing nature of Kubernetes, or self-healing nature provided by orchestrator. Kubernetes is a type of container orchestrator. Container orchestrator is a generic term, like cloud is a generic term. AWS, GCP, Azure are type of clouds. OpenStack, all these are different types of clouds that are available in the market. Container orchestrator is a generic term. Kubernetes is a type of container orchestrator. Docker, Swarm, Apache, Mesosphere, these are type of container orchestrator. But yes, the main responsibility of the orchestrator is to give you a network for your containers, and that network will be spanning across multiple nodes. It gives you high availability. Apart from high availability, it gives you fault tolerance, FT. Okay, so these are the important features of an orchestrator. Okay, so guys, now we will be talking about a bit about Kubernetes. Okay, because we all are here for Kubernetes. We have talked about orchestrator. Why do we require orchestrator? Because orchestrator provides us scalability, high availability, fault tolerance for our container applications. Now we are going to talk a bit about Kubernetes, and after that we'll see a small demo around this. Let's talk a brief history about Kubernetes over here. Okay, so Kubernetes, the short form for Kubernetes is 𝐂𝐝𝐻. Okay, why we call it as 𝐂𝐝𝐻? Because you see the spelling over here. It starts with the letter K, end with the letter S, and between the first and the last letter you have total 8 letters, 8 characters. You can see that UBERNETE. So the first letter is K, total number, last is S. Between first and last you have 8 characters. So the short form is 𝐂𝐝𝐻. Full form is Kubernetes. Okay. Now on this Kubernetes was actually developed by Google in the year 2009. Okay, and from the year 2009 to 2013, this was used by Google as an internal project. Means nobody was knowing about this Kubernetes. Okay, then something happened in the year 2013, and Google basically donated this Kubernetes project to CNCF. CNCF stands for your Cloud Native Computing Foundation. That is what your CNCF stands for. It's basically a community of lot many developers sitting across the globe and who are contributing to multiple projects which are owned by CNCF, which are managed by CNCF. Okay, Kubernetes is one of the project managed by CNCF, and as I told, they donated it to CNCF. CNCF is a open source organization. They mainly handle all the open source projects. So in the year 2018, Kubernetes became open source. Open source means the code is freely available on GitHub. You can go and check the source code of the technology. Okay, it's freely available, no licensing required, no vendor. You don't need to connect with any vendor. Like Linux is an operating system which is open source. Okay, you don't need to purchase any license for running Linux. Okay, you don't need to go to any vendor, but normally we go to vendors like Red Hat, Ubuntu, we run their operating system. But yes, it is open source. You can also deploy it by your own. You can do that. Okay, that's also perfectly, that's also very much feasible. So it became open source. Okay, and as it became open source, it started gaining the popularity. Okay, Kubernetes started gaining popularity from the year starting onwards, 2013 or somewhere around 2014. Okay, why? The first thing was it was open source. Okay, so anything which is open source, for which you don't have to pay anything, definitely get much popularity. And it was the first orchestrator in the market. It was the first orchestrator in the market. And we know that whichever technology is the first in the market is always have a highest market share, has a good market share, whichever is the first in the market. Okay, so like for example, AWS started in the year 2006, Azure in 2010. Okay, so we know AWS still has the highest market share. Why? The AWS was started quite before Azure or GCP. So it gained popularity because it was open source. It was the first orchestrator. Apart from that, the number of features that Kubernetes provides are way more than other orchestrators. This is another reason. Like if you compare AWS and Azure, the number of services that you will be getting in Azure and is around 60, 70, 80 services somewhere. Whereas in AWS, you will be getting more than 150 plus services. Okay, that is another beauty, that the number of services that your Kubernetes provides are more than what the other orchestrators are providing. Okay, that is another reason of gaining its popularity. Okay, so because of these reasons, Kubernetes became the de facto standard for running your container applications. Now, if anyone says that I'm running an application, I'm running a containerized application, okay, it means they are running the application on Kubernetes. Kubernetes has become the de facto platform, a de facto standard for running your containerized applications because of its popularity, because of its ease to use, because of the features that it provides, and it's open source. You don't need to pay to anyone. Okay, so that is the reason of the popularity of Kubernetes. Okay, so now we'll see a small demo on how do we work with Kubernetes, how do we create these containers into Kubernetes, how do we run our application into Kubernetes. Let's see a small demo as well on that. So just one thing to start off with, like in Kubernetes actually manages pods, and in the pods we create containers. We are creating containers in the pods. Okay, so that is what we do. Kubernetes never manages the container directly. Okay, there is another layer over the container that is called as a pod. Kubernetes will simply be managing the pod, and in the pod we run the containers. Okay, so let's see that. Let's see how we run it up. Okay, and how do we access our application? Let's see all these things. Okay, so to show you a small demo here, okay, I have created up a small cluster. You can see that. Let me close this. I'm using my GCP account. Okay, and you can see that I have created a Kubernetes cluster, and it's just for this particular webinar. I've just created this cluster. So I created this cluster at the start of the webinar. So you can see that this cluster is running hello cluster, and it will be having just one node. Right now I've just kept one node, but normally in production we keep multiple nodes. We keep 3, 4, 5 nodes depending on how many applications you want to run. For example, you just want to run 50, 60 applications. You're good with 5 nodes. Okay, but let's suppose you want to run thousands of applications. You need to have 20 or 30 nodes. Okay, but right now I just have one machine as a part of my cluster. It's fine. I can have a single node cluster as well. Okay, and you can see that this machine is over here. I can show you that on my compute engine. You can see the machine. Yes, this is the machine. You can see this one single machine is a part of my cluster. Okay, now let's go and start checking how we interact with the cluster. So to interact with the cluster, I will activate my Cloud Shell over there. I will activate the command line. So let me open up the command line over here. Just a minute, it is still opening up. And let me also make a full screen, open a new window. So this will open up it in the new window. Okay, so let this get opened up over here. It's provisioning my Cloud Shell machine. It is connecting to the instance. Okay, now it is connected. Okay, now let's see if I can connect with the Kubernetes. So command or the command line to interact with Kubernetes is _kubectl. _kubectl get me how many nodes I have in the Kubernetes cluster, and this will tell me how many nodes I have. I need to authorize this command, and this says that you just have one node. You can see this, there's just one node ready, and it is running from last 40 minutes. I told you just at the start of the webinar, I created this cluster, and after the end of the webinar, I will go and delete the cluster as well. Okay, so I will not be keeping this cluster running because again, I have to pay the cost for this. So at the end of the webinar, I will go and terminate this. Okay, So I just have one node cluster running from last 40 minutes. And the version of Kubernetes that I'm running is 1.24.8. This is the version that I'm running, 1.24.8. Okay. Now, let's see if I have anything over there. 𝐶ubectl. 𝐶ubectl is the command line utility. You also called as 𝐶ubectl. 𝐶ubectl or 𝐶ubectl, one and the same thing. So 𝐶ubectl get me if I have any pod in the cluster. No resources found, nothing. Okay, it's all empty. Let's go and create. Let's go and create some pod. So 𝐶ubectl run. Okay, my first pod or my first application. Okay, my first app. Okay, this is the name that you can give by your own. You can give any name: test app, web app, database app, whatever you want to give, you can give. Okay. After that, you have to give the container that you want to run in the pod. This is the name of the pod, basically. This is the name of the pod. Okay. Now, in this pod, you want to run a container. Okay. So, what container, what application you want to run? You need to just pass the image of that application. You just need to pass it. Okay. So, I'm giving the image as, let's suppose I want to run NGINX. I believe we all know what NGINX is, or let's suppose I want to run HTTPD, a simple web application. NGINX is also a web application. It's a front end. It can also act as a proxy server, load balancer. But yes, let's go with the very known service, HTTPD. Okay, it's again a web service. Okay, so I want to run a HTTPD container inside this pod. Let's hit enter, and it says pod created. 𝐶ubectl get me the pod, and it says the pod is there, but in the pod the status is container creating. This is the name of the pod, and inside the pod the container is getting created. You can see 0 by 1. 0 by 1 simply means that total number of container is 1, total is 1, and out of 1, 0 is running. Okay. No container is running in the pod. This is the pod. This is your pod, my first step. Let's see the output again. I think it will be created. It will be running now. Let's see it again. 𝐶ubectl get the pod and see it is running. It is running 1 by 1. 1 by 1 means this pod has one container, and out of which one is running. A pod can have multiple containers as well. Okay, you can see that it is running. Now, let's go and see more detailed output. Let's see the more detailed output. So 𝐶ubectl describe, I want to describe this pod. Name of the pod is my first app. Describe it. And this is going to describe the pod for you. See the events. See these events. Okay. These events will basically tell you a lot much thing. It says successfully assigned, okay, the default this pod to this node. This is the worker node that I have. I can show you the nodes as well. 𝐶ubectl get me how many nodes I have, how many machines I have. See, this is the machine. On this machine, the pod is running. So in Kubernetes, you have a group of machines, and on those machines, you run the pod. You run the pod. Okay. So the pod that I created, my first app, is running on this node 52K1. Okay. As I have a single node, so it will be running on that machine only. After that, it says pulling image, successfully pulled image in 5.1 seconds, and then created container. And after that, it says started container. Okay. See the events. Let's see. Let's call it up. Okay. See, this is the pod name. This is the IP of the pod. And in this pod, you are running container. This is the container image HTTPD. And I'm not using a Docker container. I'm using container D. I told you there are multiple container runtime, container D. This is used by Google Kubernetes Engine, GKE. I'm using GKE, Google Kubernetes Engine. And Kubernetes has created the container, and that container is container D. It's not a Docker container. Kubernetes has the beauty, as it is open source, it can orchestrate any container tool. It can orchestrate your Docker, container D, Okay, container D or cryo, whatever you have, it can orchestrate any of them. So different tools work with different containers. Like GKE uses container D. Now let's suppose if you talk about OpenShift, Red Hat OpenShift, if you have heard this name, it's also Kubernetes, Red Hat OpenShift. So Red Hat OpenShift is Kubernetes, it's an orchestrator, it's Kubernetes only, but Red Hat OpenShift uses this container, cryo containers. It don't use Docker, it don't use Podman, it don't use container, it use cryo. Okay, so different flavors of Kubernetes works differently. Okay, that's completely fine. Okay, now I was talking about this output. See, the type of container that I'm running is container D, and the image is HTTP-D. This is the image. Now let's go and try to expose the application. Let's try to access our application. So to access our application, I need to expose this. I need to expose this pod. Let's expose this. So kubectl expose my pod, my first app, and the type of service. Basically, there's a type of a service I need to use here. I need to use a node port service. -- port of the application is 80. The port of the service is 80. And the port where my application is running is also 80. And the name I'm giving as my first SVC, first service, first SVC. So I'm exposing my pod. I want to access my application. I'm exposing it up. Okay, so let's hit enter. Okay, so it says it is exposed. Let's see that kubectl get me the service. Okay, give me the services. See the service, first SVC running from last 7 seconds. Now I want to access this. I want to access this service. How will I use it? Okay, so for that I need to have the IP of this node. Let me close this. Okay, I need to have the IP of this node copied, followed by the port number. Port number is 32671. So what I'm going to do is put this here and 32671. That's it. And see, my application is working. You guys can also access this. You guys can also try to access this. I can put the URL on the chat box for everyone. Just click on it, and the application that I have created in the pod, see this kubectl get me the pod. This is a HTTPD application. Okay, and this application, this pod is exposed by a service, and it's a node port service. So as it is a node port service, I can simply use the node IP followed by the port number. This is auto assigned port number. So I've used the node IP. Node IP is, I can see the node IP. Node IP is 34.102.110.91. That is what I'm using. Colon the port number 32671. I pasted the URL on the chat. If you just click on it, you will be able to open the web page, and it should tell you it works. It should be written here, it works. It means I'm able to access the application. I can use another I can use another service as well. Like right now I'm using a node port service. I can use cluster IP, but cluster IP I cannot access from outside. Cluster IP service is used for internal access. Okay, that is where cluster IP is used. And if you want to get a load balancer will have an external IP. Like here, the load balancer will, there are different types of services in Kubernetes. Okay, one is a node port. Node port means that you're using the node IP followed by this port number that is auto assigned. Cluster IP only for internal access, no external access. I cannot access this service from outside. I cannot do that. And there's one more, load balancer. Load balancer is same like node port, but there will be another load balancer created. Okay, that will be load balancing between multiple nodes. And when you hit the load balancer IP, you're actually hitting this service. I can show you load balancer as well. For example, I go and create another service. I go and create one more pod. kubectl run my second pod -- image is equal to 𝐿. I'm running one more pod, and the application is 𝐿 now. Let's expose this. kubectl expose the pod, my second pod, okay, and minus minus type of service as load balancer, okay, load balancer, B capital only, A small, okay, it's, you have to be precise with the syntax, uppercase, lowercase, okay, minus minus port as 80, minus minus target minus port as 80 for the application, and minus minus name as I give second SVC, okay. So target port I have given, so it is created. Now you can see 𝐂𝐝𝐶TL get pod first. Second pod is running, yeah, running from last 47 seconds. Let's see if the service is running. 𝐂𝐝𝐶TL get me the service. See, second service is running, it's load balancer. Now with load balancer, you are also getting same, but you will also get this IP. With node port and load balancer services are exactly same. The only difference is that node port will not get any external IP. Load balancer will get a external IP as well. Let's see it again. Okay. Let's see it. It is still pending. This will take a bit of time, but this will come up. Okay. Why load balancer will get an external IP? Because on the back end, when you're using load balancer service on GCP, a load balancer is also created. Let me show you that. Okay. So if you go here, network services or VPC, where it is, the network services, load balancing, you can see that on the back end, when you created a load balancer service, a load balancer is also created. See this over here. A load balancer is also created over here. See this. And this is the IP of load balancer 34.102.39.189. Same you can see here. 𝐂𝐝𝐶TL get SVC 34.102.39.189. Node port, load balancer are exactly same. The only difference is node port will never get an external IP. Load balancer will get an external IP as well. Now I can access my application using this IP. That's it. Copy and paste. That's it. See, my application is running. It says welcome to NGINX. Okay, you can see that. It says, and it is working exactly what I want. Okay, it is exposing my application. So this is how basically you run your applications into Kubernetes and you expose them using services. And if you're using load balancer in the backend, a load balancer is also created. Okay, and you're getting charged for this load balancer. I'm getting charged for this load balancer. Okay, so normally using load balancers, again, a costly affair on the cloud side. So it's good to go with node port services. But let's suppose if your node don't have any external connectivity, then you can go with the load balancer.
Now that you know Kubernetes, we will move to what is Google Kubernetes Engine. This topic will show you how to run Kubernetes in cloud with Google Kubernetes Engine.
What is Google Cloud Platform? Google Cloud Platform is a suite of cloud computing services and management tools offered by Google. GCP runs on the same cloud infrastructure that Google uses internally for its end-user products such as Google Search, Gmails, Google Photos, and YouTube. GCP is one of the leading cloud service providers along with Amazon Web Service and Microsoft Azure Cloud and owns 7% of the total cloud market share. Gartner has positioned Google as a Magic Quadrant leader among the furthest 3 positioned vendor. Google Cloud's global network spans across 25 regions with 76 zones and is available for the users from over 200 plus countries and territories. Now a region is a specific geographical location where you can host your resources. A region can have 3 or more zones. Also, many enterprises are increasingly adopting Google Cloud Platform because the services offered by Google Cloud are more secure and cost-effective. Now let us take a look at the core services provided by GCP. First is the Google Compute Engine, which is Google Infrastructure as a Service virtual machine offering. It allows customers to use powerful virtual machines in the cloud as server resources instead of acquiring and managing server hardware. Second is the GCP Cloud Storage. It can store the entire organized databases, raw video streams, and even the matrix for machine learning models. It is an object storage system. Its records maintain both the identity and the structure of any class of data given to it. Third is networking. Now GCP provides tools that makes it easier to manage and scale your networks. It provides a single place to publish, discover, and connect all application services, reducing the management and operational complexity. The next service domain is big data. Now GCP provides multiple services like data flow, data procs, and data fusion to help you create a complete cloud-based big data infrastructure that supports big data storage and analysis. The advantage of hosting big data infrastructure in the cloud is that it provides unlimited data storage and easy option for parallel big data processing and analysis. Next, GCP also provides all the tools developers and the development team need to be productive while writing, deploying, and debugging applications hosted in the Google Cloud. The next service domain is identity and security. With GCP IAM, you manage access control by defining who has what access for which resources. It lets the administrator authorize who can take action on specific resources, giving you full control and visibility to manage Google Cloud resources. Next is the GCP IoT service, which provides an intelligent IoT platform which is scalable, fully managed, and integrated. It lets you connect, store, and analyze data at the edge and in the cloud. The next service domain is artificial intelligence. GCP provides fast, scalable, and easy-to-use AI offerings, including an AI platform, video and image analysis, speech recognition, and multi-language processing. This was about Google Cloud Platform. Now let us move on to the next topic and see what is Google Kubernetes Engine. Google Kubernetes Engine provides a managed environment for deploying, managing, and scaling your containerized application using the Google infrastructure. The GKE environment consists of multiple machines, specifically compute engine instance, which are grouped together to form a cluster. Now a cluster is the foundation of Google Kubernetes Engine. The Kubernetes objects that represent your containerized application all run on top of your cluster. Now to understand GKE better, let us understand its architecture and its working. As you know, all Kubernetes objects that represent your containerized application run on top of a cluster. It is a foundation of GKE. A cluster consists of at least one control plane and multiple worker machines called nodes. These control plane and node machines run on Kubernetes cluster orchestration system. The control plane runs the control plane processes, including the Kubernetes API servers, scheduler, and core resource controllers. The control plane is responsible for deciding what runs on each and every node. This can include scheduling workloads like containerized applications and managing the workloads lifecycle, scaling, and upgrades. The control plane also manages network and storage resources for those workloads. Now all the interaction with the clusters are done via Kubernetes API calls. And the control plane runs the Kubernetes API server processes to handle those requests. You can make Kubernetes API calls directly via HTTP/gRPC or indirectly by running commands from the Kubernetes command line client, that is 𝐂𝐝CTL, or interacting with the UI in the Cloud Console. Now coming to the nodes. Now nodes are the worker machines that run your containerized application, which is your containers and other workloads. They run the services that are necessary to support the containers running in your workloads. Each node is managed from the control plane, which receives update on each node's self-reported status. Next, we have something called the user pods. Now, pods are the most basic and smallest deployment object in Kubernetes. It can contain one or more containers. So now when the pod runs multiple containers, the containers are managed as a single entity, and it shares the pod's resources such as networking and storage. They're connected to various GCP services such as VPC networking, persistent disk, load balancer, and other cloud operations. This was the architecture of GKE. Now let us understand its working. GKE works with containerized applications. These containers, whether for application or batch jobs, are collectively called as workloads. And before you deploy these workloads on GKE, you must first package it into a container. Now to create a continuous integration and continuous delivery pipeline, you can use Cloud Code to write your application, then send the code to a repository which launches a build process in Cloud Build. This build process builds container images from a variety of source code repository. These container images are stored in container registry and are ready to be deployed in the Google Kubernetes Engine. You can then create a GKE cluster using Cloud Console UI, gcloud command line interface, or the APIs. After this, with a few clicks, you can deploy your application on GKE. Now I guess you have some idea about Google Kubernetes Engine. Now let us move on to the next topic and see some of the advantage of Google Kubernetes Engine. With Google Kubernetes Engine, you gain the benefits of advanced cluster management features that Google Cloud provides. First is load balancing for compute engine instance. Google Cloud offers server-side load balancing so you can distribute incoming traffic across multiple virtual machine instances. Load Balancer can scale your application, support heavy traffic, detect and automatically remove unhealthy virtual machine instances using health checks, and route traffic to the closest virtual machine. This is a managed service, which means its components are redundant and highly available. So if a load balancing component fails, it is restarted or replaced automatically and immediately. The next benefit is auto-scaling. GKE's cluster autoscaler automatically resizes the number of nodes in a given node pool based on the demand of your workloads. You don't need to manually add or remove nodes or over-provision your node pools. Instead, you specify a minimum and maximum size for the node pool, and the rest is automatic. The next benefit is auto-updating. Auto updates will help you keep the nodes in your cluster up to date with the cluster control plane version when your control plane is updated. With auto update, you don't have to manually track and update your nodes when the control plane is updated on your behalf. It also provides better security by automatically ensuring that security updates are applied and kept up to date with the latest Kubernetes features. The next benefit is monitoring and logging. Google Kubernetes Engine includes native integration with cloud monitoring and cloud logging. When you create a GKE cluster running on the Google Cloud, Cloud Operations for GKE is enabled by default and provides a monitoring dashboard specifically tailored for Kubernetes. With Cloud Operations for GKE, you can control whether or not cloud logging collects application logs. You also have the option to disable the cloud monitoring and cloud logging integration altogether. These were some of the benefits of Google Kubernetes Engine. Now let us move on to a demo part and see how to deploy a containerized application on Google Cloud Platform. So in a demo, we are going to package a sample web application into a Docker container image and then run that container image on a GKE cluster. So for that, I've logged in into a GCP account. Now it is very simple to create a new GCP account. All you have to do is enter your debit card or credit card detail and give your address. Then you might be charged maybe ₹1 for it, but even that will be refunded later. Now, as you sign into a new account, GCP will provide you $300 of free credit. You can use this amount to explore Google Cloud Services. You won't be charged until you choose to upgrade, and it will be valid for 90 days. So first, let us create a new project. So we'll just go here, select a new project. We can name a project anything we want. So we'll just name it Kubernetes. Let the rest be same and we'll just create it. Now a project is created, we'll just select it. So for our demo, we're going to use Cloud Shell. Now Cloud Shell is an online development and operational environment. It can be accessed from anywhere with the browser. The reason we're using Cloud Shell is we do not have to install any command line tools for our demo. So we'll just click on Activate Cloud Shell over here. Then you can see a Cloud Shell terminal which is being created at the bottom of your screen. So the first step, as I've mentioned before, is to build a container image. For this tutorial, we're going to deploy a sample web application called Hello App, which is a web server written in Go programming language. It responds to all requests with the message Hello World on port 8080. But before we deploy the Hello App to GKE, we must package the Hello App source code as a Docker image, and to do that, we need the source code and the Docker file. Now the Docker file contains information about how the image is built. So first, let us download the source code and Docker file for the Hello App application. Git clone https github.com Google Cloud Platform Kubernetes Engine samples. So the Hello App application is available in this website. So we've just mentioned the website URL over here. Just click on enter. So it says that the directory already exists. So we get a message saying the directory already exists. So we'll just change the directory. Next, we have to set the project ID environment variable to the Google Cloud project ID. You can find the project ID over here. But I guess my project ID is the project ID environment variable. So let's just confirm it. So for that, we'll just type echo $, Next, you have to set project ID environment variable to your Google Cloud project ID. So for that, you have to type export project ID is equal to, you can find your project ID over here. So you can just copy it from here and paste it over here. The project ID variable associates the container image with your project's container registry. Now to confirm a project ID, we'll just type echo $project ID. Here you can see this is a project ID. After confirming the project ID, it is time to build Docker image for the Hello app. So for that, we'll type docker build space -t space gcr.io/$ project ID / hello app version 1. Now this is the name given to a Docker image, and GRE refers to the container registry. Oh, we just forgot one more thing over here. That is space a dot. Now it will ask you to authorize Cloud Shell. You can just select authorize over here. Now you can see a Docker image is being created. We'll just extend this. Now you can see our Docker image was successfully built. Now to just confirm if a Docker image was built, we'll just type Docker images. Now you can see a Docker image is built. It was created a minute ago and the size of it. After this, we have to push our Docker image to the container registry so GKE clusters can download it and run the container image. So for this, we are going to enable the container registry API. We'll just type 𝐶loud services enable container registry dot google apis.com. Next, we have to authenticate to container registry by configuring the Docker command line tool. For that, we're going to type 𝐺cloud authenticate configure Docker. Now this is just a warning message saying that we have a lot of credential and it might be slow. So now we have authenticated our container registry. Now we have to push the Docker image to the container registry. So for that, we're going to type docker push the name of our Docker image. Now a Docker image is being built in the container registry. Now you can see a Docker image is pushed to our container registry. Now the next step is to create a Google Kubernetes engine cluster. So for this, we're just going to minimize it and just go to Kubernetes. You can either select Kubernetes engine from here, or you can just type Kubernetes over here. Kubernetes engine. We'll just click on enable over here. Now this might take a couple of seconds. You can scroll down and read an overview about it. You can read about Google and the various other products which are offered by them. Now this is what the Google Kubernetes engine console would look like. So it will ask us to first create a Kubernetes cluster. So we'll just go ahead and create one. Now we have two options over here. One is standard and the other one is autopilot. In standard, you manage your cluster's underlying infrastructure, which will give you node configuration flexibility. And in autopilot, GKE provisions and manages the cluster's underlying infrastructure. So we'll just go with standard over here and click on configure. So we can name our cluster whatever we want. We'll just name it cluster hello app. You can select any zone from here. These are the available zones. So we'll just select maybe US West one. Now you can select the zone which is nearest to you. You can select the version. We'll just go to static version and just create a cluster. Now creating a cluster might take a couple of minutes. So we'll wait for some time and refresh it to see if it is created or not. You can see there is a green tick over here, which means a cluster is successfully created. We have already pushed the Docker image to a container registry. The next step is deploying the sample application to Google Kubernetes engine. For this step, you have to create a Kubernetes deployment to run the application on the cluster and also create something called the horizontal pod autoscaler, which scales the number of pods. It can be anywhere from 1 to 5 based on the CPU load. So for that, we'll go to workloads and click on deploy. We have an existing container image, so we'll just select it. Go to select. This is our project ID and this is the name of the Docker image. So we'll just expand it and select this. Our Docker image is selected. We click on continue. Now we have to configure it. So we can name our application anything we want. So we'll just name it demo application. We'll let the namespace be default. Next we have label, which is basically for identification. So we'll let the key be app and the value be demo application. We'll not make any changes in that. And this is our cluster on which the demo application is going to be deployed. Now when we see the YAM, okay, so we have an error here. We cannot use uppercase. So we'll just make it lowercase, demo application. Now when we see the YAML file, you can see two Kubernetes API resources about to be deployed into your clusters. The first one is deployment and next is the horizontal pod autoscaler. Next we'll just click on deploy and our deployment is being created. Now this might take only a couple of seconds. Here you can see the CPU usage, memory usage and a disk usage, but as of now there is no data available. Now if you go to details, you'll see a cluster name, the namespace which I have mentioned, when was it created and at what time, the labels, how many replicas were made. There were 3 replicas which were made. So after the deployment, we're going to expose the sample application to the internet. So for that, we have an option here called as expose. So we'll just click on this. In the target port, we'll select 8080. Now this is the port the Hello app container listens to, as I had mentioned at the starting of the demo. The service type, let it be load balancer itself. And we can name our service anything we want. Let it be demo application service itself. And we're just going to click on expose over here. Now a new service has been created and it is waiting for a load balancer with an external IP to be created. Now this might also take a couple of seconds. Now a service has been created. So when we go to details, you can see the cluster name, the namespace, when was it created, the label, the pods, the type load balancer and external endpoint. So we'll just click on this, or you can just copy this and paste it in a new tab. So when we click on this, we are directed to a sample application. So here is a sample web application. Now you see our sample application is exposed to the internet through Kubernetes service. And here is the hello world message with the version and the host name.
After covering Google Kubernetes engine, we will move on to what is Ansible. You will learn how Ansible automate configuration management in DevOps.
Well, Ansible is a simple open source IT engine which automates the application deployment, intra-service orchestration, cloud provisioning, and many other IT tools. Not only this, but Ansible also is very easy to deploy because it does not use any agents or custom security infrastructures. So Ansible uses playbook to describe automation jobs, and playbooks use very simple language, that is the YAML. So what do you think this YAML is? Well, YAML is a human readable data serialization language and is commonly used for configuration files, but it can be also used for many applications where data is also stored. So this means it is very easy for the humans to understand, read and write, isn't it? So the advantage of YAML file is that even the IT infrastructure support guys can read and understand the playbook and debug if needed. So it's basically a really simple language and makes it really easy for the humans to read, write and understand. Now moving on with the session, as Ansible is designed for the multi-tier deployments, Ansible does not manage one system at a time. It models the IT infrastructure by describing all of your systems which are interrelated. So Ansible is completely agentless, which means that Ansible works by connecting your nodes through SSH by default. But if you want any other method for connection like Kerberos, Ansible also gives you that option. So after connecting your nodes, Ansible pushes some small programs called as the Ansible modules, and Ansible runs that modules on your nodes and removes them when they are finished. So it also manages your inventory in simple text files. Those are basically the host files that you can see on the screen, where Ansible uses the host files where one can group the hosts and control the actions on a specified group in the playbooks, right? Next, as I was telling you about Ansible, and Ansible is the tool for configuration management, you should also understand configuration management before you understand how to deploy it with the tools. So talking about configuration management in terms of Ansible means that it maintains the configuration of a product performance by keeping a record and updating detailed information which describes an enterprise hardware and software. So such information typically includes the exact versions and updates that have been applied to install software packages and the locations and also the network addresses of the hardware devices. So for example, if you want to install the new version of the WebLogic server on all the machines present in your enterprise, it is not feasible for you to manually go and update each and every machine, right? So you can install the WebLogic server in one go on all your machines with the Ansible playbooks and inventory written in most simple way. So all you have to do is that you have to list out the IP addresses of your nodes in the inventory and write a playbook to install the WebLogic server. After that, you have to run the playbook from your control machine and then it will be installed on all your nodes. So guys, now that you've seen what configuration management is, let me show you how does Ansible work. So basically, Ansible works by connecting your nodes and pushing out small programs called as Ansible modules to them. So Ansible then executes these modules over SSH by default and then removes them when finished. So your library of modules can reside on any one machine and there are no servers, daemons or databases required. So the management node that you can see on the screen is basically the controlling node which controls the entire execution of the playbook. It's the node from which you're running the installation and the inventory file provides the list of the host where the Ansible module needs to be run and the management node does a SSH connection and then it executes these small modules on the host machine and installs the product. So the beauty of Ansible is that it removes the modules once those are installed so that it effectively connects to the host machine and then it executes those instructions and if it's successfully installed, then it removes the code which was already copied on the host machine and that was which was executed. So guys, that's how Ansible works. Now, if you talk about the features of Ansible, let's take a look at them one by one. So the first is that it is agentless. By agentless, I mean that there's no kind of software or any kind of agent managing your node unlike Puppet or Chef, where you need to install a Puppet agent or a Chef client on all your node machines. But for Ansible, what you just have to do is you just have to install Ansible in your control machine and then you're good to go. After that, it is built on top of Python and this helps to provide a lot of functionalities of Python, right? Now coming to SSH, Ansible uses SSH for secure connections. Now SSH is a very simple passwordless network authentication protocol which is very secure. So our responsibility is to just generate a public key in your control machine and copy the same key onto your node machines. So coming to the final feature, the Ansible is also a push-based architecture for sending configurations. So in the case of Ansible where you want to make any kind of configuration changes on your nodes, all you have to do is you just have to write down those configurations and then you just have to push them all at once in your nodes. So if you talk in simple terms, what it does is that it gives you full control on whenever you want to make changes on your nodes and also makes it very easy and fast to set up and needs very minimal requirements. So guys, the features of Ansible are it's agentless, it's built on top of Python, it uses SSH and also uses the push-based architecture. Now as in the features section, I was talking about that Ansible is a push-based architecture. What do you think is the difference between the push-based architecture and the pull-based architecture? Well, tools like Puppet and Chef are basically pull-based configuration management tools, whereas Ansible is push-based configuration management tool. Now, in the case of Puppet and Chef, their agents present the agent software that Puppet has and is basically called the Puppet agent, and in case of Chef, it is known as the Chef client. So what this agent actually does is that it keeps on pulling the central server periodically for any kind of configuration information, and whatever it finds, it pulls those changes and then gets them affected on your node machines. Whereas in the case of Ansible, since there are no agents present, whenever you want to make any changes, you can make those changes directly and you can push those configurations directly whenever you want to, as you've got full control over it. Not only this, but also in a push-based configuration management system, So as you can see on the screen, there's a version control system which manages all the changes in the code base, and then we have a server. So basically this server will have Ansible or any other configuration management tool system installed there, and then we'll have a bunch of nodes. So these bunch of nodes are basically the collection of web servers and application servers and also the database servers, and all these are connected to the main server via SSH. Now what happens here is that these main servers constantly pull the version control system for any changes in the code base. By this, I mean that it constantly keeps on checking the status of version control system at regular intervals of time. And whenever there are any kind of changes, those specifications are sent to the main server, and then the server decides on how to take those configuration changes according to the changes in the code base. Now, in the situation where you want to write all these new configurations, you can directly push them all at once onto your node machines. So you've got full control here, and whenever you want to make any changes, you can make the required changes. Now, coming to the pull-based configuration, the relation between the version control system and the central server is the same. It basically constantly pulls for the changes to the version control system for any changes in the code base, and whenever there are changes, it pulls those changes. But the main difference between both the architectures is that from a push-based configuration management tool, it has got an agent present, and then this agent or the client is a software that manages all the nodes. So what this agent does is that it constantly pulls the central server for any configuration changes. By this, I mean that it keeps on checking the central server for any changes in the configuration that needs to be made, and whenever it finds any kind of configuration changes, it pulls those changes, and then only it gets affected onto the node machines. So at this point, you have to wait for an agent to pull those changes, and only then the configuration changes will get affected onto your nodes. So the basic point is you have to be a little bit dependent on the agent here and the improvement tools, right? So as I was chanting from the beginning of the session that Ansible is really simple, it's very easy to learn because it gives us the simplicity of push-based system. But there's a disadvantage with the system. That's because you cannot achieve full automation with the push-based system, because it's not usually possible to boot a server and have it configure without some sort of client or server protocol, and also it gives you a lack of scalability, as well as when you're dealing with hundreds of servers, a push-based system will start showing its limits unless you make use of threading or multiprocessing. Alright guys, so those were the differences between the push-based configuration and the pull-based configuration. So Ansible is basically a push-based configuration management tool. Now moving on with the session, as I've talked so much about Ansible, you would be interested to install it. So how do you think that you can install Ansible? So before I start telling you the steps to install Ansible, let me tell you that there are basically two types of machine when we talk about deployment. Those are the control machine and the remote machines. So the control machines are the machines from where we can manage other machines, and the remote machines are those machines which are handled or controlled by the control machine. So there can be multiple remote machines which are handled by a single control machine. So for managing remote machines, we have to install the Ansible on the control machine. So now let me tell you the steps to install Ansible. So for that, you just have to type in the command sudo apt-get update. So this command will basically update your repositories. Now once that is done, you have to install the common software properties. So for that, you'll type in the command sudo apt-get install software-properties-common. So you can see that on the screen that your installation is going on. Now once that is done, you'll type in the command sudo apt-add-repository space ppa:/ansible/ansible. So this will basically include your Ansible's repository. So you can see a description about Ansible. Now if you want to continue, you just have to press on enter. So once you press on enter, you can see that it is getting continued. Now once this is done, you again have to update your repositories. So for that, type in the command sudo apt-get update. Now once you're done updating your repositories, you have to install Ansible. So for that, you'll type in the command sudo apt-get install Ansible. So this will basically install the Ansible tool. So you can see that your Ansible has been installed. So guys, that's how you can install Ansible. Now let's move on with the session. So now let me just give you a summary of the commands that you need when you install Ansible. You just have to update your repositories. Once you're done with that, you have to install the common software properties. Once that is also done, you'll add a new repository on the name of Ansible, and then you'll update your own repositories, and then finally you'll install Ansible. So these are the commands that you have to use. Now moving on with the session, what do you think this host inventory is? Well, inventory defines a group of hosts which are alike in any way. So for example, you would want to group your web servers in one group and application servers in another, right? So a group can have multiple servers or a single server that can be a part of multiple groups. So the name of the group is enclosed in square brackets, and the server names can be their DNS names or IP addresses. So by default, Ansible looks at the inventory file, but that can be modified by passing the inventory part to the Ansible command line. So we can modify the way Ansible connects to our host by supplying the additional information in the inventory file. So as you can see on the screen, this is just a list of IP addresses on my nodes. And also you can name the groups of your different IP addresses. So for example, if I want to group my web servers together and my data servers together, all I have to do is I have to write a group name between the two square brackets and a big group together. So whenever you want to make configuration changes, just on the web server and not on the database server, all you have to do is you just have to mention the group name on the host, and then it will automatically configure your web server. So guys, that was about host inventory. Now if you talk about another key term in Ansible, that is Ansible modules. So modules are those executable plugins that get the real job done. So usually modules can take the key value arguments and run in a customized way depending upon the arguments themselves. So a module can be invoked by command line or can be included in the Ansible playbook. Now, let me tell you some commands related to Ansible modules. Now, if you want to use the modules from command line, you have to type in the command ansible all-m ping. Now, if you want to use the ping module to ping all the hosts defined in the inventory, then you have to type in the command ansible web servers -m command -a ls. So this will basically list all the modules present and then it will ping. Now, if you want to flush IP table rules on all the hosts in the inventory, then you have to type in the command ansible -i inventory all-m command -a IP tables f -become -ask -become -pass. So this will basically tell Ansible to execute the command with sudo privileges. So if you want Ansible to gather facts about the host, then you have to type in the command ansible all-m setup. And also if you want to extract particular facts in the documentation of the setup module, you have to type in the command ansible-doc setup. So guys, these were few commands that you can use with Ansible modules. Now moving on with the session, let me tell you about the YAML files because that is the file that has been used. So Ansible uses YAML syntax for expressing Ansible playbooks. Ansible uses YAML because it's really simple for humans to understand, read and write when compared to the other data formats like XML or JSON. So every YAML file optionally starts with 3 hyphens and ends with 3 dots. So as you can see on the screen here, it starts with 3 hyphens and ends with 3 dots. Now, you can also use abbreviation in YAMLs to represent dictionaries. So as you can see on the screen, it basically follows the pattern of a key value pair. So here the key value is James and it has various values like its name, roll number, division, sex, everything. So the key James has many values like the name James John, the roll number to be 34, the division to be B and the sex to be male. Not only this, but we can also represent the list in YAML file. So every element of the list should be written in a new file with the same indentation starting with a hyphen and a space. So for example, as you can see on the screen, after writing countries, we have written America with a hyphen and a space, and then the next value comes in the next line with a hyphen and a space, that is China, similarly Canada and Iceland. So if you have to represent this list in an abbreviation form, it can be represented in the form of countries, colon, and in a square bracket, you can type in America, China, Canada and Iceland, right? Now further talking about YAML files, you can also represent a list of dictionaries. So YAML uses the pipeline to include new lines while showing multiple lines and uses the greater than symbol to suppress new lines while showing multiple lines. So due to this, we can read and edit large lines, and in both the cases, indentations are ignored. So guys, that was about the YAML files. Now talking about Ansible playbooks, let me tell you how to write an Ansible playbook. But before that, let's see what exactly Ansible playbook is. So as I've told you before, that the playbooks are the files where Ansible code is written, and these are written in the YAML format. So YAML stands for yet another markup language, and playbooks are one of the core features of Ansible and tell Ansible what to execute. So they're like the to-do list for Ansible that contains a list of tasks, and playbooks contains the step which the user wants to execute on a particular machine. So playbooks run sequentially, and playbooks are the building blocks for all the use cases of Ansible. So each playbook is an aggregation of one or more plays in it, and playbooks are structured using the plays. So they can be more than a play inside a playbook, and the function of a play is to map a set of instructions defined against a particular host. So since YAML is a strict type of language, we need to take extra care while writing the YAML files. So now let me tell you how can we create a playbook. So as I mentioned before, YAML starts with 3 hyphens, and then we have different YAML tags. So now let's go through each and every YAML tag. So the different tags that are included are the name, host, vars, and task. So the name tag specifies the name of the Ansible book. So basically I'm talking about as in what this playbook will be doing, or any logical name that can be given to this playbook. Coming to the host tag specifies the list of hosts or the host group against which we want to run the task. The host field or tag is mandatory, and it tells Ansible on which host to run the listed task. So the task can run on the same machine or on a remote machine, and one can run the task on multiple machines, and hence the host tags can have a group of host entry as well. Coming to the vars tag lets you define the variables which you can use in your playbook, and usage is very similar to the variables in any programming language. Now coming to the final tag, that is the task. All the playbooks should contain tasks or a list of tasks to be executed. So the tasks are the list of actions one needs to perform. So a task field contains the name of the task, and this works as a help text for the user. Well, it's not mandatory, but proves useful in debugging the playbook. So each task internally links to a piece of code called module. Now let's move on to the hands-on part where we'll basically, create a playbook, and then I'll show you the working of Ansible. So let's get started with our hands-on part. So first we have to create an SSH connection, right? To create an SSH connection with the node, so for that you have to type in the command ssh-𝐾𝐗n. So this will basically, generate your key. So once you type in the command, you can see an output that it is generating a RSA key pair. Now if you have to mention the directory where you want to store the key, but if you press enter, it will store it as a default location. So let me just press enter. And once you press enter, you can see an output that it has created a directory for SSH. Now you have to enter the passphrase. So for that, let me just press enter again. And again, we have to mention the same passphrase. So for that, let me just mention it again. And you can see that, our key has been generated. Alright, now once your key has been generated, you have to create a host inventory file. So we're creating a host inventory file so that we mention the specifications of the node IP address that we want to connect with. So for that, you'll type in the command. Sudo, and then you'll mention the directory of your host. So I've just mentioned the directory, and then I'll press on enter. So it will ask for my password. So I'll mention the password. So as you can see on the screen, this is the default host inventory file. Now as we have to mention the name of our servers, I'll just mention it in the square brackets. Let's say I mention the name to be test servers. So for that, I'll type in test servers, and then I'll mention the name of the node. So let me just type in the name of the node. So over here, my name of the node is KNode. So I've mentioned that. Now once this is done, just save this file and close this file. So for that, you'll press the keyboard shortcut Ctrl X and then press on Y. So this will save your host inventory file. So once you're done with that, you have to mention the SSH generated key in the K node. That is the node that we just configured, right? So for that, you'll type in the command ssh-copy-id space -i space and the name of the node. So over here, my name of the node is KNode. Once I'm done with that, I'll press on enter. And you can see that, it will ask for a confirmation. So let's just say yes. So you can see the output that our key has been copied. Once you're done with that, you'll be asked for your password. So let's just type in the node password. And you can see, your key has been successfully added to your node. Now, before I move forward, I've just cleared my terminal. So just in case if you want to know the command is clear. So once you type in clear, the terminal gets cleared. Now moving on with the hands-on. Now, once your key has been generated, you have to, create a playbook. So before I start creating a playbook, let's just check if our test servers are running or not. So for that, you have to type in the command Ansible space -m ping and the name of the server. So here I've given test servers. So I'll just type in that command and then I'll press on enter. Now once this is done, you can see an output that it is successful. So now let's start creating playbooks. So to start creating playbooks, you have to first create a YAML file. So for that, you have to type in the command sudo nano. Let's say I give the name to be Edureka demo.yaml. So this opens up a YAML file. Now let's start mentioning the specifications required. So first I'll mention the host. So as I mentioned before, that YAML file starts with 3 hyphens. So let me just mention 3 hyphens and then I'll press on enter. So let's start by mentioning the YAML tags. So let's start with the host. So for that, I'll type in -host space : I'll mention the name of the server, that is the test servers. Then I'll mention become. And over here, you make sure that you do not miss out the space. So it has to come in one go. And then let's say I put it true. Then I'll mention variables. So for that, I'll type in the command vars. And then you have to make sure that you're maintaining the syntax. So I'll type in vars, mention a colon, and then inside which I'll type in Ansible -become -pass to Edureka. That is basically our password. Then I'll again mention task space : and then inside which I'll mention the name. That is basically the name of the task. So for that, I'll type in -name space : install nginx. And then let's mention the package also, space : space pkg is equal to nginx space state is equal to installed. And then I'll put in a space, and then after that, so let me just put in spaces, and then I'll mention notify : I'll press on enter. I'll go inside that, I'll mention -start nginx. After that, let's press on enter, and now let's mention the handlers. So for that, let's again maintain the spaces, space : inside which we'll again mention the name. So for that, we'll mention name space : start space nginx, and then mention the service. So that is name nginx state is equal to started. So guys, this was my YAML file to create a playbook. So for that, I'll press the keyboard shortcut Ctrl+X and then I'll press on Y. So this will save my file. Now once you have saved this file, you have to run your playbook. So for that, you'll type in the command Ansible -playbook and the name of the YAML file. So over here it's Edureka demo. So I'll mention Edureka demo.yaml and then I'll press on enter. So you can see on the screen that the playbook is running. So as you can see, the playbook has run. So basically it mentions name of the server, that is the test servers. It mentions the task. So we wanted to install nginx, so it has mentioned the task. Then it also mentions the running handler node, that is the K node over here. And then it also mentions whether it is unreachable, failed or not. So guys, this is how playbook runs. Now once the playbook runs, it automatically installs your nginx container. That is basically the task that we mentioned. Now to check whether it is running on the other node or not, you have to switch to your other node. So let me just switch to my other node. Now to check whether nginx has been installed or not on the other node, let's type in the command ps aux, that is WAUX space pipeline space grep, the name of the file that we installed, that is nginx. Now let's press on enter. So you can see the output that it has been installed. So guys, that's how Ansible basically works. It's really simple to do, right? So you just have to mention on one node and all the actions will happen on all the other nodes connected to it.
Moving on to our next question, Ansible is a tool used for, and the options are A. Container orchestration, B. Configuration management and automation, C. Continuous integration, or D. Cloud resource monitoring. If you know the correct answer, please comment down below. After Ansible, we will discuss why Terraform. This topic will explain why Terraform is key for infrastructure as code in DevOps.
Let's start with understanding why should you use Terraform. There are some great pre-existing tools like Ansible, Chef, Puppet, and SaltStack. But then what makes Terraform better than these tools? First reason is that Terraform is a server orchestration tool. All the above mentioned tools were created for server configuration, meaning that their primary goal is to install and manage software on the already existing server. Terraform concentrates more on server provisioning, with software container deployment left to Docker and Packer. The next reason is the immutable infrastructure. With Chef, Salt, Puppet, or Ansible, any software update must be run in place. Thus, every server grows a unique record of updates throughout its life cycle. This can quite often lead to so-called configuration drift when the differences in these configurations lead to bugs. Terraform addresses the issues by utilizing an immutable infrastructure approach, where every new update of any parameter creates a separate configuration snapshot. This way, updating the development environment goes smoothly and is completely bug-proof. The next reason is the declarative code style. While Chef or Ansible forces you to write step-by-step procedural instructions for reaching the desired state, Terraform prefers describing the desired each state of the system, and the tool itself deals with reaching the goal state. But why is it better? With the procedural code, you need to think of all the recent events and processes that took place in order to write clear instructions. But with Terraform, you simply order the tool to do something with the currently active state of the system. This is why the code base remains quite small and easily understandable. The fourth reason is the client-only architecture. Terraform leverages the cloud provider's API for provisioning the infrastructure, which removes the need of additional security checks, running a separate configuration management server, and multiple software agents. Ansible does this by connecting through SSH, yet the capabilities are quite limited. So, what is Terraform? Terraform is an open source infrastructure as a code tool developed by HashiCorp. It is used to define and provision the complete infrastructure using an easy-to-learn declarative language called HCL, or HashiCorp Configuration Language. Terraform supports multiple providers such as AWS, Azure, Kubernetes, Google Cloud, and many more. Now let's understand Terraform better through a use case. Rapider is an agile, innovative company. They are providers of strategic cloud consulting, cloud migration, DevOps automation, managed services, and security consulting. So once their client was looking for a cloud agnostic tool to orchestrate the infrastructure onto multiple public clouds. They wanted the infrastructure to be up in a matter of few minutes. The client had different environments like production, staging, and QA to test. Database backups were also included as a part of infrastructure setup. DevOps engineers at Rapider reviewed and analyzed the client's requirements and came up with a solution of using Terraform to codify the provisioning of infrastructure onto public cloud. Not only infrastructure, but Rapider also automated the application deployment process by integrating GitLab to improve the software development and accelerate the software delivery. The solution provided by Rapider also took care of database backup for a situation when the infrastructure is destroyed. Using this solution, the client is now able to test their application and deploy it on production environment without downtime. So the overall benefits that a client could experience include the client's ability to create the infrastructure over multiple public clouds within a matter of few minutes. Next is that the client has the flexibility to launch the infrastructure as and when needed. Furthermore, the automated deployments help the client push the application into production seamlessly, thereby reducing the time to market. Also, the automated backup of the database ensures that they always have a copy of their latest database. Moving ahead, let's understand Terraform lifecycle. It includes initialize, plan, apply, and destroy. Terraform init initializes the working directory, which consists of all the configuration files. Terraform plan is used to create an execution plan to reach a desired state of the infrastructure. Terraform apply then makes the changes in the infrastructure as defined in the plan, and the infrastructure comes to the desired state. Terraform destroy is used to delete all the old infrastructure resources, which are marked tainted after the apply phase. Now let's see how Terraform works. Terraform core uses two input sources to do its job. The first input source is a Terraform configuration that you as a user configure. Here you define what needs to be created or provisioned. The second input source is a state where Terraform keeps the up-to-date state of how current setup of infrastructure looks like. So what Terraform core does is it takes the input and it figures out a plan of what needs to be done. It compares the state and checks what is the current state and what is the configuration that you desire in the end result. It figures out what needs to be done to get that desired state in the configuration file. The second component of architecture is providers for specific technologies. This could be cloud providers like AWS, Azure, or other infrastructure as a service platform. It gives you the possibility to create infrastructure on different levels. Terraform has over hundreds of providers for different technologies, and each provider then gives Terraform user access to its resources. For example, AWS provider gives you access to hundreds of AWS resources like EC2 instances, the AWS users, etc. With Kubernetes provider, you can access commodities, resources like services and deployments, namespace, etc. So this is how Terraform works, and this way it tries to help you provision and cover the complete application setup from infrastructure all the way to the application. Moving ahead, let's see how to install Terraform. Now to install Terraform, let's go to its official website. So the system I'm using is a 64-bit Linux system, so I'll install Terraform for that. I'll copy the link first. Then what we need to do is open the terminal. Then we write wget and we paste the link we had copied and enter. So now Terraform will get installed. Okay, so Terraform has been installed. Since it's a zip file, let's unzip it now. And this is the file name. Let's copy that. Now let's move Terraform to a location. Let's see what the location will be. So we'll be moving Terraform to this location. Okay. Now that it has been successfully moved, let's see the Terraform version that we have. So it's 14.5. Okay. So by writing Terraform and entering, you'll see what all commands Terraform provides you. So these are all the commands. It also includes init, plan, apply, destroy, as we discussed before. There's something also called as validate that you can use, and several other commands. Now that we have installed Terraform in our system, let's move ahead with our demo. So let's just clear screen. Okay. Now what we need to do is we are going to create a directory and we are going to name it Terraform demo. Okay. So let's move into that directory now. Now what we are going to do is we are going to create a configuration file, Terraform configuration file over here. So let's write gedit and the file name. So let's name it demo1.tf. So this is the extension that we need to put for any Terraform configuration file that we are going to create here, and hit enter. Okay, so the gedit file, Terraform configuration file, has been created. Here is where we are going to put all the configuration we need. So initially, let's try to create an EC2 instance in Amazon Web Services. and then destroy that EC2 instance. Okay, so what we need to do here is Terraform provides you with everything, every support that is there for your code online. So let's say AWS provider Terraform. Okay, so you can see the usage here. This is what we need to define that we want to create or use AWS service. Let's paste this here. Okay, so it asks for region, access key and secret key. So what are access key and secret key here? We'll get that from Amazon Web Services. Let's see how. So I'm going to create a user over here. I'm going to give it Terraform. And I'm going to give it a programmatic access. Along with that, administrator access. And next. So let's give this as my demo. And value as Terraform. Okay, let's just keep it to Terraform. So this is the summary. And let's create it. So user has been created, and this CSV file is what we need to download to get the, the access key and the secret key. Okay, we have the file here. Let's open it. So this is the access key here. Let's copy this and we are going to paste it here. And we have the secret key. Again, let's copy and paste it here. Okay, so for region, let's create this for US East 2. Okay, now we are going to put what resources we need. Since we are creating EC2 instance, let's so what we need is just this part for now for creating our instance. Let's paste it here. Okay, so it says we want to create AWS instance. Let's change this to, and this AMI is for US West 2. So every time you change the region, AMI is going to change. So let's find it for US East 2. So let's check. So we are on US East 2 right now. And you can see there are no instances running. Okay, so suppose we want to create an instance. We want to launch one. So here you can see the AMI for US East 2. Let's copy that. And we'll paste this here. Okay. So I think this is enough. We don't need to add anything else. We have provider AWS and we have given the region, access and secret key. We want to create AWS instance and AMI and instance type as T2 micro. Let's keep it that way. Okay. Let's save the file and close it. Now let's go back to the terminal. And now what we are going to do is initialize it. Then let's apply Terraform plan. Okay, you can see here one in the plan, which is the EC2 instance we want to create. And then finally Terraform apply. So it asks for an approval from you. So you just write yes over here. Okay, it says one added. Let's go back to AWS and see if the EC2 instance in US East 2 has been created. Okay, so you can see the instance has been created here. Okay, yeah. So one instance is running and we are in US East 2. So the instance has been created. Okay. Now what we need to do is we want to destroy this instance that we have created. Now simply what we need to do here is Terraform destroy, and this will destroy that instance. Okay, you can see one destroyed over here. Let's see if it has been destroyed. So you can see we had an instance over here, but it has been destroyed now. So this was a very simple and basic demo that I have shown you here. Now let's do something a little more complicated. Let's try to add some more services that AWS provides you. So let's clear the screen. Okay. Now what I'm going to do is we have the same gedit file over here. You can see the demo 1. Okay. So we have written a code partially over here. Let's include some more things and additional features in this code itself. So just remember that this instance has been already destroyed. So while we initialize, plan and apply, this instance is going to be created again if we keep this code. Okay. So I want to create this instance again. But apart from that, what I want to do is I want to create another EC2 instance in some another region. So let's see how to do that. For that, let's copy this. Okay. So all I need to do is, suppose I want to create another instance in US East 1. So let's change this. The access key, secret key is going to remain same because we are making it through the same user. Okay. Let's create another resource here because we want to create one more instance. Okay, let's name this something like US East 1. Okay, and just remember the AMI is going to change for US East 1. Okay, so let's search for that AMI now. Okay. Yeah, okay, there is no instance over here. So suppose we want to create one. So you can see the AMI here for Linux. So let's copy this, and so this is the US East 1. Let's paste this here. So you can see the AMI differs from region to region. Okay. So we have done this now. What we need to do is, how will this resource understand that it wants to create an EC2 instance in US East 1? So for that, what we are going to do is we are going to create an alias. So let's put this as okay. So this is done. We have added the alias over here. So let's refer this to this part. Okay, this alias that we have created. How we are going to do that is by writing provider is equal to AWS dot whatever alias we have provided here, copy paste it. Okay. So this is done. Now, apart from this, let's see, we want to create an S3. So, okay, S3 bucket. Okay, so for S3, this is what we need. So let's copy these and paste it here. Okay, so let's change this to something. Let's keep this. So one thing to remember is that the bucket name has to be unique. So let's try to make a unique name over here. Okay, let's keep this. Let ACL be private. Let's change this to my Terraform bucket. And let's keep this dev-env. Okay. Apart from this, what we are going to do is we are going to add versioning over here. So why we are adding versioning here is because we want to preserve, retrieve, and restore every version of every object stored in our Amazon S3 bucket. So that's the reason we have added the versioning block over here. Okay. So looks fine. Let's save this. Okay, so we have one EC2 instance in US East 2, another in US East 1, and one S3 bucket. So remember that in case of US East 2, we haven't used any alias. So what it is going to do is it is going to refer to this default one where there are no alias, nothing provided for it, to refer. So it's going to refer this by default, US East 2. Okay, let's save this. And let's close this. Okay. Let's open the terminal and let's initialize again. Then plan. Okay, so you can see 3 over here, 2 EC2, 1 S3. Let's apply it. Okay, so you can see 3 added. Let's check it now in AWS. Okay, so we are in US East 1. So we will have 1 EC2 here. Okay, so we can see one instance running. Okay, so we have one instance running over here. Let's check it in US East 2. Okay, so we have one instance successfully running over here as well. And let's check our S3 bucket. Okay, so you can see we have one S3 bucket created over here successfully. Great. Now, let's say we want to add a VPC, one subnet, and also want to create relational database system. Okay, so more 3 things, VPC, subnet, and RDS. So what we can do is we can actually add to this rather than creating another file. So let's open this again. Okay, so below this, let's start adding. But one thing to remember is that we haven't destroyed any of this yet. The 2 EC2 instances and S3, we haven't destroyed them. So what we are going to do is we are going to add to this. Okay, so what we are going to add, let's start with VPC. So okay, so let's copy this. This is what we need to create a VPC and paste it here below. Okay, so it says the resource we want to create is AWS VPC. Let's give this a name as dev. Okay, cider block. Okay, let's keep this and let's keep this default. Okay, let's change the tag name to something else. Let's keep it dev VPC. Okay, so that's done. Now suppose you also want to create subnet. So let's search for that. Okay, let's copy this and paste it here. Let's again change a little bit. Let's give it a name as sub. Let's keep the CIDR block same. And let's change it to dev subnet. Okay. So one thing to see over here is we need VPC ID over here. But since we haven't created a VPC yet, how will we give the VPC ID over here? So there is a way to do that. So what we are going to do is let's just copy the whole thing that we have over here. Copy this and paste it here. We don't want the double inverted commas. Okay. So this is how we are going to give the VPC ID to our subnet. Okay. It's the same as this over here. Just AWS VPC dot dev dot ID. Okay. This is how it will get the ID of the VPC. Okay. So this is done. Apart from that, as we said, suppose we want to create RDS. Let's see what to do for that. So you can see the basic usage here. Let's copy this. And let's make some changes. We want engine version as 8.0.19. Okay. And let's change this to 8.0. Okay. So we are going to add one more line over here, which is we don't want to create a snapshot of this RDS that we are creating. Okay. Suppose this is some dummy RDS that we have created. We don't want any backup for this. So we are going to provide it that we don't want a snapshot. Okay. Okay. So we have written skip final snapshot and we have kept it true. Okay. So it won't create a snapshot. Okay. So that is done. Let's maybe change the name to my Terraform DB. Okay. Username. Let's keep this the same. Okay. This is just an example. So overall, what all we have added to this, we have created one VPC, subnet, and RDS. Let's save this. Okay, and close it. Let's go back to the terminal and initialize it. Then Terraform plan. Okay, so you can see here that 3 to add. So we already have 2 EC2, 1 S3, and apart from that, we are adding one VPC, subnet, and RDS. Okay, so let's apply. Okay, so we can see 3 added. Let's go and check. Let's check this in our AWS console. So we can see that S3 is still running, the one we had created before. So the 3 things we have created now is VPC, subnet, and RDS. Okay, let's check those now. So we can see the VPC we have created is now available, it's running, and this one is a default VPC that was already present. Apart from that, let's check subnets. So see, our subnet is present over here and it's running. Rest are default. Okay, apart from that, let's check RDS. So we can see one database instance here. Let's see. Okay, so you can see the RDS we had created for MySQL, that's running now. Okay, now suppose everything that we have created now, we want to destroy it. Okay, imagine how much time would it take to destroy all of these through console. Now let's see how we are going to destroy it through Terraform. So all we need to do here is Terraform destroy. So what all will it destroy? Everything that we have created in that file, everything is going to be destroyed, which includes our two EC2s, one S3, VPC, subnet, and RDS. Okay, everything has to be destroyed through one single command. Okay, let's see. So you can see 6 over here. So let's see if it destroys everything. Okay, so it says 6 destroyed. Let's check one by one. Okay. Now currently we are in RDS. Let's refresh this and see. Okay, so you can see the RDS has been deleted now. It is destroyed. So let's next see VPCs. So we can see the VPC we had created is deleted. The one present over here is the default one. Let's check the subnet. Okay, again the subnet we had created has been destroyed, and these are just the default subnets that are present. Apart from that, let's see EC2. So currently we are in US East 2, right? Okay. So you can see there are no instances running over here. Okay. So the instance we had created has been destroyed now. Let's check S3. As you can see, no buckets over here. So the S3 we had created is also destroyed. Okay, now let's go back to EC2 and we are going to change our region to US East 1. So remember we had created one more instance in different region using alias. Let's see if that has been destroyed as well. Okay, so you can see there are no running instances. Okay, so the instance we had created in US East 1 also has been destroyed. This is just one example of how multiple services AWS provides, and you can do everything through infrastructure as code rather than going through console. Okay, so you can do this with other cloud platforms as well, like Azure Google Clouds, and there are many more. So this was just a simple example for AWS.
With Terraform in mind, we will now look at what is continuous testing. You will learn how continuous testing ensures quality throughout the DevOps pipeline.
What is testing and what is the difference between a continuous testing and an automation testing? That is what we have to discuss. I think the word test means simple. Testing, test. Test means to test something, whether it is working fine or not. You have developed something and you want to see if it is working fine or not. That simple thing is called as testing. Okay. Now, testing can be of two types. It can be automated testing, automated testing. You call it as automation, or it can be continuous testing. Now, what is the difference between continuous testing and what is the difference between the automation testing? Okay. Like for example, I've deployed an application. Okay. I have an application running on the server. I go onto this application, I open the web page, and I'm putting the data and I'm seeing whether the response is correct or not. I'm doing all these things manually. All the things manually by my hand. Like developer has developed the application. After the development is done, I just open the application, enter required fields, enter required data. After that, I simply see that it is working or not. I get the desired output or not. That is what is a manual testing. But normally, nowadays in the IT industry, manual testing has a limited scope. Manual testing only comes into the picture when you cannot automate it. Okay, but normally now, all the things can be automated in the IT world. How? Using some automation tools. Okay, we have some smart tools that can automate writing the test cases. What is a test case? What is a test? What is a test case? A test case is basically a procedure that describes like what should be the input and what should be the desired output. It's a procedure how to test something. That is called as a test case. So earlier, if I talk about long back, what people used to do, these test cases were written manually. Okay. After that, the team sits out, they distribute test cases and they execute each and every test cases manually one by one. That was a time when we do manual testing. Okay. Then later on, with the enhancements in the technology and to save the time, to deliver the product on time, people started thinking manual testing is tedious. First of all, a person can make a mistake. Okay, somebody can make a mistake during testing. And it's a person, let's suppose if he's on leave, then who is testing? The testing cycles, the time to test anything will be increased. So that's why people started switching to automation testing. Means here, you use some tools to code. Okay, you write the code basically using some tools like Selenium, JUnit. There are many tools available in the market. TestNG, there are many tools available in the market. Using those tools, what do? You write the code to test the application. You're writing a code to test it. Okay. So the complete procedure is coded. Then you simply execute that code. That code will go and test the application. On your behalf, that code will go and put the data and see whether the output is getting desired or not. If not, then it will show you the error that it has failed. Now, anyone in your team who knows how to run it can run it. Even if, let's suppose I am the person who is running the test cases automation. I am on leave. If some other person is also know how to run it, he can run it on my behalf. So there's no blockage. And automation is really fast. You execute it, it will give you the output in like within a few minutes, like whether all the test cases have passed or not. So this is what automation brings into speed and less chances of error. Because when a human being is doing it, there are chances that there may be errors coming in even after your testing. Okay. So that's why people switch to automation. Okay. Now, automation is
done by using some tools, like you can use JUnit, or you may be using Selenium, any test cases you may be using, any test tool you may be using. So what is basically a continuous testing? We have seen manual, automation. Automation is done by a tool. What is continuous? Continuous simply means it's automation test, which is done continuously. What does the term continuously means over there? That is what the question is. So for example, let's suppose a developer developed something. Okay, that code is placed. Now that code will be built. You will start creating a package from that code. Okay, after the build, testing will be done. Automatically, test cases will be called and testing will be done. Now, let's suppose any of the test cases fails. Okay, any of the test cases fail. Automation testing is happening. Some Selenium or JUnit test cases are running. Let's suppose the testing fails. At that time, to the developer, a bug will be reported. Hey developer, there is a bug in the code. The test case is not passed. It has failed. What developer will do? Developer will create another version of the code. He will change the code. He will modify the code to fix the bug. He has to modify the code. So he's going to put another version of the code. Let's suppose this was V1. The code version is V2. Okay. Now from this version 2, you created a build earlier, build version V1. Now you will create a build version 2. And then use this build version 2 will again be tested. Let's suppose again something fails. A bug will be reported to developer. Developer will go and create a new version of the code after making the changes. In the V2, he will make changes. So version V3 will be prepared. From the V3, a build will be generated, which will be V3. And this V3 will again be tested. And this loop goes on and on and on and on until all the test cases pass. Until all the test cases are not passed, this loop goes on and on and on and on and on. And this is what is called as continuous testing. Any single bug fix, any feature update, a single line of code is also updated, then also it will be tested. Using some automation only it is tested, like Selenium JUnit, some automation tool will be used. But the testing is happening continuously. Whenever the bug is reported, some code will be changed. From that code, a new package will be generated and that package will be tested. So this is what the continuous testing is all about. Automation means automating the task. You're writing some code to automate the task. Okay, so that is what testing is all about. And that is what the difference between automation and continuous testing is. This is the loop: planning, coding, building, testing. Basically, this is your CI loop and this is your CD loop. So testing comes in the CI loop, in the integration loop, where you build and test. You write the code, you build it, and then you test it. Once testing is passed, then you will go and release it, deploy it, operate it, and monitor it. This is your continuous deployment loop. DevOps is all about CI/CD, creating these CI/CD pipelines. You have to create this CI pipeline and the CD pipeline. Okay, starting from writing the code to the deployment of the final application. This is DevOps. This includes many things. Writing code, so maintaining code. Writing code is not part of DevOps. Code will be written by developer. But once the code is written, you have to maintain it. You have to maintain different versions of the code. Okay, you have to build it. You have to test it. Then you have to go and deploy it. After that, you have to operate it. And then you have to monitor it. These are the stages of your software development life cycles, which are handled by DevOps. DevOps is basically a methodology that automates all these tasks, all these stages. Okay. So now, what are different tools used for testing? Okay, tools. We'll talk about these tools. Like we have Selenium and TestNG. Maven is also a tool. Maven is basically a build tool. So we'll talk about these tools in a short while, but let's first talk about what are different types of testings that we perform. What are different types of testing? So we have heard many of the names: functional, unit testing, load testing, stress testing, integration testing, regression testing. What are these? So if I talk about them, functional testing means, by the name it is clear, functionally application is working or not. Like I gave an input and I get the desired output or not. That is what functional testing is. Okay. To check whether the required functionality that is mentioned in the requirement of the customer gave you some requirement. So in functional testing, we see that whatever was the requirement is actually working or not, is functionally working or not. That is what functional testing is all about. Second is your unit testing. Unit testing means, let's suppose in an application you have different components. You have a front end, you have a back end, you have a middleware, you have a caching, you have a queuing server. Like one application has many components. So testing each and every component independently is called as unit testing. Okay, unit testing means testing smaller components of your application, small components. Okay, front end, back end, middleware, then you have any caching or any other layers, any other components that you have. Testing each of them individually and checking whether they are working together or not. They are working independently or not. Their functionality wise, they're working or not. That is what we check in unit testing. Okay. And integration testing, if I talk about this integration testing is all about when you combine all these units together. First of all, we test each and every individual unit. After that, we combine all these units together. Okay. After combining all these units together, we see that whether our final application is working or not. That comes under integration testing. So integration testing is all about integrating the components, combined together, and to see if all the components when combined together are giving the desired output or not. That is what is your integration testing. Okay. Then after this, we have load testing and stress testing, almost similar with a small difference. Load testing means you give enormous amount of load on the application. Okay, let's suppose you are creating an application that is going to back up something. You're creating a backup application. Now, how much data that application can back up? So you will start with 10 GB. Okay, that's fine. You will go more, 20 GB, 30 GB, 300 GB, 400 GB, 500 GB, 1 terabyte, 2 terabytes. So you will increase the load capacity to check how much load can the application can handle. Okay, so load testing is basically process of testing the performance of your application during heavy load. Like at 10 TB, when you're trying to back up 10 TB, the application is working very fine, very smooth. 100 GB, also good. But when you're trying to back up 300 GB or 1 terabyte, the performance, the backup is taking much amount of time. The performance is not good. So definitely you have to work on that part. The developer has to work on that part. That the application is failing the loads, load testing, it's not good. The performance for when you're backing up big amount of volume, big amount of data, the performance is not good. So that will be tested under load testing. And stress testing, again, stress testing is a type of a testing to get a break-even point. Like at what point, what load you give to the application and your application will fail. That is called as stress testing. Simple thing to test the maximum load that your application can bear. That comes up under the stress testing. Almost similar, okay, with a small tweak. Okay. And then finally, you have the regression. Now, what the regression is all about? Regression is like, for example, as I discussed that, you make a small one-line change in the code. One-line change. So there, even if you're making that one line of change, you have to run all the test cases right from this beginning till the end. Because that one line change can cause other functionalities. It can hamper other features, other functionalities. Okay, so this is what a standard practice is. Like whenever a developer makes any code changes, complete test cycles have to be executed. Okay, it is not like that you have made a one line of change, you will test that only. No, it can happen that that one line of change can even a one word of change can break other functionalities, can break other components. Okay, so that to test all the features, regression means continuously testing. Even a small component is modified, you will be completely testing the end-to-end entire application. So such kind of testing is called as a regression testing. Okay, so these are different types of testing that are performed in the real world for our applications. Okay, now coming on to the tools, like what tools we use over here. Okay, so let's see the tools. Role of the continuous. So we talked about the tools here, Maven, Selenium, TestNG, Jenkins. Let's talk about these tools a bit in detail. Okay, so Maven, first of all, what a Maven is. Maven is basically a tool that can help you in automating the task, that can help you in building anything. Okay, that decides on the dependencies. For example, I'm writing some Selenium test cases, and that Selenium has some requirement. Okay. So Maven is a tool that will help you in managing the builds, managing the dependencies of the test cases. Like for example, I want to execute Selenium and Selenium requires a Java class. There's a special Java class that is required by Selenium. So who will fulfill that? That is required, that will be done by Maven. Maven is the tool. Maven is the build tool that not only builds the application, but it also goes and resolves the dependencies for testing. So that is done by Maven. Maven is given by Apache. Mainly, Maven is used with Java projects. For Python, we have something different. So we have many tools like Ant, Gradle, Maven. Maven is one of the build tool. Okay, so we have many build tools. Here, we'll talk about Maven because Maven is one of the most popular build tools that is used for mainly for Java projects. Any Java projects means application, a project that is built in Java. Okay, so that is what Maven is. If I talk about Selenium, what Selenium is, Selenium and TestNG and Selenium. So Selenium is a tool that is going to automate, that helps you in automating the test cases. Selenium is mainly used for testing web applications, web pages, any web application that you're developing. Okay, to test that web page, web application, we will be using Selenium. Okay, and it can easily integrate with tools like Maven, TestNG, Jenkins, easily integrate. So Selenium is basically the tool in which you will be writing the code. You will be writing the code, and that code is basically going to test your application. So Selenium will allow you writing that code. Okay, Selenium is the test tool. Maven is the build tool that resolves dependencies, that builds your application. Like for example, I want to build my application that requires some Java class. So that Java class will be pulled by Maven. Okay, Selenium will go and perform testing. And then TestNG. So basically, Selenium has few drawbacks. Like Selenium can automate your testing. Okay, that's fine. But Selenium is very bad when it comes to writing test cases. Like you want to write test case, Selenium will not be able to do it. You want to generate any report, Selenium will not be able to do it. Okay, so Selenium is really bad in doing such stuff. So to maintain those stuff, what we use is we used TestNG. TestNG is another tool that is mainly used for your managing test cases, writing test cases, and for creating test reports. Like, okay, Selenium, all the test cases that were run through Selenium are passed. Who will give the report? TestNG will give the report. Okay, so TestNG is basically a reporting tool and mainly used for performing, managing your test cases, which Selenium won't be doing it. Okay, and last but not the least, we have Jenkins. We have Jenkins. So all these test cases, normally nowadays, testing team writes it. DevOps engineer can also write these test cases, or developer can also write the test cases. Nowadays, there's a trend that, okay, that what happens here is, whenever a developer develops the application, along with that only, developer writes the test cases as well. Okay, instead of DevOps guy writing the test cases or the testing team writing the test cases, the developer only says, okay, we have to test all these things. They write their test cases. Now they can use Selenium, they can use JUnit, anything. Those are tools for executing test cases, for writing it up, for Selenium test cases or JUnit test cases. But yes, they do it up. Okay, and we just have to integrate those. Just have to call those test cases. Okay, we just have to call those test cases and execute those. That's it. And how we do that? We do that using a tool, is Jenkins. So Jenkins, there are many tools available in the market similar to Jenkins. Like you have Bamboo, TeamCity, Hudson. There are a lot many tools which are the competitors of Jenkins. But yes, Jenkins is one of the tools that is very widely used for integrating the things. It's an integration tool. Integration tool means, let's suppose you have the code. Okay. Now using that code, you will first build the code. Building the code means what you have to do is you have to create a package. You have to build it, because raw code cannot be tested. Nobody can test raw code. It's raw Java code. It's raw Python code. You cannot test it. You have to build it. After building, then you will run the test cases. Now, any testing, unit testing, JUnit testing, functional testing, load testing, stress testing, regression, whatever you want to execute, it's up to your wish. You have to test it. And then if all test cases are passed, you have to go and deploy it. That's it. Simple thing. So how you can integrate all these stages together, like starting from pulling the code, building the code, testing the code, after testing, deploying the product. Okay, because you have the code, you build the product, you tested the product, and then you have to deploy the product, and then you have to monitor it up as well. So how this can be done, how all these stages can be integrated. So for doing that, we use a tool called as Jenkins. Jenkins is an integration tool. A tool mainly used for automating the things, for integrating multiple stages. Okay, it can schedule your builds, deploy the code to production or staging server, any environment. You want to deploy, you want to build, you want to test, it will do it. And this is one of the tools that is very widely used. Okay, reason of its popularity is open source. It's the first tool, integration tool in the market. Along with that, the simplicity, the ease. I will show you Jenkins in short while. Okay, the simplicity or the ease that it provides for managing the things is very useful. It's very easy. Okay, so that's why people prefer Jenkins a lot. Okay, so let's see how this Jenkins will help me in achieving test cases, in managing test cases. Let's see over here. Okay, let's go and check it out. Okay, so what I did here is to just show you a small demo over here. We'll see a small hands-on first. Okay, so to show you a small demo, I am on my GCP. You can see that this is my GCP over here. Okay, so to show you the demo, what I did is I've created a machine. You can see this machine is there, instance number 1 that is running. Okay, and onto this particular instance, okay, the IP address of this instance of this machine is this. You can see the IP address. It also has a public IP, and on this machine, I've installed Jenkins. I've already installed Jenkins. You can see that over there. This is the machine. Okay, you can check the IP. Okay, the IP for the machine is 10.128.0.3, and that is what you can verify from here. Okay, this is the internal IP. This is the external IP. Okay, so now what I can do here is just see systemctl status Jenkins. It's installed. To install Jenkins, you can simply go on Google and just type here on Google, just go here and type install Jenkins. I'm using CentOS. If you're using Ubuntu, you can use Ubuntu. So you can just go here, how to install Jenkins. and you can follow these steps. Like I'm using Red Hat CentOS. So you can follow these steps over there to install Jenkins on a server. Okay. Once Jenkins is installed, we can see that it's running over here. Yeah. Now what next I have to do is I have to just access this Jenkins UI. So let's go and access the Jenkins UI. I go here. Okay, I can reopen this if you want. Just a minute. Yeah, I can reopen this. So what is the IP of my machine? Let's see the IP address of my machine. This is the IP internal. External is this. Copy. Okay. And let me open this here. Followed by Jenkins runs on port number 8080. I hit enter. It says welcome to Jenkins. Guys, this is a public URL. You can also open this. I can put the URL on the chat box. Right now, I'm not sharing the ID and the password with you, but you can open this web page. Okay, let me put my admin password, admin and the password. Okay, so you can see I'm logged in. Okay, I'm logged in onto this. This server is created just before I started. Okay, like you can see the uptime. It will be around 30, 40 or maybe 1 hour, not more than that. Yeah, 1 hour and 14 minutes. This is the uptime. So before the start of the webinar, I created this machine. And at the end of the webinar, I will go and delete this machine. Okay. So Jenkins is running. I'm able to log in. Okay. Now, what I have to create a pipeline. What I need to do is I need to perform the code checkout. I need to perform code building. Then I need to test it. And then I need to package it. All those things I have to do. So for doing that, I have a sample Java code with me over here. You can see that Java code is here. You can see that 𝐒𝐳07 DevOps class codes. Okay. This is a Java code, guys. This is a Java code for building an address book. Like I'm going to build a page like this. Okay. So I will show you the artifact will be built. Okay. But deployment part will not go into, CD part will not go into. We'll mainly focusing on the testing part. So only CI part will focus, not the CD part. So if you want to see CD, then I have to install Docker, or maybe I have to install a Kubernetes server. And then on that, I have to deploy this as a container. I have to create a container, or maybe I can use a virtual machine as well. On that virtual machine, I can install Tomcat, and on that Tomcat, I can go and deploy it. But I will not do that as of now, because our main agenda is testing, not to understand deployment, CI/CD. So we are not into that. So let's see how we do it. Okay. So you can see that right now, this is the code SRC. If you see the folder SRC over there, this is the application code over there. So it's written over there. Can you see these files, Java files? See this Java file. You can see the Java code. Okay, this is the Java code for my application. Okay, you go into the main, or you go into this SRC. You go into the main, and you go into the PMD or whatever. Can you see these all XML files? Okay. All Java files over here. Okay, you can see this tutorial address book, and you will be able to see all the UI Java. You want to see the UI file. Okay, so this is a Java file again. You can see this UI file. Okay, all this is a code a developer has written it. As a DevOps engineer, it's not my job to write it. Okay, we don't have any separate DevOps engineer is not going to write it. Only a developer will go and write it. Okay, so if you don't understand the code, that's fine. No need to worry. We are going to see how we execute this. Okay, how we build it. Okay, this is the raw code. And along with this raw code, test cases are also written. You can see that. Can you see these are test cases? If you go into this Java COM Edureka demo utilities, these all things like exception thrower.java. See, you're testing something. Int I equal to 10 log info plus I. Throw new input output exception. Then you're automating, you're writing test cases. See, these are the test cases that are written. So when you will go and deploy, you will be using MVN to test, Maven for building, Maven for packaging. All these things you're going to use. Okay, so let's see how we do it. Yeah. So this is the code. In the code, this is my source folder. In the SRC, this is the application code, and this is the test cases that I need to execute. Okay, so how to automate this? Simple. Let's go into Jenkins. Let's create a job. Let's create a Jenkins job, a project, a build job. I click on new item. Okay, you can name anything like my Java project. Okay, I can name it anything. I'm going to use a pipeline. I need to show you everything in the pipeline: code checkout, code building, code testing, then code packaging. Okay, so I will be, if I show you the pipeline over here, this is a pipeline look likes over here. You can see that. Okay, just a minute, let me open it up. So this is the pipeline that you can see. So what I'm doing here in this is, let me put it on a notepad. Okay, so this is the pipeline. I can put this pipeline for you guys if you want on the chat. I'm not sure if it will come on the chat or not, or maybe I will upload the file. Just a minute. Yeah, I think it's coming up. So you can copy it from there as well. You can copy that pipeline as well. Okay, so that is what my Jenkins is going to deploy. My Jenkins is going to run. So see what I'm doing over here. See, first stage is a checkout stage where I'm just doing a git checkout. I'm copying my code. Okay, now after that, do a copy of the code. I do a git checkout. After that, I do a compiling. So for compiling, what tool in Jenkins I'm using? I'm using Maven, MVN as a build tool. MVN compile. Compile my code, because once compiling is done, then only you can test it. Raw code cannot be tested. A compiled code are only tested. Nobody can test a raw code. Okay, once compiling is done, compiling means once you get the compiled code, okay, which is in the form of which your computer system can understand, that code you will go and test. So for testing, I'm running a command, Maven test, MVN test. That's it. So MVN is basically Maven. Maven is installed on Jenkins. If you want to check, I can show you that as well. Like I go onto my browser and I show you here which Maven. See, Maven, or maybe I can do here MVN -- version. I think it is not copied there. So you can see, yeah, it's there. Maven. Can you see the version of Maven that I'm using? So it's in OPT Maven. It's not in this. So MVN -- version. See, Maven is there on my system. Okay. And I'm going to use this Maven as a build tool for deploying, for building my application, for testing my application. So as a next step, I'm just going to do an MVN compile. After the MVN compile, I'm doing an MVN test. Now, once all the test cases are passed, then it will go and create a package. The file that is ready to be deployed. This is, guys, my CI. This is what my CI pipeline is. Okay, CD comes after this. Now, where you need to deploy on a VM, on a container. So I will extend this pipeline. I will extend the more stages, but we are not going to do the CD part as of now. We'll just keep it ourselves restricted to CI. For CD, basically, we cover all these things in our training program, in our DevOps training program, CI, CD, Terraform, Ansible, all those things we cover. Okay, but yes, let's see how we do it up. So let's create this pipeline. Okay, so let's open this. Right now, what I'm going to do is copy this over here. From here to here, I copy this completely. Control C. And I go back to my Jenkins. And I create my Java project. It's a pipeline project. I click OK. Once you click OK, a project is created. See, it takes me to the next page. Now in this, I don't need to do anything over here. I just need to put my script. It's a Groovy script. So I just have to put it up here. That's it. Okay. I have to give my pipeline. Okay. And I'm just giving all the stages: git checkout, MVN compile, okay, MVN testing, and then MVN packaging. All these things I'm giving. Okay. Finally, apply this and save this. Okay. So right now, my job is ready. You can see my job on the backend. CD, if I do var lib Jenkins, this is the data path for Jenkins. PWD, I'm in var lib Jenkins. CD to workspaces. Okay, ls-al. Okay, right now, nothing is created inside this workspace. When I will go and execute, right now, see, nothing is there. ls-al. And what's my PWD? So right now, nothing is there. let's go and execute a job. Let's go and execute my build job. Let's do that. Okay, so how to do that is just you have to run this. You have to execute this. So click on build now. So once you're building it, you will see different stages coming up. The first job started, git checkout is happening over there. Now it is doing a compile. Okay, compiling. Now it is testing the thing. Okay, test cases are getting run up here. Okay, now testing is happening. After test cases, it will go and package it up. It will building it up. It's building, it's creating the package, the final package. And it's successful. See, this is green. This is green. Okay, so this is what DevOps is all about. Automating the thing. It's taking the code, compiling the code, testing the code, and then building. On the back end, you see here, earlier this was empty. Okay, now you see ls-al. Can you see this my Java project created? Because you ran the first job. You created the job, that's why it created the folder here. cd to my Java project, ls-l. Can you see the complete source code over there? See, all these files are present on GitHub as well. See this GitHub. See, src docker file I'm not using Docker over there. Docker is mainly used for deploying it. Okay. Readme, address book, build.properties, build.xml, pom.xml. So 1, 2, 3, 4, 5, 6, 7, 8. 8 files are present. See these 8 files. Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think one more is created right now. Yeah, this one, this address book.yaml. Let me see that. It was there. 1, 2, 3, 4, 5, 6. Oh, 9 are there. 1, 2, 3, 4, 5, 6, 7, 8, 9 files. 9 direct there. And you can see exactly same over there. So my code is checked in. It has been checked out over there. Apart from that, can you see a target folder as well? From where does this target folder comes up? Whenever you compile Java, okay, Java code, you compiled Java code, it created the target folder. cd to target. Maven created this because Maven did the compilation. ls-al. Can you see this final output? Can you see this classes? You go to cd classes, ls-al. Can you see this cd to com? Basically, let's go to com, ls-al. No, I think it's cd to edureka demo. Where's the class file? No, I think it's not here. I think, let me just go back, ls-al, cd to address book, ls-al, where I think it should be, the classes file should be inside this only. Yeah, let's see that classes file, cd to classes, sorry, cd ... to classes, com edureka demo, and let's go into the helper. Yeah, can you see these class files actually? See this ls-al. Can you see these class files? What these class files are? So whenever you have the code, you have the Java code with you. Okay, whenever you compile the Java code, after compilation, you will be getting a class file in the backend for that code. See the class file. This file was not present in my code. You want to see the code, actual code? Let me show you that on the GitHub. Okay, let's go back on the GitHub. I go on the src, I go on the main. Okay, I go here, I go into the helper. See, it was a Java file, .java. It was a .java file. Source code was .java. When you compiled, in the end, the compiled output is .class. So now compilation is done. After the compilation, you will do all the test cases. Once the test case is passed, you are going to package it. And this is what your final package is, the one in the red, address book.wall. Now you can deploy this on Tomcat. You can create a server, you can create a CD pipeline. On that, you can deploy a server. On that server, you install Tomcat. On Tomcat, you go and copy this and execute this. That's it. That will be a part of CD. My job is not to go with CD as of now. I'm going to show you CI, and this is CI. Can you see this file, this WAR file? WAR stands for Web Archive. Web Archive. That is what It is, okay, web archive. That is what your WAR file is. So this is your final output. This is the final deployable artifact. You want to check the logs? Let's see the logs as well. Okay. I will give you the logs. Okay. Okay. Let's see the logs over there. Let's go to my Jenkins and click on this number 1 job. Okay. You want to see the console output? See the console output. Okay. So on the console output, it first running the job in valib Jenkins workspace my Java project. Okay, that's fine. Okay, now you see it did a git config, git all these things it did. Now after that, Maven compile, it's compiling the things. So when it started compiling, it called the Maven. Okay, to compile it, it created inside the target, it created the classes folder. See this folder. Okay, inside this folder, it created address book UI. .java will be compiled to Java, will be compiled to .class files. It will start creating all the class files for the tools. Okay, once the build was success, then it tested all the class files. It's doing the testing right now. See this testing, test cases, running the test loggers and all these things. Okay, so after testing, once the build is success, then it go to the packaging. And in the end, you will get your final package. See, if you scroll down over here, build success building WAR file in this. See this. Valib Jenkins workspace my Java project target address book.war. See this. Can you see the file on the back end? Yes. See, what's my PWD? Sorry, let me go back over there. CD valib Jenkins workspaces my Java project target my Java project and then target ls-al. See my PWD. Inside this you have this file valib Jenkins workspace my Java project target, and that is what my log says. Valib Jenkins workspace my Java project target. Inside that you have the final file. This file you have to go and deploy now using a CD pipeline. So CI pipeline we have seen, but this is how we test, this is how we integrate this.
Moving on to our next question, how does continuous testing benefit the software development process in DevOps? And the options are A, it delays testing until after deployment. B, it identifies bugs early by integrating testing throughout the development pipeline. C, it eliminates the need for manual testing. Or D, it reduces the number of code commits. If you know the correct answer, please comment down below.
What is Prometheus? Prometheus is a free software application used for event monitoring and alerting. Now, what it really does is it records real-time metrics. We'll talk about metrics later on in the session. Now, this metrics that it records is stored in a time series database built using a HTTP pull model. And with this, you also have flexible queries and real-time alerting. Prometheus basically pulls these metrics, which are in a key value format, and stores the data as time series, allowing users to query data and alert in a real-time fashion. At given intervals, Prometheus will hit targets to collect metrics, aggregate data, show data, or even alert if some thresholds are met, in spite of not having the most beautiful graphical user interface. Now that we know that Prometheus is basically an alert monitoring system, now let's move on and understand why we need Prometheus. As I've already mentioned in the introduction, it basically contributes to the DevOps system by monitoring cloud-native applications and infrastructure, and also by watching over hundreds of microservices. Now, it really works well for recording any purely numeric time series data. Now, another really important benefit of Prometheus is that it fits both machine-centric monitoring as well as monitoring of highly dynamic service-oriented architectures. This is a real advantage. Now, in a world full of microservices, its support for multi-dimensional data collection and querying is a particular strength. Now, another advantage of Prometheus is that it is designed for reliability. To be the system you go to during an outage to allow you to quickly diagnose problems. Now, each Prometheus server is standalone. Not depending on network storage or other remote services, you can easily rely on it when other parts of your infrastructure are broken, and you do not really need to set up an extensive infrastructure to use it. Now you must be wondering why Prometheus really, because there are other time series databases that can be used too, right? So one of the noticeable differences between Prometheus monitoring and other time series databases is that it is a pull-based tool, unlike Nagios, Sensui, etc. Now, because it is a pull-based tool, what it really does is it actively scrapes targets in order to retrieve metrics for them. For example, the node exporters or application exporters. So Prometheus expects to retrieve metrics via HTTP calls done to certain endpoints that are defined in Prometheus configuration. Node exporter and application exporters will listen on particular ports, and Prometheus server initiates a HTTP call to this particular exporter and fetch system or application metrics from the end. Now that we know why Prometheus is so important, let's move on and understand continuous monitoring in Prometheus. Monitoring applications and application servers is an important part of today's DevOps culture and process. Now, via continuous monitoring, you obviously want to continuously monitor your applications and servers for application exceptions, server CPU, memory usage, or storage spikes. And you also want to get some type of notification if the CPU or memory usage goes up for a certain period of time, or a service of your application randomly stops responding, so that you can perform appropriate actions against those failures or exceptions. This is why Prometheus is used in continuous monitoring. Now, with monitoring, the number of tools out there such as Amazon CloudWatch, Nagios, New Relic, and many others. But Prometheus is a very popular free and open source project for monitoring dozens of servers, as I've already mentioned, even microservices. Now that we know what is Prometheus used for in continuous monitoring, let's move on and check out the Prometheus architecture. So in Prometheus terms, we call the main monitoring service the Prometheus server. You can see that on the screen. And the things that Prometheus monitors are called targets. So the server is the monitoring service, and the targets is what the Prometheus monitors. So I hope that is clear. So in short, the Prometheus server monitors targets. I said earlier, targets can also refer to an array of things. It could be a single server or a target for probing of endpoints over HTTP, HTTPS, DNS, TCP, or it could simply be a HTTP endpoint that an application exposes, through which the Prometheus server gets the application's health status from. So now let me explain a little bit about metric. Each unit of target, such as current CPU status, memory usage, or any other specific unit that you would like to monitor, is called a metric. So Prometheus server collects metrics from targets over HTTP, stores them locally or remotely, and then displays them back in the Prometheus server. Now the Prometheus server scrapes targets at an interval that you define to collect metrics from specific targets. For example, for a minute or 30 seconds or whatever you want, you can give the target as, and then it will finally store it in a time series database. You can see the storage box that is in between. That is your time series database. Now you define the targets to be scraped and the time interval for scraping metrics in the Prometheus.yml configuration file. You get the metrics details by querying from the Prometheus time series database, where the Prometheus stores metrics, and you use a query language called PromQL in the Prometheus server to query metrics about the targets. So in other words, you ask the Prometheus server via PromQL to show us the status of a particular target at one particular time. As you can see in the third white box, it accepts queries, that is, it accepts PromQL queries. Now Prometheus provides client libraries in a number of languages that you can use to provide health status of your application. But Prometheus is not really only about application monitoring. You can use something called exporters to monitor third-party systems. Now, exporter is a piece of software that gets existing metrics from a third-party system and eventually export them to metric format that the Prometheus server can eventually understand. Now, a sample metric from a Prometheus server could be the current usage of free memory or file system free via a node exporter in the Prometheus server. We learn all of this in the demo part of this session. Now, I hope Prometheus server is clear to you. So the main component here is the Prometheus server, which is divided into three parts: the retrieval part, the storage part, and the HTTP server. So the HTTP server really accepts queries and displays it in the graphical user interface. Also, we'll be learning about Alert Manager later on in this session. So I hope all of these are clear. Let's move on to the next part of this session and learn about Prometheus metrics and its types. So here, each unit of a target, such as the current CPU status, memory usage, or any other specific unit that you would like to monitor, is simply called the metric. So the server collects the metrics and stores them either locally or remotely, and then eventually displays it on the Prometheus graphical user interface. Now, moving on, let us check out the 4 different types of metrics that are available. The first one that we'll be talking about is the counters. A counter is simply a cumulative metric that represents a single monotonically increasing counter whose value can only increase or be reset to 0 on restart. Now, for example, you can use a counter to represent the number of requests served, tasks completed, or errors. You always have to remember this, to not use a counter to expose a value that can decrease. Now, for example, do not use a counter for the number of currently running processes. Instead, use a gauge. We'll be talking about gauges in a bit. Now, client library usage documentation for counters are Go, Java, Python, and Ruby. Let's move on and understand the next metric type, that is gauges. I'm sure you must be aware of gauge. Now, a gauge is a metric that represents a single numerical value that can arbitrarily go up and down. Gauges are typically used for measured values like temperatures or current memory usage. If you check out a speedometer in a car, it looks like a gauge, right? That is a gauge. That's exactly what we're talking about here. So the client library usage documentation for gauges are Go, Java, Python, and Ruby. The next metric type is the histogram. Now, a histogram samples observations and counts them in configurable buckets. It also provides a sum of all observed values. A histogram with a base metric name of base name exposes multiple time series during a scrape. Now, when you're operating on buckets, remember that histogram is cumulative. Now, moving on to the next metric, we have summary, which is very similar to histogram. A summary samples observations, while it also provides a total count of observations and a sum of all observed values. It really calculates configurable quantiles over a sliding time window. Now, a summary with a base metric name of base name exposes multiple time series during a scrape. Now, the difference between summary and histogram is that here you do not know what the range of values will be upfront, so you cannot use histograms. Whereas in histogram, you know what the range of values will be upfront, so you can just define it on your own. Now, with this, let's move on to the demo part of this session and install Prometheus on our Linux virtual machine. So I'm just going to check out my Ubuntu machine number. So the first thing what we're going to do is we're going to install Prometheus from the official website. So I'm going to go to my web browser. So I'm just going to type in Prometheus in my web browser and I'm going to click the first link. And as you can see, this is the official website of Prometheus. I'm going to click on the download button. So once I click on the download button, it will redirect me to a page. So as you can see here, there are a lot of products: Prometheus, Alert Manager, Black Box Exporter, and a lot more if you keep scrolling down. Right now, we're going to be downloading Prometheus. So we're just going to stay here and I'm just going to click on the operating system as Linux. And this will just show the tar file for the Linux operating system. I'm just going to right click on that and I'm going to click on copy link location. And I'm going to switch back to my terminal and click on wget. And this will download Prometheus for me in my Linux operating system. Now that it's downloaded, I just want to see the list of files in my tar file. So as you can see, there's the Prometheus Linux tar file, which is present currently in my Prometheus folder. Now what I'm going to do is I'm going to copy this file and then untar it using the command tar -xvf. And then I'm just going to paste this file. This will immediately untar the file for me. Once that is done, now I'm just going to list down the number of files that are currently present in my Prometheus file. Now you can see that there's an file which has been untarred here. Clear my screen. Okay, now I'm again going to just list it so you can see it clearly. Now I'm just going to copy this file and enter this directory. So I'm just going to list down all the files that are present. You can see there's console libraries, there's consoles, license notice. There's a file that's named Prometheus. So this is the application, the Prometheus application. So I've already mentioned before that the Prometheus.yml configuration file really just defines the targets that has to be scraped, right? And also the time interval for scraping metrics. Now let's just check if all of those parameters that I just mentioned are there in the configuration file. So I'm just going to use scat command for it. You can see that there's a scrape interval parameter of 15 seconds. You can set the scrape interval to every 15 seconds. Default is every 1 minute. So I also have an alert manager configuration. Right now, we haven't set that up, but it's just there. You can also load your own rules and evaluate them according to the global evaluation interval. And you can see by default, it is currently active on the 9090 port. Okay. And by default, a scrap configuration containing exactly one endpoint to scrape is given. That is the Prometheus itself, right? As I've already mentioned before, Prometheus is a tool or an application that will scrape out metrics from different applications. But by default, right now, we have the Prometheus itself to be scraped. And that is currently present on the port number 9090. So I hope that is clear. We will learn about the rules in the next part of the session. We'll also learn about the alert manager configuration in the later part of the session. So both of these will be clear later. But I hope the scrap interval and the scrap configs are clear to you. Now let's move on to the next part. Now I'm just going to clear the screen. Now I'm just going to execute Prometheus by using /Prometheus, and this will immediately activate and get my Prometheus application running. If we move back to my web browser and just type in localhost 9090, this will redirect me to my Prometheus application, as you can see. Now, if I come out of my terminal, right? Okay, and I reload my page, you can see that it is unable to connect to my Prometheus. So what I'll have to do is I will have to create a Prometheus service and get that running. So let's learn how to do that. I'm just going to clear my screen. So now to be able to run Prometheus as a service, I'm going to use the copy command. I'm just going to use the cp-r command. I'm just going to copy all of these files that are consisting in this folder to the destination folder. And I'm going to use this command -user local -bin Prometheus. Now, for any application to be run as service, you will have to compulsorily have a .service file. So let's go ahead and create one. So to create the service file, I'm just going to use the command sudo vi, and I'm going to enter that particular folder. So as you can see, I just typed out a tiny piece of code. And as you can see here, this is my executable command and this is my configuration file. Let's go ahead and save this. Okay, great. So now that our service file has been created, I'm just going to clear my screen, and now we're just going to start our service file. Now, once that is done, I'm just going to check the status of Prometheus. It is active and running. Great. Now, if I want to stop Prometheus, I'm just going to type in the command sudo service Prometheus stop. Okay. Now that I refresh my page, you can see that Prometheus is up and running. So that's great. I hope it's clear how to create your own service file so you can get Prometheus up and running. I hope it was very clear, and I hope you understood how to install Prometheus into your virtual machine. Now, in the next part of the demo, I'm just going to brief you all about the graphical user interface of Prometheus, so stay tuned. Okay, so now we're going to check out the user interface of Prometheus. So in the previous session, we installed Prometheus and we got the instance running. Now, if I click on Prometheus, this is where it will take me. Now you can see that there are three options that says enable queue history, use local time, enable autocomplete. You can use the local time if you'd like to enter some time to evaluate the queries. So there's a search bar here for you to type in the expression that you'd like to execute. Now the expression or query that you'd like to execute is usually executed in two different forms, that is the table form and the graph form. As of now, since you don't have any expression and query, it says no data queried yet. Now on the top, you can see three options that says enable query history, use local time, enable autocomplete. So this option will allow you to use your local time. Since I'm in India and it's 10:08 right now, so that's my local time. Now, if I want to also enable my query history, that is all the queries that I have executed in the past. So this option will simply enable me to check out the queries that I've executed in the past. So I'm just going to untick that because I don't have any queries that I've executed in the past anyway. Another interesting thing in this page is that you can add several panels, right? So you can execute different queries all at once. This is great. And this option add panel has been added in the recent times. So this is the new user interface. You also have a classic user interface. I'll shift to that. And you can see that here you can enable query history. That's the only option that's common from the new user interface. Also, you have a bar that will allow you to type in your expression or query. You can also insert metric at cursor. Now, since Prometheus is written in Golang, so you have a lot of metrics that are related to that. You also have metrics related to Prometheus. Now, if I want to execute any of these metrics, I can just click that and I can execute it. You can see that the instance localhost of port 9090 is currently up and running and the job is Prometheus. I can view the graph too if I'd like to. Now let's just execute another query. I'm just going to click Go Info and this will just give me the version of the Golang and the job, etc. So you can just really execute all the queries directly from this option in your classic UI. But as you can see in the new user interface, that option is unavailable. Now let's move on and check out the other options that are available in this panel. Let's click on alerts. Currently, we have no alerts. As I've already mentioned before, that alerts are simply conditions that you will have to specify. And if these conditions are satisfied, so the alert will be triggered to that particular maintainer or manager. So currently, as we have none, it just shows nothing here. So these options will allow me to check my inactive alerts, my pending alerts, my firing alerts. So usually it's in inactive state if the condition is not satisfied. If the condition has been satisfied, then it'll go to the pending stage. And finally, if it exceeds the critical limit or the critical amount, it will enter the firing stage. So you can view the alerts based on these three states, that is the inactive state, pending state, and firing state. Moving on, we have graph. So this is the same as the homepage of Prometheus, right? So we've talked about that. So once I click the status option, you can see that there are 7 different options that drop down. The first one is runtime and build information. This just really gives me, the information about Prometheus. That is the start time of Prometheus, the working directory, the configuration reload. Extra information about my runtime and build is given in this option. Now the alert managers, there are none, so it just says endpoint. Now you can also see the Go version here. You can see the build user, build date, all of that. The version of the build information also is given here. So this is what the runtime and build information is all about. The next option in the status is TSDB status. What is TSDB? TSDB is simply the time series database. So this option allows me to check out my database's status, right? The number of series, the number of chunks. So I can just view the statistics of the head cardinality. So I can just view the top 10 label names with value count. I can view the series count by metric names. And I can also check out the label names with high memory usage. In fact, I can also, take the queries from this top 10 series count by metric names. I can just execute it as a query. And you can see that this gives me the data of all and this just executes the information and gives me the data, the list of data that allows me to check out my HTTP request duration in seconds. So also I can view this in graph. So I'm just going to click on that. And this just gives me information of all of the data that is available in the table in terms of graph. So I hope this is clear. Now moving on, we'll check out command line flags. This is just the command line flags that I can use to really make changes in my service file. We created a service file, right, to run this particular service of Prometheus. So this just really gives all the information about my service file. So you can see that there's config file currently in this location. There is also query timeout, and you can view all of that, all of the extra information here. You can check out the web listen address. It's in port number 9090. You can also check out the web page title. Currently, the web page title is Prometheus Time Series Collection and Processing Server. You can change this if you'd like to. You could also check out the web read timeout. So all the information basically about this service that we've created is given in the command line flags. So moving on, we will check out a configuration file. This configuration file we've already seen before, right? This is our prometheus.yml file, right? So this is simply the same file that is given here. You can see global, alerting, scrap configs. You can check out the targets and then finally the port number. Okay, so if you'd like to copy this, you could just copy to clipboard. Moving on to the next option, we have rules. There's none right now, so it shows nothing. Later on in the session, we'll be creating our rules, so stay tuned for that. Now, the next option is targets. There's only one Prometheus service that is up and running, and that is of port number 9090. So the state is up. You can see the instance, you can see the job, and the last scrape, the scrape duration, and if there are any errors that will appear here. Before we move on to the next option, so I'm just going to show you the metrics of this instance, the Prometheus instance that we're running. I'm just going to click on metrics. Now you can see that Prometheus defines a very nice text-based format for its metrics. I'll just zoom this a bit so you can view it better. So now you can see that the data is relatively, human readable. And we even have the help and type decorators to really increase the readability, right? As I've already discussed before, Prometheus has only 4 types of metrics, right? To keep everything really simple. That is counter, gauge, histogram, summary. Now the type and help attributes here help us provide user-friendly hints for each metric in the output. So that's what this help and type decorators really do. They just increase readability. You can't really view all of these metrics and understand what they are. So they're just helping you with the readability. You can see that the help here says Go GC duration seconds, a summary of the pause duration of garbage collection cycles, and the metric type is summary. Here you can see the type is gauge, and you can see all of that information. Here the type is counter. Also here the type is counter, gauge again. So that's what really the type will do. So the type will just give you an insight of what type of metric it is. So help will just really describe the metric, and type will just give you the type of metric. So I hope this is clear. So I hope metrics was easy to understand. Now that we finished targets, let's move on to service discovery. And this just shows you, so currently there's just one endpoint that has been scraped, and that is our current running active instance, that is Prometheus. Now it just shows the address, the metrics path, and the scheme, the job, and just shows some labels of the target. So that's all service discovery is all about. And if you'd like to check out and know more about Prometheus, just click the help option in the panel, and this will redirect you to the Prometheus official website. Now the classic UI we already discussed, and this is all for the graphical user interface of Prometheus. I hope it was easy to understand. I hope it was easy to learn. Now let's move on to the next part of the session. Okay, so now in this part of this session, I'll be downloading the Prometheus node exporter. So for all of y'all who don't know what the node exporter is, it really is a way to measure various machine resources. Now the machine resource can be your memory, disk, or even your CPU utilization. So it's a very famous application of Prometheus. So without much ado, let's go ahead and download our node exporter. I will go to my web browser and I'm going to the official website of Prometheus. So the first link will redirect me to the official website of Prometheus. I'm going to click on the download button and I'm going to scroll down and look for node exporter. So I'm just going to copy the link location. I'm quickly going to move back to my terminal and I'm going to download Node Exporter. So now that the Node Exporter has been downloaded, now let's just check if the file is available, and it is. So I'm just going to untar this tarred file with the command tar xzf, and I'm just going to copy this. And this command will just untar my file. Okay, so I'm just going to clear the screen. Now let's just move ahead and check out what are the files that are there in our Node Exporter file. So we have license, Node Exporter, and notice. Now what I'm going to do is I'm going to use the sudo cp command. So I'm going to copy the Node Exporter file to my user local bin location. So with the help of the copy command, that is the cp command, I'm just going to create a copy of the Node Exporter file into my user local bin location. Okay. Once that is done, I'm just going to check out the files that are present in my user local bin location. You can see that there is a Node Exporter file that has been copied, right? So I've just copied this file into this location. That's all I've done. Moving on, we'll now create a service file. So we created a service file for a Prometheus application, right? So even for the Node Exporter, I'm going to create a service file using the command sudo vi. So I'm just going to name this as node exporter.service. So I have written down a piece of script the same way we did to a Prometheus service file. Here you can see the description, which says Prometheus node exporter service. You also have the type, you have execution start, which is currently present in the user local bin location. Now, once that is done, I'm just going to save this and I'm going to reload my system. Now I'm just going to start the service. You'll have to make sure of one thing, and that is the node exporter. So what you're naming the service file, you'll have to initiate the same name. So as you can see here, the service file is named as node exporter. So I'm just going to type the same thing here and I will start the service. Once I start the service, I'm just going to check its status and you can see that it's active and running. So that's great. So the node exporter is currently running on address 9100 ports. So we're just going to check it out. And it opens. So you can check out the metrics that are currently running in our node exporters. So this is the endpoint as to where our Prometheus will scrape all of its data. So now that we have node exporter up and running, let us configure the node exporter into our prometheus.yml file. So every time you'll have to configure a particular target, you will have to go to the prometheus.yml file and add the target there. Okay. So what I'm going to do is I'm going to move to my directory. Okay, once that is done, I'm just going to list out all the files. So you have the Prometheus file here. Here you can see the prometheus.yml file, right? I'm just going to clear my screen. So now I'm just going to view all the files that are present in Prometheus. As you can see that there's the YML file here. So we're going to use the command sudo vi prometheus.yml to edit our configuration file. So now you can see there is only currently one job, and that is Prometheus. We have to add another job to our file. So here I'm adding node exporter as my job name, and the target is with IP address 9100, right? So make sure the indentation is correct. So once the indentation is correct, we have applied a target. We have added a target to our configuration file, and we can just save this. Once that is done, I'm just going to clear my screen. So now I'm going to restart my Prometheus and check the status. It's active and it's running. So we can just go back to our page. So you can see here the node exporter has been added to our service discovery with address as localhost 9100. It's localhost because we are currently working on our machine. If you want to add another machine's port address, you can do that too in Prometheus by mentioning their address. And now you can just go back and you can check out the configuration file has its changes. So it has another target that's named node exporter, and also its port number is 9100. So if I move back to my classic UI2, I can check out the metrics that are here. If you notice, there are a lot more metrics than before, right? You also have the node metrics. If I want to check out the node CPU seconds in total, I can execute it, right? So now that I've executed it, you can check out the CPU's total number of seconds it is hosting the node exporter for. You can also check out the username info of the node. You can see that the instance name is given here, the machine that we're currently working on, the node name is Edureka, the system name is Linux, the version is given here, and also, so the entire node's username info is given if we execute this query. So this is great, right? Like, now your node exporter has been successfully configured into Prometheus. Let's move on to the next part of the session. Before moving on to the next part of the session and configuring Alert Manager, let's understand querying a little bit more in detail. So Prometheus, as we all know, fundamentally stores all of its data as time series, right? Now, each time series is identified by a metric name. We've also discussed this before, and as well as a set of key value pairs that Prometheus calls labels. Okay. Now, the metric name indicates the overall aspect of a system that has been measured. Let me just execute this query, Prometheus HTTP request, duration seconds total. Okay. Now you can see that labels serve to differentiate subdimensions of a metric, such as, the handler, the code, the instance, the job that it's currently running on. Finally, a sequence of samples forms the actual data for a series. Okay. Each sample consists of a timestamp and a value, where timestamps have millisecond precision, and here values are always 64-bit floating point values. The best part of Prometheus queries is that you can add regular expressions, you can specify a time limit, a certain time limit. You can also use different functions. We'll see all of this. So now I could add a certain filter to my query. Now, if I want to just execute the queries with label code 400, I'm just going to add that filter here and execute the query. And this will automatically display the HTTP requests in total with code 400. And you can really, add whatever you'd like to in your filters. So that is one way to work with queries. And also, as I've already mentioned, you can also add regular expressions, right? So you can use not equal to, is equal to, and many other things. So for example, if you want to list all the series, no matter which metric name or job, with the handler name starts with API, okay? So you can just simply run this query. What we've done in this regular expression is, so this is obviously a regular expression, right? So in this regular expression, it needs to end with a full stop and a star. Okay, since regular expressions always match a full string in Prometheus. Now, the resulting time series is usually a mix of series with different metric names. Now you know that how to select your time series by the metric names as well as a combination of their label names. So in the next part, we will learn how to calculate rates or deltas of a metric over time. Now, one of the most prominent frequent functions you will use in Prometheus is the rate function. Now, instead of calculating event rates directly in the instrumented service in Prometheus, it is a very common thing or a common way to track events using raw counters, okay? And to let Prometheus server calculate rates ad hoc during query time. This has a number of advantages, such as not losing rate spikes between scrapes, as well as being able to choose dynamic averaging windows at query time. Counters start at 0 when a monitored service starts and get continuously incremented over the service process's lifetime. Occasionally, when a monitored process restarts, its counters reset to 0 and begin climbing again from there. Graphicking raw counters is usually not very useful, as you will only see an over increasing line with occasional resets. Now we will just use another query for this example. Now I'll just explain you how the rate function really works. And for this, I'm just going to use the query Prometheus HTTP request duration seconds count. Okay. And I'm just going to specify the job as Prometheus. And you can also view the graphs. It looks something like this. Okay, now to make counters useful, we can use the rate function to calculate their per second rate of increase. This is really why we use rate function. We need to tell rate function over which time window to average the rate by providing a range selector after the series matcher. Okay. Now, for example, to compute the per second increase of the above counter metric as averaged over the last 5 minutes, we can just add the rate function and just specify the time limit as 5 minutes. I'm just going to close the braces and execute the function. Okay. You can check out the graph now. You can see now the result is much more useful, right? Rate function is very smart and automatically adjusts for counter resets by assuming that any decrease in a counter value is a reset. The variant of rate function is irate function, while rate function averages the rate over all samples in the given time window, that is 5 minutes in this case. Irate function only ever looks back 2 samples into the past. Okay, it still requires you to specify a time window like 5 minutes to know how far to maximally look back in time for those 2 samples. Now, irate function will really react faster to rate changes and is thus usually recommended for use in graphs. In contrast, the rate function will provide smoother rates and is recommended for use in alerting expressions. Okay, now let's execute the irate function for this. You can see that the graph would look like this, okay, uncovering short intermittent dips in the request rates. Rate and irate functions always calculate a per second rate. So here sometimes you'll want to know the total amount by which a counter increased over a window of time, but still correct for counter resets. You can achieve this with the increase function, okay? For example, to calculate the total number of requests handled in the last hour, you can use the increase function. And I will change this to 1 hour. Now that we know how queries work, how you can use regular expressions, and how you can really use functions in your queries, let's move on to the next part of this session, that is custom roles. Okay, so time series queries can quickly become quite complicated to remember and type using the expression browser all the time, right? So what you can do is, sometimes in some situations you'd want to use some queries very frequently, right? But you don't want to really type the same query over and over again. So in this case, rather than remembering and typing this particular query every time, we can create a recording rule that will run at a chosen interval and make the data available as a time series. So how are we going to do it? I'm just going to, so this is a pretty popular query that I'm going to execute. That is node memory 3 bytes. Okay. I'm just going to execute this query. This will just give me how much of free bytes is available in the node exporter. You can see the free number of bytes here. But what if I want to execute this in terms of, percentage? So here you can see the number of memory that the job node exporter is using, and it's just 4. So I'm just multiplying by 100 to check in percentage form. So you can see that it is only using 4 bytes of memory. Now, if I want to see how much of memory is remaining, I'm just going to minus the entire query with 100. So you can see that 95% of bytes is left over. Now, what if I want to execute this query very often, right? So it'd be very time consuming for me to type the whole thing out and then execute it, right? So, but there's an easier way to make this a query, right? So it'll just drop down in your drop down list and then you can just search for it and execute it, right? So how do we do that? So what we're going to do is we're quickly going to shift back to our terminal. I'm just going to clear my screen. Okay. And I'm just going to move into the user local bin Prometheus directory. And now here we have to create a new file called Prometheus rule. So that's what I'm going to do. And since it's a YML file, I'm just going to add the YML extension. Here, I'm just going to add the name as custom rules. And I'm just going to specify my rule here. So I just type the whole thing out. I have named this custom rules and I've recorded this query as node memory free in %, and the expression we've already executed is the same one. I'm just going to go ahead and save this. I'm just going to clear the screen. So Prometheus usually comes with a tool called Prom tool, and this Prom tool can be used to really check your rules files, and you can do really a lot of things with Prom tool. For now, we're just going to use this command which I typed out, and we're going to execute this command to check if our file is running okay. And you can see that it checks the Prometheus rules file and it says it's success. Now let's go ahead and add the Prometheus rules.yml reference to the Prometheus YML rule file section. I'm just going to clear the screen. Now I'm just going to enter the Prometheus.yml file. So here I'm just going to enter the Prometheus_rules.yml file. So now I'm just going to save this file. Now once that is done, I'm just going to restart the system. And I'm just going to check the status too. Okay, great, it's up and running. So we're just going to switch back to Prometheus. And I remember naming it free bytes. I'm just going to switch to the classic GNUI so I can look for it. And it was named node memory free in %, right? This is exactly what we named our query. And I'm just going to execute this. And you can see that it's 95%. So this is how easy it is to make your own queries and execute them. Okay, so now that we've created our, custom rule, so let's just go check out our custom rule. And you can see that it's here. And the state says, okay, so that's great. Now let's go ahead and create our first alert rule. Okay, the same way that we created our custom rule, we're going to be creating our alert rules. This is exactly why I explained you custom rules in the beginning. So I'm just going to switch back to my terminal. I'm going to clear the file. I'm just going to go to the Prometheus_rules.yml file. And once that is done, so I'm just going to type in my alert in this Prometheus_rules.yml file. And once I'm done typing, so I'll just explain you the alert after that. So I've created a rule named alert rules, and this alert will allow you to recognize when your instance is down. So we have currently the Prometheus instance that is running, and we also have the node exporter that's running. So if any of these instances go down for up to 1 minute, and then the alert will be up. Okay. So the severity is pretty critical, and we have given annotations too where we have mentioned the instance. So this just gives a summary of what instance is going down and a description too of the job type. And also we have mentioned the job type and that it has been down for more than 1 minute. Okay. So once this is done, we're just going to save this. I'm going to clear my screen. So the same way that we executed the prom tool command, we're just going to execute that. So we're just going to execute this command. And it says 2 rules found. That's great. Now I'm just going to restart my Prometheus. And I'm going to check the status. Okay, it's up and running. Let's switch back to our Prometheus and reload it. Now you can see that there is now an alert rule, okay, which has the alert instance down, and the expression is up is equal to 0. So this expression that says up is equal to 0 is pretty interesting, because now if I go to my Prometheus and just execute up, it'll just tell me what are the jobs that are currently up and running. Now the value is currently 0. So if the expression turns 0, so then the alert will be activated. So here, this is what the expression really means. So here, if the up is equal to 0 for more than a minute, then the alert will be immediately activated. As I've already mentioned before, the 3 stages, that is the inactive stage, pending stage, and then the firing stage. If none of the alerts are up, then it's just going to be an inactive state. And if, for instance, one of the jobs go down, okay, then it will immediately move to the pending state. So once it immediately moves to the pending stage, then it will wait for a minute, because we have specified the condition that it should be in the pending state for a minute. And if it goes beyond a minute, then it should go to the firing stage. Okay. So once it reaches the firing stage, all of the managers that are involved in getting the notification about this alert, then they will be informed about it immediately. So I really hope you understood how to create your own rules, how to configure them into your Prometheus rules.yml file, and then just really, understand how they really work. Now let's move on and install and configure our alert manager. We'll have to just simply go to the Prometheus official website, click on download, and then you'll get an option called alert manager. I'm just going to click on that. And then I'm just going to copy the link location of Linux, because I've been clearly using Linux machines. So I'm just going to copy that link location, clear my screen, and so I'm just going to download Alert Manager. So once I copy the link location, what I'm going to do first is I'm just going to move back directories. So now I'm just back to my root. I'm just going to move into my Prometheus directory. So I'm just going to download my Alert Manager here. Okay, as you can see that the download is complete, I'm just going to list out the files. And you can see that there's an Alert Manager, the tar Alert Manager file. I'm just going to untar this using the command and you can see that using the command sudo tar -xvf, and then I'm just going to paste the link. And you can see that the files have been untarred. I'm going to clear my screen and I'm just going to list out the files. Yeah, so the Alert Manager file has been untarred. I'm just going to enter into this directory and check out the files that are currently in this. You can see that there's an Alert Manager executable file. You have alert manager.yml, the configuration file. You have an AMP tool. So now what we're going to do is we're going to be running Alert Manager as a service. The same way we ran Prometheus and Node Exporter as a service, we're going to also run Alert Manager as a service. So what I'm going to do first is I'm just going to copy my files into the user local bin. So now I'm just going to create the Alert Manager service file. If you remember, we also created a Prometheus service file and also Node Exporter service file. So we're just going to do the same. We're going to create an Alert Manager service file. So once you create your Alert Manager service file, this is what you'll have to type out. I've typed out the script. So you have a description, you also have the type of the service, and you're just going to mention the location of the configuration file and where the execution will begin from. Okay, once this is done, I'm just going to save this file. I'm going to clear the screen. So I'm just going to shift locations to the user local bin Alert Manager directory. So I'm just going to list out the files, and you can see there's the alert manager.yml file. So here is where we'll have to make a few changes. That is the Alert Manager configuration file. So I'm just going to make some changes there. So this is the default file. I'm just going to make some changes here, and I'm just going to explain what the changes are about. You can see that you have receivers where you have to configure your email ID, that is your email ID from where you're sending the message, and the receiver who's going to receive the message, right? So you're just going to add a to email ID, you're going to add a from email ID, and you're also going to add a username, you're going to add identity, that is the email ID, and then you're also going to add the Gmail password. Now that all of my email IDs are in Gmail, so I'm just going to mention the public Gmail host server. So I'm just going to add in all my credentials and cut to the next part of the session. And as we have already seen before, there's a tool that is called AMP tool in the Alert Manager. So the AMP tool is just an executable that allows you to view or to modify the current state of the Alert Manager. So I'm going to execute this command, user local bin alert manager AMP tool, and check the configuration file, and then just give the location of my service file. Okay, and once that is done, it's going to check. So I'll just check if it's successfully configured. Once that is done, you can just see that there's one receiver on this end. Okay, I'm just going to clear my screen, and I'm going to start my alert manager. So once I've made changes to my service file, so now I'm just going to execute my command, user local bin alert manager AMP tool. Now for all of you all who don't know what AMP tool is an executable that allows you to view or to modify the current state of the alert manager. Okay, so once this is done, this is successful. So you can just check the config file with the help of AMP tool, and once that is successful, you can just see that there's one receiver. So what I'm going to do is I'm just going to clear my screen, and I'm going to start my alert manager service. Now that the alert manager is up and running, you can see that it's currently running on port number 9093. So I'm just going to check out the port where the alert manager is up and running. As you can see that there is 4 different options that are given: alerts, silences, status, help. And you can just filter your alerts, group your alerts, and you can also see the status of your alerts. And you can also see the active, pending, and expired alerts. You can get help from this page too. So you can just see your alert manager in general. And now now with the alert manager active, let's move on to the demo part. Okay, so now that we have set up our alert manager, so we'll quickly shift back to our terminal, and I'll clear my screen. So now we have to configure alert manager into Prometheus. I'm just going to move out from this directory, and I'm just going to enter the Prometheus directory. I'm just going to list out the files that are present here. So I'm just going to edit my prometheus.yml file. And here, as you can see, I'm going to specify my alert manager. So I'm just going to specify my alert manager to port number 9093. And once I'm done with that, I'm just going to save this file. And now I'm going to restart Prometheus. Okay, it's up and running. So I'm just going to check if my endpoint has been successfully scraped in my runtime and build information. And if I scroll down, you can see that, so the alert manager has an endpoint, right? And this is it. So that's great. We have Prometheus, we have alert manager up and running. Now let's just go check the status of all our targets. We have Node Exporter, which is up. We have Prometheus, which is up. Okay, now let's go to our alert stage. We have one alert rule that we've currently written, and it's inactive. Now let's get into the demo part, and let's just stop one of the instances. I think I'm going to stop my Node Exporter instance, and once that starts, so let's just see how the alerts go by when one of the instance is shut down. Okay. So I'm just opening a new terminal, and what I'm going to do here is I'm just going to Okay, now what I did is I just entered my Prometheus directory. I just listed down the files, and we have the node exporter file. I just changed the directory to the node exporter and listed down the files. And currently the node exporter is up and running, obviously. But now what I'm going to do here is I'm just going to stop this service. Okay, before that, I'll just clear my screen, and I'm just going to stop the service. And I'm just going to check the status. So it's inactive. And once that is done, I'm just going to quickly shift to my status of the target. So you can see that one of the target is down, and I'll just execute the up query, and you can see that the node exporter has the value 0. That is, it's down. Okay. I'm just going to check the alerts. You can see that the alerts is in the pending state, right? There's 0 in inactive and there's just 1 in pending. So it's just going to be in the pending state for a minute. If you remember, we had specified that for a minute, it's going to wait if the instance is going to be down. So once it crosses the 1 minute threshold, it's going to go to the firing stage. Here, it's going to alert the manager. That is me currently. I will receive the mail saying that one of the instance is down, and it's a critical alert that you will have to address immediately. Okay. So that's how it really works. Now let's reload the page. And you can see that after a minute, it's entered the firing state. Okay. And there are none in pending state. So it was in pending state for a minute, and then it moved to the firing state. So in the previous session, we learned about how to create our own alerts in Prometheus and how to be notified about these alerts so that we can take discrete actions whenever necessary. So in the next part of the session, I'm just going to integrate Prometheus with one of the most famous visualization tools in DevOps, that is Grafana. So before I explain you about Grafana, I'm just going to briefly explain you about Node Exporter and how we're going to be displaying its metrics in Grafana. So Node Exporter is simply an exporter that collects technical information from Linux nodes, right? Such as CPU, disk, memory statistics. I'm sure you must be aware of this by now. So the metrics that the node exporter exposes of the Linux machine that we're currently working on, that is Ubuntu, all of these metrics are going to be visually represented in Grafana. We know that Prometheus doesn't have like a great UI, right? All of the information is very textual and it's not very like visually appealing. So with the help of Grafana, I just really want to, expose all of these metrics in a graphical representation like gauges or, bar graphs, anything. It could be anything. So before we download Grafana onto our Linux machine, I am quickly going to be making some changes in the YML file. Before that, I'm just going to check if my Prometheus is up and running. It is. And I'm also going to check if my node exporter is up and running. It is. So that's great. I'm just going to clear my screen. Okay, so now that is done. So I'm just going to list down the files that are currently in the Prometheus directory, and I'm just going to shift to my Prometheus file. So I'm just going to move into this directory. Going to list the files. Okay, great. So we're just going to make some changes in the prometheus.yml file. I'm just going to. Okay. Now you can see that you have our alert manager configuration, our rule files, scrape configs, a job name. But here in the static config, so I'm just going to add the node exporter as a target too. I'm just going to add the IP address of, currently it's running on localhost 9100. Okay, great. Just going to save this. And I'm going to restart Prometheus. Okay, it's up and running. I'm just going to clear the screen. Okay, great. Just going to go down. So now I'm just going to go back to my Prometheus directory. And now let's go ahead and download Grafana. I will click on my web browser and I'll just go to the official website of Grafana. So this is the official website of Grafana. I'm just going to click on the download button. So on this page, you can just click download. And then if you scroll down, you can see Linux. So these are some of the commands that you can use to download Grafana on your Linux machine. So I've already made a list of all of these. So I'm just going to use them to download Grafana. And okay, now that Grafana has been installed, I'm just going to clear my screen. And I'm just going to check if it's up and running. So I'm just going to use this command to start the Grafana server, and then I will check the status of it. And it's up and running. Currently, it's running on port 3000. I'm just going to quickly shift to my web browser and check. As you can see that Grafana is up and running. That's great. If you've newly installed Grafana, the email address and the password by default is admin. Okay, and you can obviously create your own password. So once you're prompted with your credentials admin, then you can just create your own password and submit it. But I'm just going to skip this for now. And this is how the Grafana user interface really looks like. Okay, you can see that there's a search button, there's some icons on the left hand side, and there are also panels that you can play around with. So you can create your dashboard that will allow you to create beautiful visualizations for your data source, right? So once that is done, I'm just going to add my first data source. Just going to click this option in the basic panel. And here, as we are going to be working with Prometheus, we want our data source to be Prometheus. I'm just going to select this, and it says data source added. So you can name your data source anything you'd like, but I'm just going to let it be Prometheus for now. And our URL of Prometheus is localhost 90, right? Once that is done, I'm just going to check if everything looks fine. Yes, it does. So for adding a data source, all you have to do is name it and then add a URL. That's how easy it is. I'm just going to save and test this. And this is great. It's working, right? So once I've saved and tested it, so I'm just going to click the Grafana icon that's present on the left top corner, and this will redirect me to my homepage of Grafana. Okay, now that we are done with this, I'm just going to click the plus icon and click on the option import. So what we're going to do is we are going to import the dashboard from grafana.com. So if I search for Grafana Node Exporter dashboard and click on the first link that's available, it will redirect me to a page which has the name Node Exporter Full, right? So what it really does is it has an ID. The Node Exporter has an ID. So I'm just going to copy this ID to the clipboard, and I'm quickly going to import this ID here, okay? And I'm going to load it. Because we're using the Node Exporter dashboard in Grafana, I'm just going to copy that ID and I'm going to go down. If you want to change the name, you can do that. And I'm going to select Prometheus as my data source. And I'm going to import this. Once that is done, you can see a beautiful representation of your CPU, your system load, your RAM used, and the root FS, the swap used. All of the information is beautifully being represented in gauges, right? These are gauges, okay? And these are the graphs currently. You can see that it's just been used here. You can see busy system, busy user, and all of how long it's been idle for. All of the information about the CPU. This is basic CPU information. You have storage disk. You have 8 panels here. You can see that here. So there's several different panels that have already been created by Grafana, and all you have to do is import it and add your data source. That is your Prometheus, right? And this is way better than viewing it on Prometheus because Prometheus has everything in text and in terms of metrics. So it is very boring to view it like that. I'd obviously prefer Grafana to just view all of this.
Next, in AWS DevOps, you will explore how DevOps is implemented using AWS services.
Now let's talk a little bit about DevOps and cloud, or DevOps on cloud. Why do we need DevOps on cloud? Now understand that DevOps and cloud go hand in hand. They can be implemented individually, of course, but DevOps becomes twice as much efficient and beneficial when clubbed with the cloud. It can help an organization deliver new software features much faster in a more effective manner. Many organizations try to fix their application development processes by shifting from waterfall to DevOps. Now they have this understanding that DevOps alone won't be that effective. So public and private cloud solutions are now evolving together with DevOps. This brings in products at a faster rate to the market through quick access to development environment and streamlined developer processes. Infrastructure as code and automation together reduces the cloud complexity and maintenance of servers and resources, which our ops team previously was very concerned about. The security also highly increases with automated repeatable processes that serve to eliminate error that can cause further issues. And even more importantly, it builds security controls from the very beginning to the very end of the process. Now, because you don't have any servers and your continuous operations are cloud-based, it also eliminates a lot of downtime. And last but not the least, scalability, which is one of the most important factors for applications as they are developed. When DevOps and cloud are clubbed together, it reduces the cost of infrastructure, and global reach also increases with this. Now that you know why you need a cloud platform, let's go ahead and look at our cloud platform of choice today, which is AWS. So what is AWS? Now back in the day, handling and storing data was way different than it is now. Companies preferred storing data using private servers, and that was obviously for security reasons. But however, with better usage of the internet, the trend has seen a paradigm shift for industries as they are moving their data to the cloud. Now, this enables companies to focus more on core competencies and stop worrying about storing and computation. For example, back in the day, if a streaming platform or a search engine platform, anything with a high volume database suffered a corruption, it would take days before their operations resumed. They would face problems scaling up, and only then would they realize the need for a highly reliable, horizontally scalable, and distributed system is what they need. But now, with cloud services and public cloud platforms, this wouldn't be a problem. Now, since every company has started to adopt cloud services, it can be claimed that the cloud is the talk of the town, and AWS in particular is the leading cloud service provider in the market. AWS, which stands for Amazon Web Services, is an Amazon.com subsidiary which offers cloud computing services at an extremely affordable rates. Therefore, its customer base is strong and it targets everyone from individuals to startups to tech giants running the IT landscape. If you might wonder what cloud computing is basically the use of remote servers on the internet to store, manage, and process data, as opposed to an actual physical server or a personal computer to do the same. As we are talking about AWS, it is kind of an IaaS or infrastructure as a service, which basically gives you a server in the cloud that you have complete control over. In IaaS, you are responsible for managing everything starting from the OS completely up to the application you are running. So now that we have discussed about DevOps and AWS, let's move on to our CI/CD pipeline. Now, what is a pipeline or CI/CD pipeline? It's nothing but a series of steps that must be performed in order to deliver a new version of the software. At its bare bones, at its most basic, you have your build, test, and deploy stage. The CI/CD basically stands for continuous integration and continuous deployment. So CI is basically continuous integration, which basically means bringing together all the developers' working copies to a shared mainline. All the developers working on parallel branches of a certain upgrade of an application merge their changes into one main branch. And CD stands for continuous delivery and deployment. Now, while the CI includes building and testing of your application, Continuous deployment is about the processes that have to happen after the code is integrated for the app to be delivered to the users. These processes involve testing, staging, and deploying the code. So at the end of this session, what we aim to do is build a CI/CD pipeline for our demo app on AWS. So for that, we will have to look at a few components of AWS. So DevOps, when implemented on AWS, becomes a lot more efficient and effective for a productive lifecycle. And the steps that are involved in AWS DevOps are code commit, code pipeline, code build, code deploy, and optionally code start. So first of all, we have AWS Code Commit, which is a fully managed source control service, somewhat like GitHub, that hosts secure and highly scalable Git-based repository without the need of operating the system. It's mainly designed for developers who are supposed to store and version their code securely and reliably. For example, you have your IT administrators that store their scripts and configurations, and your web designers who can store their HTML pages and images, etc. The code commit is fully managed, has great availability, is secure, scalable, and pacens up your development lifecycle. For people not aware of code commit, think of it as versioning in your S3. But how it's different is that S3 supports versioning, but not collaborative file tracking features, which code commit obviously does. It manages batches of changes across numerous files made by multiple developers parallelly. How it works is that you create a repository in AWS Code Commit service via the console or CLI, and later using Git from the development machine, you can run git clone to connect the local repository and the AWS Code Commit repo. You can then modify your files on your development machine via the local repository and then run git add, git commit, and push it to the AWS Code Commit repository as you do with GitHub. Again, like Git, even git pull can be used here to synchronize the files in AWS Code Commit repository with your local repo, which ensures that you're working with the latest version of the files. Next on our list, we have AWS Code Pipeline, which is a combination of continuous integration and continuous delivery services for a quicker and more reliable infrastructure and application updates. It automatically builds, tests, and deploys a user code whenever there is a code change, and it is completely based on user-defined release process models. It also integrates with AWS services like AWS Code Commit, Amazon S3, Code Deploy, Elastic Beanstalk, OpsWorks, and AWS Lambda. You can configure the pipeline either with your CLI or your graphical user interface. And like most services on AWS, even with pipeline, you only have to pay for what you use. All of this is great and all, but why should you use Code Pipeline? Simple. By automating your software build, test, and release processes, AWS Code Pipeline enables you to increase the speed and quality of your software updates by running all new changes through a consistent set of quality checks. It automates your release process, it speeds up your delivery with quality, it allows you to choose your tools of choice, establish consistent release processes, and provide a pipeline history detail as your source of truth. Code Pipeline basically breaks up your workflow into a series of stages like your source, build, test, and deploy, and gives you a revision option as a deployable content. Each stage can process only one revision at a time, even though multiple revisions can be processed in the same pipeline. And each stage will have at least one action to be performed, which is some kind of task performed on the artifact. Once all of the actions that are configured in a stage is complete, the stage is considered as complete. After a stage is complete, it transitions the artifacts created in that stage to the next stage of the pipeline, where you can manually enable or disable it, so it prevents changes from running through an entire pipeline. An approval action is granted only by the IAM user, and if an action fails, it does not transition to the next action or stage at all. So when a developer completes working on his code, he or she commits it to the source repository, and Code Pipeline automatically detects the changes and builds those changes. After that, the build code is deployed to the staging server for testing, and then additional tests such as integration or load tests are run by the Code Pipeline. Once all of the tests are run, if the code receives manual approval, then AWS Code Pipeline deploys the tested and approved code to the production instances. Also, every time when a user creates a pipeline, the code pipeline creates a folder for that pipeline in an S3 artifact bucket in that particular region to store input and output artifacts. Next on our list, we have AWS Code Build. Now, this is a fully managed build service in the cloud, which compiles your source code, runs unit tests, and produces artifacts that are ready to deploy. It eliminates the need to provision, manage, and scale your own build servers. It provides pre-packaged build environments for the most popular programming languages and build tools, and scales automatically to meet your peak build requests. Now, one prerequisite is that you must provide the AWS Code Build with a build project, which should include information as to where to get the source code from, build environment, build commands, and where to store the build output. How it works is that the code build will use the build project to create a build environment. AWS Code Build then downloads the source code from the build environment and performs tasks that you would specify in the build specifications. If there is any build output, the build environment uploads its output to the S3 bucket, and while the build is running, the build environment sends information to Code Build and CloudWatch logs. You can use the Code Build console, AWS CLI, or AWS SDKs to get summarized build information from Code Build and detailed build information from CloudWatch logs as well. Now, that was all about Code Build. Now, finally, let's talk about Code Deploy. Now, AWS Code Deploy is a service that coordinates your application deployment and updates across the fleet of AWS EC2 of any size. It automates your code deployment to any instance, handles the complexity of updating them. It also avoids downtime during application development and rolls back automatically if failure is detected. Apart from that, it also integrates with third-party tools and AWS to make your job easier. It has 6 primary components to be specific. You have application revision, compute platform, deployment group, deployment configuration, and the code deploy agent. Now, the basic skeleton of how your deployment workflow pursues is as you can see on your screen. You basically create an application with a unique name and set up a deployment group by specifying the instances to which you want to deploy your application and the deployment type. If you're using the Lambda platform, you just deploy your deployment group's name, followed by which, in your deployment configuration, you specify the success or failure condition of deployment and to how many instances you want to deploy parallelly. Then you upload the application specification file to the S3 and deploy your application as specified with the help of your code deploy agent, which is running on each instance on an EC2 platform, or as specified in your specification file to the deployment group when you're using a Lambda platform. And finally, you check your deployment results. And if you face any bugs or issues, you can always roll back and redeploy. Finally, let's discuss a little bit about CodeStar, which is basically a cloud-based development service that provides tools that you need to quickly develop, build, and deploy applications on AWS. It's basically a very templatized format where you start developing on AWS in certain minutes and you could choose from a variety of project templates. All of the software delivery is easily managed and you can work across your team very securely using the CodeStar. And apart from all of this, you also are provided with a project management dashboard to monitor your application continuously. All you have to do as an AWS CodeStar admin is create a project and add users. Your users or team members will commit changes, which in turn will be built and deployed. And through consistent monitoring of the application, if there are any updates required or any bugs, the developers take a decision, make updates, fix bugs, and then the loop closes back in on the team, and that's about it. The development process takes little to no time using CodeStar. Now that we have spoken about all of these different components of AWS DevOps, I hope building the CI/CD pipeline would seem a tad more tangible to you. If you're new learners, you can always sign up for a free tier, which is free for the entire year. Obviously, there are limitations to all of the services beyond which you shall be charged. but that rarely happens. So if you're starting out with AWS and want to try out all of its features and services, the free tier is a pretty good idea. We already have a video on how to create a free tier on the AWS console. If any of you want to know how to create a free account, you can just go ahead and check that out. So we're going to be building a CI/CD pipeline using AWS, using Code Pipeline. And I'll try to be as slow and verbose as possible, as comprehensive as possible, so as to help you guys to follow me each step of the way. So what we'll be doing here is that we'll be creating a demo application, platform as a service application, and we shall be deploying it using the Code Pipeline. So let's go ahead and create our application first. So to create an app, we will be using the Amazon Elastic Beanstalk, which basically has a bunch of templates ready for you. Now, since this is a demo about Code Pipeline and not web development, we'll be creating a pretty rudimentary app. So let's go ahead and type Elastic Beanstalk. Using Elastic Beanstalk, we can make simple apps very, very quickly. And if you have already created an application, created a few applications, they are going to appear right here on your screen. But since we have created no applications using this particular account, this is a screen that will greet you. So we're going to go ahead and click on Create Application. So let's call this Deployment App. We're not very original, are we? We're not going to put in any application tags. You could put them if you like, but currently they are completely unnecessary. On platform, let's pick PHP. And it automatically fills up the platform branch and version with the latest ones available. Then I'm just going to be using the sample application code and click on Create Application. Now this is a platform as a service app. So basically, once I click on Create Application, I wouldn't have to worry about any background processes or creating the infrastructure. Elastic Beanstalk is going to do that for me on its own. And here it's going to show you all of the steps that are taking place, like create environment is starting, using Elastic Beanstalk as Amazon S3 storage bucket for environment data, so on and so forth. Now this will take some time, so let's go ahead and parallelly do something else. I'm going to open another tab. Now the AWS console. Okay, thankfully it did not ask me to sign in again. So while my app gets created, what I'm going to do is I'm going to create the pipeline. So I'm going to type in Code Pipeline. And the funda is simple even here, guys. You're just going to put in certain details and your pipeline will be created for you. Now this is your dashboard. This is where all of your recent pipelines will appear. Since in this free tier, we have no pipelines created, hence you have no results to display. So first things first, I'm going to create a pipeline. So click on this big orange button which says Create Pipeline. I'm going to give the pipeline a name. Let's just call it Demo Pipeline. So as a default, I'm just going to fill in a role name, AWS Code Pipeline Service Role US East Demo Pipeline. Then click on Next. So for source provider, I'm going to use GitHub. And for that, I'll have to connect to GitHub. And it'll ask me to authorize the code suite. Okay. Okay, once you have successfully authenticated the account, you can go ahead and search for the repository. Here, I'm going to choose the demo-code deploy app, which is actually a sample app I have forked from the AWS Code Pipeline repository. You can go ahead and look for it as well. It will be available in the AWS Code Pipeline's GitHub account. Yeah. And in the branch, let's select master branch and click on Next. Now we move on to the build stage. Because I have nothing major to build, I'm just going to go ahead and pick skip build stage. Then you will be prompted with a notification which will ask you if you're sure to skip your build stage. Now, since I have nothing major to build, yes, I am going to skip this build stage. And for deployment, here we are going to choose a deploy provider. So here I'm going to use Elastic Beanstalk and put in my application name and my environment name. Now our application name was deployment app and our environment name would be deployment app environment. This is something which gets created automatically. So we're going to go ahead and click on next. And finally, we are at the review stage where you can go ahead and review all of the details that you have just put in for your code pipeline. And I'm just going to create this pipeline. It's pretty simple to do. Now this might take a few moments, so kindly be patient. And then you are greeted with a notification which says, "Success, congratulations, your pipeline has been created." Now here you can go ahead and release changes if you want. Our IAM role is in place that we had created earlier. Our pipeline is a success. Now all we have to do is wait for our application to get created, and then we can go ahead and deploy our application. All right, with that, our application has been created. It has 𝐂𝐝, and you can see the platform here. You can see the running version. You can see all the details, all the recent information regarding the app. Now, this is a platform as a service. It basically runs all of your processes in the background. Now, if you would have gone ahead, created this app, configured your IAM user, configured everything else that was needed, this would have taken you a lot of time. But because you are using a platform as a service feature of AWS, this entire process is automated and your work is simplified. So if you go down and look at the recent events, one thing you can see is your instance deployment is completed successfully. Just in the line above that, you can see that your new application was deployed to running EC2 instances. So basically an instance is running on EC2. So let's go ahead and go to EC2, click on instances running. There is one instance running, obviously, we all know which one that is. And this is your deployment app. Now if we go ahead and click on it, here you can see the instance state, it's running, and your pipeline, your source has succeeded, your deployment has succeeded. You go here, you can go down, take a look at your IAM role, your subnet ID. So with that, your instance has been deployed and you realize that your demo pipeline has worked.
After exploring AWS DevOps, we will move to what is Azure DevOps. You will learn how Microsoft's Azure platform supports DevOps practices.
What Azure DevOps exactly is. To understand that, we need to understand what Azure is. And to understand Azure, I would be using this particular analogy. Now, if you talk about power consumption, it's fairly simple. I mean, you consume electricity and you pay for the amount or the units that you've consumed. If you've used maybe 100 units, you'd be charged for 100 units. And the important part here is you're not concerned about where the electricity has come from, who maintains it, how is it generated, how is it brought to your house, and stuff like that. I mean, even if you know about these things, it's not your concern how it is done. I mean, even if you do not have any knowledge about it, you can still survive very well. Similar as Azure or any cloud service provider that is there in the market. Let me tell you how. Now, if you talk about software development, you normally have to take care of a lot of things like building a software, building the infrastructure in first place, having servers in place, making sure that your servers, your resources are monitored and maintained. Now, the problem here is if you are doing all these things, you won't be able to focus on your business. And if you wish to focus on your business, you probably might need to hire quite a few people. Plus, servers and stuff like that is actually costly. What if I could tell you that you could actually go ahead and rent all these services like you rented the electricity and paid only for the units you used? Wouldn't that be nice? Well, this is what Azure does. It is a cloud service provider which actually lets you rent, compute, storage, database, analytics, and a number of other services. You only pay for the services you use and only for the time duration you use those services for. And that is why this analogy, which is very similar to how electricity is consumed and used. I hope the idea is clear to you what Azure is. To give you a little more specific definition, it is a popular cloud service provider which provides services I just talked about, and it is one of the best in the market. It is a Microsoft product, and we all know that Microsoft is a big fish when you talk about software market. And that is why Azure is one of the leading cloud service providers. It is second only to AWS, and it is actually catching up with AWS in a very good way. Now, AWS also has a DevOps approach, and as I've already mentioned, Azure is very much neck and neck with AWS. It also has its DevOps services, and these services that are provided by Azure are very good when you talk about comparing those with AWS DevOps services. Let's try to understand how Azure DevOps services go well with each other, and to do that, let's take a look at some of the components which Azure has to offer to you. Well, when you talk about Azure components, these are the major components which Azure has to offer to you. You have your Azure pipelines, you have your Azure boards, Azure artifacts, Azure repos, and Azure test plans. If you remember the definition of DevOps, I talked about continuous integration and continuous deployment. Let me throw in some light on what it is exactly. Now, when you talk about continuous integration and continuous deployment, what you mean to do here is you wish to continuously build softwares and continuously deploy those to the end users. Again, if there are any releases, any changes that need to be done, those should be implemented right away, and the latest version should be available to all the people that are working on that software. I mean, if I actually go ahead and build a particular software, now if there are like 15 people working on that, and if I make some changes to that software, that change should be given to everyone, right? So this is where continuous integration and deployment comes into picture. It aims at keeping everyone on the same page and ensuring that software development happens at a faster rate. And to do that, you have something called as Azure pipelines. Now, when you talk about continuous integration and deployment, you need a line, maybe a tunnel where you can actually carry out these processes, right? That tunnel, that line, that pipeline is something that is provided by Azure pipelines. I mean, you can actually go ahead and build any kind of software and use different kinds of platforms that Azure supports. And when I say Azure supports, well, Azure supports so many platforms that I believe there is hardly any software or any framework that you wish to use that you cannot using Microsoft Azure. And that is why building pipelines with Microsoft Azure becomes very easy. Now, if you talk about building pipelines in general, it is a very simple and a very easy to implement kind of a process, because it is just clicks away when you talk about Microsoft Azure. And once the pipeline is ready, integrating it with different softwares becomes very, very easy. Now, again, if you are building a software, you might be having maybe hundreds of people working on that software. In that case, you need a software or something that would let you keep track of all these things, help you plan better, help you have everyone on the similar pages, and help you keep track of all these things. Now, this is where Azure boards come into picture. It readily integrates with Power BI. Now, if you people know what Power BI is, it is a data visualization and business intelligence tool, and it is one of the best in the market. It is very neck and neck with Tableau, which again is a great tool. And what Microsoft Azure boards do is they let you integrate Power BI into Azure DevOps environment, where you can actually go ahead and take a look at the data in real time and have various graphs, charts, so that your assessing or the way in which you keep track of all these things becomes a lot more easier. Next, we have Azure Artifacts, and what it does is it lets you take into consideration various packages or feeds that you generate. Now, when I say this, you can do that from both private and public resources. Apart from that, whether it's Maven, whether it's NewGen, whatever it is, everything is taken care by your Azure Artifacts. When you're talking about continuous integration and deployment, your repositories become very important. And Microsoft Azure lets you have any kind of repositories that are there. If you take a look at Azure Repos, it has almost everything that is needed to deal with repositories. If you're building a software, it needs to be tested. And with Azure Test Plans, you can do end-to-end testing, and it ensures full coverage for your tests. So these are some of the components that ensure DevOps process is carried out very well with Microsoft Azure. And that is why Azure and DevOps go very well hand in hand. Now let's move further and take a look at the demo part. So guys, in order to understand how Microsoft Azure works or how the Azure DevOps stuff works, we would be switching into Azure portal. Now Azure, as I've already mentioned, is a cloud service provider, and we are going to see how Microsoft Azure can be used to carry out DevOps operations. To do that, you can actually go ahead and visit Azure's website. Just open their website and then you have this place called as portal where you can click in. Now guys, if you have an account, it would ask you to sign in. Just go ahead and sign into your account and you are more than good to go. For people who are completely new to Microsoft Azure, let me tell you a thing that they have something called as a free tier where you can actually go ahead and create a free account. You have to enter in your credit card details, but Microsoft Azure won't charge you for that. Once you create an account, Microsoft Azure gives you certain free credits which you can use for a particular duration of time. Now, I cannot see my credits here, but normally you can actually go ahead and take a look at the amount of credits that Microsoft Azure has to offer to you. It is somewhere around, if I'm not wrong, it is close to $200 if I'm not wrong. Yeah, that is what it is. So probably you would be able to utilize the services for free. And how do you do that? You use that credit that is made available to you. So if there is a particular service that you want to use, you can pay the bills using the credit that is made available to you, and you won't be charged for the services that you use. There are certain limits on the services that you use. Suppose if you actually go ahead and create a server and you let it open for a long time, create a database on top of it, you might be charged heavily for that. But I would suggest that you actually go ahead and take a look at certain documentation that Microsoft Azure has to offer to you. And as long as you stay in the specified limits, you won't be charged anything. So I would suggest that you actually go ahead and put in your credit card, debit card details and get an account created. Once you create an account, this is what the Microsoft Azure portal or the interface looks like. So we have our account, which is up and running. Now we are going to go ahead and carry out DevOps practices, right? So how do we do that? We switch into DevOps. You can just come to the search console and type DevOps here, Azure DevOps, or you can just go ahead and type Azure DevOps somewhere here. The reason I'm doing this is I want to show you how the interface looks like. So this is what it would look like when you start. And if you click on start free, you would be redirected to this page. Now again, guys, first you need to create an organization. Think of organization as an environment. I mean, if your company is actually planning to build a software, they would be having a structure to do that, right? So if your company is planning to actually go ahead and build a particular software, they would be having a template, a structure to do that, right? So when I say an organization, I'm talking about a structure. How do you create an organization? It is very simple. Here's an option here. If you click on new organization, it would ask you for the name of the organization. You enter the name and your organization gets created. Now that we have an organization, our next step should be to go ahead and create a project. How do we do that? Again, click on project. There would be an option here once you create an organization saying that do you want to create a project? You should say yes on it. Again, that is how the interface looks for somebody who has started fresh. If not, this is what it would look like. So I can just go ahead and enter the project name. Let's say demo project for today. I'm bad at naming conventions, so forgive me for that. Description, sample project would do. Again, guys, the complexity of project is not important here. I'm just trying to explain certain stuff to you. So please pardon this simpleness of this particular project. Again, guys, once you do enter in the details, it gives you an option. Do you want it public or private? When you say public, anyone on the internet can have access to it. More of an open source kind of stuff. If not, you can stick to your private thing and you can give access to the people you want to take a look at your project. Having said that, if you select private, you can just say create project and your project gets created. Okay, guys, so the project is created. It took a longer while than normal. If your internet is not working that well, at times it takes this time. So once the project is ready, guys, you are actually free to go ahead and do the stuff. Now, these are the components that we talked about. At the bottom, you can see these components. You have your boards, repos, pipelines, test plans, artifacts, and you can actually go ahead and create all of those. Let's start by creating a pipeline first, guys. So all you have to do is say new pipeline. Now again, guys, how do you actually go ahead and create a pipeline? What do you do for that? Do you go ahead and use an existing piece of code that you have? Do you have repositories that you want to do? Or do you want to type in your own code? You can do anything you want. You can use Azure repos, which are made available to you for free. GitHub, we all know, is a popular place to have your repositories kept. And if you wish to do that, you can import repositories from your GitHub as well. To do that, you have to actually just go ahead and click on this icon. That is what I'm going to do in this session. I'm going to use a GitHub repository. So you have to click on this thing and you have to authorize your GitHub repository or your GitHub account rather. Now my account is already authorized with Azure, so I don't think it should ask me for reauthorization. You can actually go ahead and authorize your GitHub account. Once you do that, you're free to actually go ahead and import repositories from your GitHub. Now, if I go to GitHub, this is my demo account. So I have one repository that I have it here. My repositories. You can see this is a Python repository, guys. As I've already mentioned, you can use any platform you want when you talk about Azure. Python is something that is simple and I wish to stick to that. Now, this repository is something that is made available to you by Microsoft Azure as well. Do not worry, I would be sharing in this link. If not, you can visit Microsoft Azure Docs for Azure DevOps and you would get this link as well. So once you have this link, you have to fork this thing into your GitHub. For people who do not know what GitHub is, well, think of it as a storage place where you can actually go ahead and store your repositories. Now, repositories is nothing but it is a piece of code or a software which you can actually go ahead and store it here, which you can give access to others as well. Something that is called as open source, where others can actually go ahead and take in your piece of code, maybe modify it and give it to you, or modify it and use it for their own purpose. So this is what GitHub does. It is a place where you can put in your codes, you can have a master branch for it, and you can give access to certain people who can make changes to that code. Now, how do people make changes to it? They have this option which is called as forking your GitHub repository. When I say forking it, that means I'm actually creating a copy or a branch of this particular repository and I'm using it for my own sake. Once I make changes to it, I can submit those changes to the main repository or to the master branch of it. So this is what GitHub is. And the process which we saw here, it would ask you to authorize your GitHub account. And if you've already forked that particular repository, it would be available here in the suggestion. As you can see, it has been forked here. So I have this repository here, which I've selected. So it opens my YML file, which is there, which I can actually go ahead and edit. What does this thing do? It considers Python Django framework. It tests a Django product or project rather on multiple versions of Python. And it has steps that lets you analyze code, save, build artifacts, deploy them, and more. So this is what this piece of code does for you guys. And won't be getting into the details of what this code does, but again, it's a sample repository. You can actually go ahead and study it a little more. Once you do that, all you have to do is just run this piece of code. As simple as that, guys. You have to run it. What this code does is it creates a pipeline for you. And when I say it creates a pipeline, it lets you probably actually go ahead and make codes, make changes to the codes, and submit those to the master branch. We would be doing that. Do not worry about that. As you can see, Microsoft Azure gives you continuous feedback and update as to what is happening, where it is happening, and how it is happening. This might take maybe half a minute or so because quite a few things that are happening. As you can see, it's telling you what has happened, right? I mean, the processes, you can see the tasks happening. It is performing tests and stuff like that. See, these are the number of processes that have taken place. You've prepared a job, it has initialized an agent to take care of it, initialized the job, got resources for it, used Python version, exported the project path, then it installed certain prerequisites, it ran tests, it published the test results, and then this is what happened. Post job get sources. If you wish to have more details, you can click on this icon and it would give you the details about what has happened here. So you can do that as well. Or you can just probably come back to pipelines and see that there's a pipeline that has been created. Now, guys, if I actually go ahead and commit changes to this piece of code, that is my YML file or the files that I have in this repository, those would be reflected here. You can see the status here. We are going to do that, but let me show you some other things as well. If I click on analytics, it should give me analytics of what has happened here, whether there were any failures, whether the code ran properly and stuff like that. Test failures is not available because we do not have a plugin here. When I say plugin, okay, it did not find any test results is what it is saying. So let's just go ahead and do certain things and probably this would be more clear to you guys. Do not worry about that. Going back to the history part. If I take a look at the summary part, it would tell me what has happened here. Test succeeded, build pipeline succeeded, manually queued, and this is what has happened. Now guys, can I just go ahead and put in certain other details? Can I make certain changes here? Let's try to understand what can be done. Now, again, I have this Git repository with me, right? So let's just go ahead and play with it a little and commit certain changes. To do that, first go to the pipeline. This is the pipeline I'm concerned about. And probably I must be getting certain details that I'm looking for. They're not here. So let's go back a little. Projects, pipelines again. Here you have this option called as status badge. Now, what is the status badge? See, this is what the status badge looks like. It tells that, okay, whether the pipeline you built was built correctly or not. So if you are a developer, you would be wanting your code to be green, right? I mean, everything should be checked green. Everything should be nice and ready and successful. So this is what the badge does. So we are going to go ahead and use this piece of badge to add to our code so that now this is a sample stuff. I mean, it's not that important, but if we do go ahead and make or add this badge to our piece of code, it would show that a certain change was made in the code or in the file, and that would be reflected in the pipeline, something that is important when you talk about CI/CD. So let's do that with this simple example. So I come to the pipelines here, my pipeline, and then I scroll down. You would be having this README file where you can make changes. How do we do that? I say edit. And then I add in a piece of code here. Say, let's add a new piece of code somewhere here maybe. Okay, there you go. Again, guys, do not get into the details of the complicacy of this stuff. It is fairly easy, and do not judge me for that either. I mean, as I've already mentioned, my aim is to just go ahead and show you how the concept or the stuff works. So it is very basic, guys. I've just gone ahead and made some change to this piece of code. I've actually just gone ahead and added the badge here. So I'm just going to go ahead and say commit changes, update README file. Yes, please do that. Commit directly to the master branch, or should I commit it to the new branch that I did? Let's say master branch for now. So the change was committed here. So if I come here and if I just go to pipelines and select my pipeline, open it. Yeah, there you go. The change has been reflected. Update README. So this file was updated. So again, guys, this is what I'm talking about. Continuous integration and deployment. That is what it means. I mean, if I make change to this piece of code, and if somebody else wants to access it, it or my software should give me the latest copy, right? So this is what this piece of code is doing. In my pipeline, if I just go ahead and pick a certain piece of code, I make change to it, that change gets reflected. And this is what DevOps does. And this is what Azure helps you do. It lets you bring in the whole GitHub concept into Azure, and it helps you go ahead and work with CI/CD in a much better way. Again, I talked about some other stuff as well. Repos, you have your boards, you have quite a few things that you can do. If you talk about overview in general, you have something called as dashboard. So if I click on this icon here, so I have this dashboard that is created by default. Oh, there is no dashboard here. Or if there is a dashboard, it does not have widgets. So I'm going to add a widget. Let's say I need a widget for build history. So I click on it and I say add. So I say done editing. So if I just refresh this thing, so if I just come here and select this particular pipeline and I say save, it will reflect the changes that has happened. What happened with or what is happening with this particular dashboard or with this particular project. So it would give me details like these. And as I've already mentioned, when you create dashboards, you can actually go ahead and integrate Power BI, which is a very popular business intelligence and BI tool basically. So you can actually go ahead and take in or consider all those features as well. Apart from that, you have all the other stuff that you can actually go ahead and play with. Again, to use analytics or to understand how analytics work with this thing, you actually would have to go ahead and do two things. One, you would have to go ahead and integrate your plugin for analytics. Once you do that, you can go ahead and implement quite a few things. To do that, you can actually come here and you can do quite a few things. You can take your GitHub connections. You can integrate your GitHub with your Azure. You can actually go ahead and integrate quite a few other things. See, you have options like service connections, agent pools, retention, parallel jobs, and stuff like that. So you can take care of all those things as well. Boards, again, you can go ahead and add items here. Items as in you can put in states where you want to put in details for certain things, like there are particular bugs that have particular priorities. Based on your project, you can add in those items saying that, okay, this is the criticality of those items and stuff like that. It is fairly easy. You can just click on create a new item, whether it's a bug, whether it's a feature, issue, whatever it is. You can go ahead and you can add that here. And you can keep track of all those things in the form of dashboards or boards here. Repos, you can actually go ahead and when you click on files, you can see the repos that you're using and stuff like that. You can go to the marketplace and you can take in the repos that Microsoft Azure supports. Pipelines, we've seen what it is. Test plans, you can go ahead and launch proper test plans as well. And you can create your own artifacts or your feeds as well by using Azure artifacts. So yeah, guys, this is pretty much what this session had to offer to you people. We did go ahead and create a pipeline. We saw how to commit changes and how those changes get reflected when you use an Azure pipeline. And we also saw what dashboards are and how do they work.
Moving on to our next question. Azure DevOps is a set of tools and services provided by, and the options are A. Amazon Web Services, B. Google Cloud, C. Microsoft Azure, or D. IBM Cloud. If you know the correct answer, please comment down below. With Azure DevOps covered, we will now compare methodologies in DevOps versus Agile. You will understand the differences and similarities between these two approaches.
First one will be the purpose. An agile process uses an iterative approach, which will quickly and efficiently evolve to respond to customer needs. Whereas DevOps practices combine the development and the operation team, using automation for continuous deployment. Next, we have principles. Agile mindset revolves around teams who prioritize delivering working software through constant communication with the client. This allows for adaptability to new information and keeps projects relevant in the world. Whereas DevOps will focus on 5 principles: culture for communication, automation to streamline tasks, learn principle to eliminate waste, measuring for continuous improvement, and sharing to promote transparency and knowledge exchange. These principles work together to enhance efficiency and software quality. Next, we have practices. Agile development breaks tasks into small stories and communicate daily in stand-up meetings. A team will work for a shorter periods to manage complex projects and improve efficiency. Whereas the DevOps software development method will highlight continuous delivery, automation, monitoring, and continuous integration. Then we have team skills. Agile team members are more flexible, adaptable, multifunctional, and are strong communicators. There will be technical and non-technical people working in it, where DevOps team members automate processes with IAC, deploy software, and generally there are much technical people involved in this. Next up, we have toolkits. Agile will make use of the project management tools like Trello for version control, Git is used for changing the code and communication, Slack is used to keep the code in sync. Whereas DevOps will focus on bigger building process. They use configuration management tools to automate infrastructure setup, CI/CD tools to automate building, testing, and deployment. Lastly, monitoring tools to keep an eye on everything. And lastly, we have risk management. Rapid development with risk mitigation, like sprinting to the finish line but with a safety net. You break down your project into smaller tasks and work quickly using efficient methods. Whereas in DevOps, it ensures that the changes wouldn't risk project integrity, meaning making sure any modification to the project wouldn't negatively impact its overall quality, performance, or ability to achieve its goal. It's like safeguarding the health of the project throughout its development. Now, let me take a case study as an example to compare DevOps versus Agile. Let's take Spotify as an example, as it is a popular music streaming platform that personalizes the customer's experience and delivers new features quickly to a large and various user comments. Their traditional waterfalls development process led to slow innovation, and it's difficult to adapt to user feedbacks. So, Spotify embraced Agile methodology, focusing on the short sprints with user stories that prioritize features based on user needs. They also implemented DevOps practices, utilizing CI/CD pipelines for automated testing and deployment. Additionally, they also adapted a culture of experimentation, allowing teams to test new features with a small setup of users before broader rollouts. This approach has enabled Spotify to personalize music recommendations, roll out new features more frequently, and adapt to user feedback faster. Their experimentation culture allowed them to test and refer features before wider deployment, reducing the risk of introducing bugs or unpopular features. This shows us that DevOps and Agile are better when they work together. Still, for Spotify needs of rapid feature development and reliable deployment, DevOps is the best choice. Now let us see the future of DevOps and Agile. In the future, the scope of DevOps and Agile in AI and ML will be like DevOps, it will automate repetitive tasks like a tireless construction crew, freeing developers for creative problem solving. Agile, like a weather forecast for the building, provides data insights that enables developer to make better decisions about features and priorities in AI ML development. Next, let's see the role of DevOps and Agile in an advanced collaboration tool. Agile promotes effective teamwork and frequent communication, which is very essential for distributed teams, whereas DevOps combines these tools into development pipeline for seamless project management. Lastly, we have infrastructure as code and GitHubs. Agile supports continuous improvement and updates, enabling quick adaptation to the changes, where DevOps drives automation and consistency in infrastructure management through IAC and GitHubs. So, I'm here to conclude that both DevOps and Agile are essential, but DevOps is better if you focus on automating and streamlining the entire software delivery process. At the same time, Agile is better if you need to improve flexibility and responsiveness in the development phase.
We have just compared DevOps and Agile. Next in DevOps roadmap, you will learn the steps and skills needed to become proficient in DevOps.
First, you need to understand that there are two main parts when creating an application. The development part, where software developers programs the application and testing of application, and the operation part, where the application is deployed and maintained on a server. And DevOps is a link between the two. Now, this is a bit too abstract, so let's dive into the details to really understand the DevOps tasks and which tools are needed to carry out these tasks. Concept of software development. It all starts with the application. Developers team which program an application with any technology stack, different programming languages, build tools, etc. And they will of course have a code repository to work on the code in a team. One of the most popular ones today is Git. Now you as a DevOps engineer will not be programming the application, but you need to understand the concept of how developer works, which Git workflow they're using, also how the application is configured to talk to other services or databases, as well as concepts of automated testing and so on. Operating system and Linux basics. Now that application needs to be deployed on a server so that eventually user can access it, right? That's why we're developing it. So we need some kind of an infrastructure, on-premises server or cloud server. And these servers need to be created and configured to run our application. Again, you as a DevOps engineer may be responsible for preparing the infrastructure to run the application. And since most of the server where applications are running are Linux servers, you need to have a knowledge on Linux. And you need to be comfortable using the command line interface because you will be doing most of the stuff on the server using command line interface. So knowing basic Linux commands, installing different tools and software on servers, understanding Linux file system, basics of how to administer a server, how to SSH into the server, and so on. Scripting language. In addition, since you are closely working with developers and system administrators, to also automate some of the tasks for them, you will most probably need to write script. Maybe small application to automate tasks like doing backups, system monitoring tasks, cron jobs, network management, and so on. In order to be able to do that, you need to know a scripting language. Now this could be an operating system specific scripting language like Bash or PowerShell, or what's even more demanded, a more powerful and flexible language like Python, Ruby, or Golang, which are also operating system independent. Again, here you just need to learn one of these languages, and Python without a doubt is the most popular and demanded one in today's DevOps space.
Easy to learn, easy to read, and very flexible. Python has libraries for most of the database's operating system tasks as well as for different cloud platforms. Version control. Now with these automation tools and languages, you write all of these automation logic as code, like creating, managing, and configuring infrastructure. That's why the name infrastructure as code. Now, how do you manage your code? Just like the application code, you manage this also using version control like Git. So as a DevOps engineer, you also need to learn Git, build automation, and CI/CD. Now we have developers who are creating new features and bug fixes on one side, and we have infrastructure or server which are managed and configured to run the application. The question now is how to get these features and bugs fixed from the development team to the server to make it available to the end users. So how do we release the new application version basically? And that's where the main task and responsibilities of a DevOps comes in. With DevOps, the question is not just how we do this in any possible way, but how we do this continuously and in an efficient, fast, and automated way. So first of all, when the features or bug fix is done, we need to run the tests and package the application as an artifacts like jar file or zip, etc. so that we can deploy it. That's where build tools and package manager tools comes in. Some of the examples are Maven and Gradle for Java application, NPM for JavaScript application, and so on. So you need to understand how this process of packaging, testing, application work. As I mentioned, containers are being adopted by more and more companies as a new standard. So you will probably be building Docker's image from your application. As the next step, this image must be saved somewhere, right? In an image repository. So Docker artifact repository or Nexus or Docker Hub, etc. will be used here. So you need to understand how to create and manage artifact repository as well. And of course, you don't want to do all of this manually. Instead, you want one pipeline that does all of these in a sequential step. So you need build automation. And one of the most popular build automation tools is Jenkins. Of course, you need to connect this pipeline with the Git repository to get the code. So this is a part of continuous integration process where codes changes from the code repository get continuously tested. And you want to deploy that new features or bug fix to the server after it's tested, built, and packaged, which is a part of continuous deployment process, where code changes get deployed continuously on a deployed server, and there could be some additional steps in the pipeline, like sending notification to the team about the pipeline state or handling failed deployment, etc. But this flow represents the core of the CI/CD pipeline, and the CI/CD pipeline happens to be at the heart of the DevOps tasks and responsibilities. So you as a DevOps engineer should be able to configure the complete CI/CD pipeline of your application, and the pipeline should be continuous. That's why the unofficial logo of DevOps is an infinite cycle. Because the application improvement is infinite, new features and bug fixes gets added all the time that needs to be deployed. Infrastructure as code. Now let's say this is our production environment. Well, in your project, you will of course need development and testing or staging environment as well to properly test your application before deploying it to the production. So you need that same deployment environment multiple times. Creating and maintaining the infrastructure for one environment already takes a lot of time and is very error prone. So we don't want to do it manually 3 times. As I said before, we want to automate as much as possible. So how do we automate this process? Creating the infrastructure as well as configuring it to run your application and then deploying your application on that configured infrastructure. It can be done using a combination of 2 types of infrastructure as code tools. Number 1 is infrastructure provisioning tools like Terraform, for example, and configuration management tools like Ansible or Chef, etc. So you as a DevOps engineer should know one of these tools to make your own work more efficient as well as make your environment more transparent, so you know exactly in which state it is and easy to replicate and easy to recover. Containers. Nowadays, as containers have become the new standard, you will probably be running your application as containers on a server. This means you need to generally understand concepts of virtualization and also be able to manage containerized application on a server. One of the most popular container technology today is Docker, so you will definitely need to learn it. Container orchestration. Now application will run as containers, right? Because we're building Docker images and containers needs to be managed. For smaller application, Docker Composers or Docker Swarm is enough to manage them. But if you have a lot of containers, Like in case of big microservices, you need a more powerful container orchestration tools to do the job, most popular of which is Kubernetes. So you need to understand how Kubernetes work and be able to administer and manage the cluster as well as deploy application in it. Cloud providers. Now let's go back to the infrastructure where our application is running. Nowadays, many companies are using virtual infrastructure on the cloud instead of creating and managing their own physical infrastructure. These are infrastructure like AWS, Microsoft Azure, Google Cloud, etc. One obvious reason for that is to save costs of setting up your own infrastructure. But these platforms also manage a lot of stuff for you, making it much easier to manage your infrastructure there. So for example, using a UI, you can create your network configuration firewall, route tables, and all part of your infrastructure through services and features these platforms provide. However, many of these features and services are platform specific. So you need to learn them to manage infrastructure there. So if your application will run on AWS, you need to learn the AWS and its services. Now AWS is pretty complex, but again, you don't have to learn all these services that it offers. You just need to know those concepts and services that you need to deploy and run your specific application on the AWS infrastructure. Networking and security. You also need to know basics of networking and security. For example, to configure firewall to secure the application, but also open some ports to make application accessible from outside, as well as understand how IP addresses ports and DNS works. However, to draw a line here between the IT operation and DevOps, you don't have to have advanced super operating system or networking and security skill and be able to administer these servers from start to finish. There are own professions like network and system administrator, security engineers, and so on that really specialize in one of these areas. So your job is to understand the concept and know all these to the extent that you be able to prepare the server to run your application, but not to completely take over the managing the server and the whole infrastructure. Monitoring. Now when you have all these maybe thousands of containers running in Kubernetes or hundreds of servers, how do you track the performance of your individual application? Or whether everything runs successfully, whether your infrastructure has any problems, and more important, how do you know in real time if your users are experiencing any problems? One of your responsibility as a DevOps engineer may be to set up monitoring for your running application, the underlying Kubernetes cluster, and the server on which the cluster is running. So you need to know a monitoring tools like Prometheus or Nagios, etc. DevOps tools. So at this point, you may be thinking, how many of these tools do I need to learn? Do I need to learn multiple tools in each category? Also, which one should I learn? Because there are so many of them. Well, you should learn one tools in each category. One that's the most popular and most widely used. Because once you understand the concept well, building on that knowledge and using an alternative tools will be much easier. If, for example, you need to use another tools in your company or project, so as you see, these are a lot of technologies that you need to learn as a DevOps engineer, and it might be overwhelming. So if you're thinking you don't know where to start or where to learn all these, then we at Edureka have created a complete DevOps training where you can learn all these technology in a structured way.
After understanding the DevOps roadmap, we will explore DevOps tools. This topic will introduce you to essential tools used in DevOps environment.
Version control. Version control manages changes to a project's source code. It helps multiple developers work on a project simultaneously without conflicts and enables tracking the history of changes made to the project. Version control is a fundamental element of DevOps that promotes collaboration, automation, traceability, and risk mitigation throughout the software development and delivery lifecycle. Now let's explore 3 version control tools. Git. Git is a widely used tool for source code version control. Git is the backbone of many DevOps workflows. Git is used to monitor changes in the source code, enabling multiple developers to collaborate on non-linear development. Git is open source and enables multiple developers to work on a project simultaneously. One of the popular Git hosting services is GitHub, where developers can host their repositories, collaborate with their team, and contribute to open source projects. Git's flexibility, speed, and collaborative features have made it an essential tool in modern software development workflows. So Git has a 3-tier architecture, unlike other version control systems. The three layers are the working directory, staging area, and repository. So the working directory represents the actual files on your local machine. It's where you make changes to your code. Developers interact with the working directory, modifying files and creating new ones. The staging area is an intermediate step between the working directory and the repository. So changes made in the working directory are staged using the git add command. The staging area helps in organizing and preparing changes before committing them to the repository. The repository is where Git stores the complete history of a project, including all commits, branches, and tags. These three layers comprise Git's architecture, facilitating version control and collaboration in software development. Developers work in the working directory, stage changes in the index, and commit them to the repository, enabling efficient tracking of project history and collaboration with others. The repository can be local on your machine or remote on any server. Subversion. Subversion, often abbreviated as SVN, is a centralized version control tool that helps manage and track changes to their codebase. It was created by CollabNet Inc. in 2000 and has been widely used in various software development projects. Unlike distributed version control systems, example Git, Subversion uses a centralized repository model. There is a single central repository that stores the complete version history of the project. Mercurial. Mercurial is a distributed version control tool designed for managing source code repositories. Like Git, Mercurial allows developers to track changes to their code over time, collaborate with others, and manage different branches of development. Matt Mickle created Mercurial and released it in 2005. Mercurial plays a crucial role in managing and tracking changes to infrastructure, code, scripts, configuration, files, and application code. Mercurial is designed to be simple and easy to use. CI/CD. Continuous integration, continuous deployment is a technique that involves automating different stages of app development to deliver apps to customers regularly. So CI/CD brings continuous automation and continuous monitoring to apps at every phase of their lifecycle, from delivery and deployment to integration and testing. These connected techniques are often referred to as CI/CD pipeline and are used by the development and operations team. CI/CD is a solution to the problems that arise when integrating new code. Continuous integration and continuous delivery are integral components of the DevOps philosophy, contributing significantly to the efficiency, reliability, and speed of software development and deployment. So let's explore some CI/CD tools. Jenkins. Jenkins is an open source automation server widely used for building, deploying, and automating any project, particularly in the field of continuous integration and delivery. It helps automate parts of the software development process, making it more efficient and reducing manual intervention. Jenkins is an amazing tool to build a CI/CD pipeline because of its flexibility, extensibility, and strong community support. Jenkins plays a crucial role in the DevOps toolchain by automating key processes and providing a flexible and extensible platform for developing, testing, and releasing software. Its popularity and widespread adoption make it an essential tool for many DevOps teams. So Jenkins operates based on a master agent architecture, enabling the distribution of build and deployment tasks across multiple machines. The Jenkins master is the core server that manages the entire Jenkins environment. It handles the scheduling of jobs, monitoring of agents, and overall coordination of the CI/CD pipeline. Jenkins agents or slaves are machines that perform the actual building, testing, and deployment tasks. Agents connect to the Jenkins master and execute tasks as directed. GitLab CI is a part of GitLab, a web-based Git repository manager. So GitLab CI is designed to automate the build, test, and deployment processes of software projects. The core concept in GitLab CI is the CI/CD pipeline, which is a set of automated procedures that run when changes are made to the source code repository. So a pipeline simplifies the implementation of CI/CD best practices within the GitLab platform. Travis CI. Travis CI is a cloud-based CI/CD service that automates the process of developing, testing, and deploying software products. Travis CI automates the process of continuous integration by automatically triggering builds whenever changes are pushed to the version control repository. Travis CI integrates seamlessly with GitHub and Bitbucket repositories. Developers can configure Travis CI to automatically trigger builds and tests. Configuration management. Configuration management is a software engineering and IT operations discipline that manages and controls the configuration of software systems and infrastructure. The goal of configuration management is to ensure consistency, reliability, and traceability of a system's configuration throughout its entire lifecycle. Some popular configuration management tools include Chef. So Chef is a powerful open source configuration management and automation tool. It allows users to define the configuration of their infrastructure as code, automating the deployment, configuration, and management of servers and applications. Chef is particularly useful in large-scale and dynamic environments where maintaining consistency and automating repetitive tasks are essential. So Chef works on a 3-tier client-server model. Here are the key components of Chef architecture. The Chef workstation is the development environment where developers test their code. It includes the necessary tools, libraries, and the command line utility for interacting with the Chef server. So Chef server is a central component that manages the configuration data and metadata for all nodes in the infrastructure. It stores information about code, environments, and node configurations. And the Chef client runs on each node in the infrastructure. It is responsible for executing configurations retrieved from the Chef server. Chef client is the key component of all the nodes, which helps in setting up the communication between the Chef server and Chef node. Ansible. So Ansible is an open source automation tool for task automation, configuration management, and application deployment. It is designed to simplify and automate various IT tasks, including configuration management, application deployment, and task automation. Ansible is known for its simplicity, agentless architecture, and ease of use. It's suitable for managing both small-scale and large-scale infrastructure and is used by organizations of various sizes to automate their IT processes. Puppet. So Puppet is a popular open-source configuration management tool. Puppet is designed to automate the provisioning and management of IT infrastructure. Puppet allows administrators to define the desired configuration or state of their infrastructure components, such as servers and applications. Puppet organizes configurations into modules, which are units of code that can be reused across different systems. Containerization. Containerization is a form of virtualization that allows applications and their dependencies to be packaged together in a standardized and portable environment called a container. So containers provide a consistent and isolated runtime environment, ensuring that an application runs consistently across different computing environments. So Docker is the most widely used container technology today. A Docker container image is a lightweight executable standalone software package that includes code, runtime, system tools, and system libraries. That is everything needed to run an application. Docker is extensively utilized for software development and deployment because it simplifies the process of packaging and running applications, streamlining the development to deployment workflow. The Docker architecture is based on a client-server model and consists of several components that work together to enable containerization. The Docker client is the first component of a Docker architecture. The Docker client is the primary way that Docker users interact with Docker. The command line tool that lets users communicate with the Docker daemon is called the Docker client. Users can use the Docker client to build, manage, and interact with containers and Docker images. We can run commands such as Docker build, Docker run, and Docker pull in the Docker client. The Docker host is the second component of the Docker architecture. It comprises the Docker daemon, images, containers, networks, and storage. The Docker daemon, also known as the Docker engine, is the background service that runs on the host system. A REST API is used by the Docker client and daemon to communicate over a network interface or Unix sockets. The Docker daemon listens for Docker API requests and communicates with the host's kernel to manage containers, volumes, images, and networks. Multiple daemons can be communicating with the Docker client. Docker registry is the third component of the Docker architecture. The Docker registry contains all of the Docker images. Docker Hub is a public registry of the Docker. The use of Docker registries facilitates distribution and sharing of Docker images. So with the help of Docker run or Docker pull commands, we can pull the required images from a configured registry. Container orchestration. Container orchestration automates the deployment, management, scaling, and networking of containers. The deployment, scaling, networking, and management of containers are all automated with the help of container orchestration. Container orchestration is a crucial component of modern application deployment and management, especially in microservices architectures and cloud-native environments. It enables organizations to manage and scale containerized applications, making it easier to build and operate complex distributed systems. Kubernetes, an open-source platform for container orchestration that automates containerized application deployment, scaling, and management. Originally developed by Google, Kubernetes is now maintained by the Cloud Native Computing Foundation and has gained widespread adoption in the industry for managing containerized workloads in production environments. It is commonly used in cloud native and microservices architecture. Here are the key components of the Kubernetes architecture. Kubernetes implements a cluster computing background. The master node manages the entire Kubernetes cluster. Master controls the cluster and the nodes in it. This cluster is hosted by one node acting as the master of the cluster and others as nodes which do the containerization. Nodes are the worker machines that run containers and host the applications. Infrastructure as code. Infrastructure as code describes the methods and resources for defining infrastructure, usually in a markup language like JSON or YAML. It involves managing and provisioning computing infrastructure through machine-readable script files. So the goal of IAC is to automate and streamline the process of infrastructure management, making it more efficient and scalable. Some popular IAC tools are Terraform. Terraform is the most popular infrastructure provisioning tool. It is a tool for building, changing, and versioning infrastructure as code. Terraform is an open source tool developed by HashiCorp. It enables users to define, provision, and manage infrastructure resources in a declarative configuration language. Terraform is designed to work with various cloud providers, on-premises data centers, and other infrastructure components, allowing for consistent provisioning and management across different environments. CloudFormation. AWS CloudFormation is a service provided by Amazon Web Services that allows users to define and provision infrastructure resources. It enables the creation and management of AWS resources using templates written in JSON or YAML format. CloudFormation templates describe the desired state of infrastructure, including the configuration of various AWS services and their interrelationships. Cloud platforms. Cloud providers offer a layer of APIs to abstract infrastructure and provision it based on security and cost constraints. The great success and intricacy of contemporary DevOps can be attributed to the cloud provider's ability to provision, configure, and secure resources quickly. Cloud providers such as Amazon Web Services, Microsoft Azure, and Google Cloud Platform offer a wide range of services for building and deploying cloud-based applications. Test automation. Automation testing allows for the quick and frequent execution of test cases, providing rapid feedback to developers. This enables the integration of code changes into the main code base more frequently, promoting a continuous integration workflow. DevOps engineers carry out quality assurance software testing to understand the effectiveness of various software tools. So Selenium is a popular tool for web application testing, and it has become the standard for automated web testing. Selenium can be integrated with testing frameworks such as JUnit, TestNG, NUnit, and others. This integration enhances test organization, reporting, and management, making it easier to incorporate Selenium into existing testing processes. Project management. Project management in DevOps ensures that development and operations activities are aligned with the overall business goals and objectives. It helps ensure that the principles and practices of DevOps are effectively applied throughout the software development and delivery lifecycle. Project management helps in efficient resource planning and allocation, ensuring that the right people with the right skills are available to contribute to the project's success. One important project management tool is Jira. Jira is a widely used project management tool developed by Atlassian. It is designed to help teams plan, track, and manage their work in an agile development environment. Jira is highly customizable and supports various project management methodologies, including Scrum, Kanban, and traditional waterfall approaches. Automation is the base of DevOps, and scripting is crucial for tasks like configuration management and deployment automation. An operating system acts as a link between the user and the hardware of a computer. Since the majority of servers run Linux OS, Linux is a very important scripting tool used by a DevOps engineer. Monitoring. Monitoring is a critical aspect of DevOps practices, playing an important role in ensuring the reliability, performance, and availability of software systems. Monitoring provides real-time insights into the performance of applications and infrastructure. Early detection of issues such as system failures, errors, or performance degradation allows teams to respond before users are impacted. Nagios. Nagios is an open source monitoring tool that is used for tracking the availability, performance, and health of IT infrastructure components. Originally developed in 1999, Nagios has become a popular choice for organizations seeking a solution for monitoring their systems, networks, and services. So Nagios has server agent architecture. The Nagios server is installed on the host and plugins are installed on the remote hosts or servers, which are to be monitored. Nagios sends a signal through a process scheduler to run the plugins on the local remote host servers. Plugins collect the data and send it back to the scheduler. Plugins are responsible for determining the status of the monitored resources. Then the process schedule sends the notifications to the admins and update Nagios GUI. Nagios provides a web-based user interface that allows administrators to monitor and manage their entire system. The web interface provides a dashboard, detailed views of hosts and services, as well as reporting and configuration capabilities. Prometheus. Prometheus is an open source tool providing transparency, flexibility, and ability for users to inspect and modify the source code. Prometheus is considered a DevOps monitoring tool because it is designed to monitor and collect matrices from various systems and services in a dynamic and containerized environment. 𝐓𝐫𝐸𝐴𝐵𝐸𝐺. 𝐓𝐓𝐵𝐸𝐺 is an open source monitoring system designed for tracking and managing the performance of IT infrastructure components. It provides a comprehensive set of features for monitoring servers, networks, applications, and services in real time.
We have just covered the tools used in DevOps. Finally, in the DevOps interview questions, you will prepare for common questions asked in DevOps job interviews.
DevOps, a combination of development and operation, is a set of practices that aims to improve and automate the collaboration and communication between software development and IT operation teams. The primary goal of DevOps is to streamline the software development and delivery process, enabling organizations to deliver high-quality software more rapidly and efficiently. And who are DevOps engineers? A DevOps engineer is a professional who combines expertise in software development and IT operations to streamline and improve the software development and delivery process. DevOps engineers play a crucial role in implementing DevOps practices within organizations, bringing the gap between development and operation teams to achieve more efficient and reliable software delivery. And now, how can you become a DevOps engineer? So it's all about continuous learning. Start with a strong foundation in areas like software development and system administration. Learn key tools like Git, Jenkins, Docker, and Kubernetes. Certification can also help you stand out. Now, let's get started with the beginner level DevOps interview questions. And the first question is, what is DevOps and why it is important? Since we have already went through what is DevOps, let us understand why it is important. So DevOps is essential for organizations aiming to stay competitive by delivering high-quality software faster with improved collaboration, automation, and a focus on customer feedback and security. And the next question is, name the core principles of DevOps. Collaboration, automation, customer-centric action, responsibility throughout the lifecycle, database decision-making, and constant improvement. And the next question is, which are the top DevOps tools? And the top DevOps tools are Jenkins, Docker, Ansible, Puppet, Chef, Git, Selenium, and Terraform. Up next we have, what are the different phases in DevOps? The different phases in DevOps are plan, code, build, test, release, deploy, operate, and monitor. The next question is, how is DevOps different from the Agile methodology? DevOps and Agile are complementary methodologies with different scopes and focuses. So first, DevOps focuses on the entire software delivery pipeline and involves both development and operation teams aiming to automate and streamline processes. Agile, on the other hand, focuses on the development phase, emphasizing iterative development, customer collaboration, and flexibility within the development team. So both methodologies seek to improve software quality and customer satisfaction, but address different aspects of the development process. Next, explain CI and CD. CI stands for continuous integration. So it is a process of frequently and automatically integrating code changes made by different developers into a shared repository. And each integration triggers an automated build and a series of tests to catch and fix issues early. And CI ensures that the code base is always up to date and working smoothly. Whereas CD stands for continuous deployment. It's the automatic deployment of code changes to production or staging environments after they pass the CI process. CD ensures that the new features and bug fixes can be efficiently and reliably delivered to users, often without manual intervention, while maintaining a high level of quality and stability. And the next question is, name some popular config management tools. And the tools are Ansible, Puppet, Chef, SaltStack, CF Engine. The next question is, what is infrastructure as code? Infrastructure as code is a practice in DevOps and IT operations that involves managing and provisioning infrastructure resources using code and automation. Instead of manually configuring servers, networks, and other components, IAC treats infrastructure setup and management as if they were software. In short, instead of setting things up manually, you write scripts that tell the computer how to do it automatically. So this makes it easier to control, change, and replicate your infrastructure, like creating a copy of a setup exactly as it was before. And the ninth question is, what is the role of AWS in DevOps? In DevOps, AWS play a crucial role by offering cloud infrastructure and services that allow teams to automate provisioning, scale resources dynamically, and implement serverless and container solutions, all while streamlining CI/CD pipelines and providing robust tools for monitoring, security, and compliance, making it a go-to choice for managing databases and facilitating global deployments, while also offering seamless integration with an extensive ecosystem of DevOps tools. Next, name 3 important DevOps KPIs. The 3 important DevOps KPIs are deployment frequency, lead time for changes, and mean time to recovery, that is MTTR. Next, explain automated testing in CI/CD. Automating testing in CI/CD means using automated tests to check code changes for issues and quality as they are integrated and deployed. It's a quick and consistent way to catch problems early, maintain code quality, and ensure reliable software release. Up next we have explain Jenkins pipelines. Jenkins pipelines is a powerful feature of Jenkins, an open source automation server. It allows you to define and automate the entire software delivery process as code, making it more flexible and easier to manage. In other words, Jenkins pipelines offer a way to define, automate, and manage your software delivery process in code, providing flexibility, repeatability, and scalability to your CI/CD workflows. Next, what is configuration management? Configuration management is a systematic process that involves identifying, documenting, controlling and tracking changes to various components of a system or product to maintain its consistency, reliability, and integrity over time. And the next question, what are the benefits of using version control systems like Git in a DevOps environment? Version control systems like Git benefits DevOps by enabling collaboration, versioning, continuous integration, rollback, code quality control, documentation, branching, security, portability, and constant monitoring. They streamline development, improve code quality, and support DevOps practices for efficient and reliable software delivery. Next, what is the role of containers in DevOps? Containers in DevOps are lightweight, standardized packages that bundle applications and their dependencies for consistent and portable execution. They enable resource-efficient isolation, scalability, and rapid deployment, facilitating seamless automation and orchestrations in the software development and delivery process. Containers align with DevOps principles, enhancing efficiency and reducing deployment's complexities. Now, let's move on to the intermediate and advanced level DevOps interview questions. And the first question is, what is the blue-green deployment pattern? The blue-green deployment pattern is a deployment strategy used in DevOps to minimize downtime and reduce the risk of releasing new versions of an application. This approach involves maintaining two separate environments, typically referred to as blue and green, where only one serves as the active production environment at any given time. The pattern is executed as follows. The blue environment is the current production, green environment is new version, then testing and validation, traffic switching, and later ongoing monitoring. And the second question is, define shift left in DevOps. Shift left in DevOps refers to the practice of moving activities such as testing, validation, and quality assurance earlier in the software development process. Rather than conducting these activities mostly in the later stages or during deployment, shift left advocates starting them as early as possible in the deployment lifecycle. So this approach helps identify and address issues sooner, enhancing software quality, accelerating development, and reducing the cost and effort required to fix problems. It also emphasizes collaboration between development and testing teams with an increased focus on automation and continuous feedback to improve overall software development efficiency and quality. Next, how do you automate software builds? First, choose a build automation tool, followed by version control to store the source code and create a build script or configuration file. Set up continuous integration server like Jenkins, then configure your CI server to trigger a build. Use your build automation tool to manage project dependencies, and later ensure that the build environment is well defined and consistent. And after that, integrate automated testing and quality checks into your build process. After a successful build, your build automation tool should create an artifact such as executable files, libraries, or deployment packages. And finally, deployment. Next, we have why is continuous testing important for DevOps? So it is important because it identifies issues early, provides rapid feedback, ensures software quality, include automated regression testing, incorporate security and compliance check, reduce risk, accelerate releases, improve collaboration, support shift left, and optimize testing resources. And the next question is, explain the master-slave architecture of Jenkins. In the Jenkins master-slave architecture, Jenkins has a central controller called the master, and multiple worker mission refers to as slaves. The master is responsible for managing job scheduling, configuration, and storage of job definitions and build history. On the other hand, the slaves are worker missions that execute tasks. They run Jenkins agents which communicate with the master, receive job instruction, runs the jobs locally, and report the job progress and result back to the master. And the next question is, explain the two types of Jenkins with their syntax. Jenkins provide two primary ways to define and configure pipelines. They are declarative and scripted pipelines. Both are used to create CI/CD pipelines, but they have different syntax and approaches. So declarative pipelines are designed to provide a simpler and more structured way to define pipelines. They use a more human-readable and concise syntax, making them easier to read and maintain. And the syntax is, so in this example, a declarative pipeline is defined with 3 stages, that is build, test, and deploy. Each stage contains a series of steps to execute. Whereas the scripted pipelines provide more flexibility and are based on the Groovy scripting language. They are suitable for complex and advanced use cases but have more challenging learning curve compared to the declarative pipelines. So in this example, a scripted pipeline is defined using a node block. So inside the node block, stages are defined with explicit steps. Scripted pipelines provide more fine-grained control over the build process and can include conditional logic and custom functions within the Groovy. And the next question is, how to automate testing in DevOps lifecycle? So to automate testing in DevOps lifecycle, choose the right testing tools and framework, then integrate testing into your CI/CD pipeline, write and version automated test scripts, then manage test data and environments, enable parallel test execution, then provide real-time feedback and reporting. Later, encourage shift-left practices, continuously improve your testing process, and in result, automatic testing speeds up feedback, reduce defects, and enhance software quality and security. And the next question is, what are the key features of Docker and how it is used in containerization? The key features of Docker are easy and faster configuration. So Docker simplifies application configuration by packaging everything needed into containers, making it easier to set up and manage application. Next, ability to reduce size. So Docker uses efficient storage and layering, reducing image sizes and improving storage efficiency, so which is particularly useful for distribution and deployment. Next, increase productivity. So developers can work in consistent and isolated environments, speeding up development and testing cycles while reducing any issues. And then we have application isolation. So Docker containers isolate applications and their dependencies, preventing conflicts and ensuring that each application runs independently. Next, Worm. So Docker Worm is Docker's native clustering and orchestration solution for managing and scaling containerized application across multiple hosts. And then we have routing mesh. Docker's Worm provides built-in load balancing and routing for services running on a cluster, simplifying the setup of highly available applications. And then we have services. So Docker's Worm services allow you to define and deploy multi-container applications as services, making it easy to manage complex applications. And finally, we have security management. Docker offers various security features including user namespace, capability control, and image scanning to enhance the security of containerized applications. Next, discuss the challenges and best practices for managing secrets and sensitive information in DevOps. So the challenges are, first we have security. So keeping secrets safe from unauthorized access. Next, automation. So integrating secrets into automated processes. Next, access control. Managing who has access to the secrets. And then rotation. So regularly changing and updating secrets. And finally monitoring, tracking and auditing secret access. The best practices are use secure tools, no hard coding, role-based access, rotation, encryption, audit logs, education, and finally regular testing. And the 10th question is, explain the principle of site reliability engineering, that is SRE. SRE is a discipline development by Google that combines software engineering and IT operations to create a balance between reliability, availability, and efficiency in large-scale complex systems. The key principles of SRE are embracing risk. So understand and manage risk to balance reliability and innovation. Next, service level objectives. Set measurable reliability targets based on user expectations and work to meet or exceed them. And then we have toll reduction. Automate repetitive manual tasks to reduce human errors and free up time for strategic work. And next we have monitoring. Implement robust monitoring to detect issues and understand system behavior. And the next key principle is release engineering. So collaborate to ensure stable, non-disruptive releases and deployments. Next, automation. So automate routine tasks for consistency and efficiency. And finally, simplicity. So keep systems simple to reduce complexity, which can lead to increased risk. And the next question is, how will you secure Jenkins? Some best practices for securing Jenkins include access control. So use strong passwords and set user permissions. Next, server security. So keep Jenkins and its plugins up to date. Limit physical and network access. Then, plugin and build security. So update plugins regularly and isolate builds in secure environment. And then, configuration and secrets. So review and protect job configuration. Safely store secrets using the credentials plugins. And then we have backup and monitoring. So backup Jenkins data and set up logs and monitoring. Then secure communication. So use HTTPS and SSL certifications. And then API tokens. Use API tokens for programmatic access. Then security testing. So integrate security tests into your CI/CD pipelines. The next question is, explain the difference between git fetch and git pull. So git fetch is used to retrieve changes from a remote repository without merging them into your local branch immediately. And after a fetch, your local branch remains unaffected and doesn't automatically update to reflect the changes from the remote repository. And then fetching separates the process of retrieving changes from the remote repository and integrating them into your local branch. It's a safe way to see what's new without affecting your local work. And then comparison. So fetch allows you to compare your local branch with the remote branch to understand the difference before deciding whether to merge or rebase. And best practices, often used in combination with git merge or git rebase to update the local branch with the changes retrieved using the fetch. Next, git pull. The pull concept. Git pull combines the fetch and merge actions into a single command. So it retrieves changes from a remote repository and immediately merges them into your local branch. And then after a pull, your local branch is automatically updated to include the changes from the remote branch. And then git pull is more convenient for quickly updating your local branch but may potentially lead to unexpected merge conflicts if not used carefully. And then less control. It provides less control over when and how the changes are integrated into your local branch compared to git fetch. And finally, the best practices. Generally used for simply updates and when you are certain that merging the remote changes won't lead to conflicts or issues. Next, explain some basic git commands. First we have git init. So initializes a new git repository in the current directory, creating a hidden .git directory to store repository data. Next, git clone creates a copy of a remote repository on your local machine, allowing you to work with the project locally. Next, git add. So stores changes for commit. You can specify individual files or directly to stage. Next, git commit message. Commit stage changes with a descriptive message to the repository history. Then, git status displays the status of your working directory, showing which files are modified, staged, or untracked. Next, git log shows a history of commits, including commit messages, authors, dates, and commit hashes. Then, git branch lists all the branches in the repository, indicating the current branch with an asterisk. And then we have git checkout. So this changes to the different branch or a specific commit. You can create a new branch by specifying its name. And then we have git pull. So this fetches changes from a remote repository and merges them into the current local branch. And finally we have git push. Sends your local commits to a remote repository, updating the remote branch with your changes. Up next we have mentioned some of the useful plugins in Jenkins. Some useful plugins commonly used in Jenkins are Blue Ocean. So provides a modern user-friendly interface for creating, visualizing, and managing Jenkins pipelines. Next, Git plugin. So this integrates Git version control with Jenkins, enabling the automatic triggering of builds on code commit, branch management, and Git-based project configuration. And then we have Docker plugin. So this allows you to build, publish, and manage Docker containers as part of your Jenkins pipelines. And then we have pipeline plugins. Facilitates defining and managing complex, multi-step build and deployment pipelines using the pipeline domain-specific language, that is DSL. And then we have HTML Publisher plugin. So publishes HTML reports generated during builds, making them accessible through the Jenkins interface. Next, Maven Integration plugin. So streamlines the use of Apache Maven as a build tool, making it easy to build, test and deploy Maven projects. Next, Jira plugin. So provides integration with Atlassian Jira, allowing you to create issues and update Jira issues directly from Jenkins jobs. And finally, we have Amazon EC2 plugin. Enables Jenkins to dynamically provision and manage Amazon EC2 instances as build agents to handle job workloads. And the next question is, how do you go about creating a backup and duplicating files in Jenkins? Creating a backup and copying files in Jenkins is a straightforward process. To create a backup of your Jenkins configuration, you need to periodically back up your Jenkins home directory. So this directory contains critical components such as your build job configuration, slave node configuration, and build history. So to perform a backup, simply make a copy of this directory. If you want to copy specific job configuration or replicate a job, you can do so by copying the respective job directory. So this allows you to create duplicates of jobs or change their names if needed. And with this, we have come to the end. I hope you have enjoyed the video, and if you did, make sure to like and subscribe to our YouTube channel. Thank you for watching and keep learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!